Hi, good morning all. Welcome to PSM Final NEET PG Dash. So this is by Medico. I'm Dr. Sumna, your PSM faculty. So your NEET PG is almost around the corner. We have exactly 20 days, and today I'm going to help you with the one of your biggest subjects, but a high yielding subject, which is PSM. Okay. So today's class we'll be discussing it under 10 segments. Okay. So after covering all these 10 segments, I'm sure you'll be able to cover at least 70% of the questions that are going to be coming in your NEET exam. So let's start. So the first segment will be confusion or concepts corner. Here we'll be discussing the most important concepts in epidemiology and biostatistics, which are often found to be very confusing for the students, and students tend to skip or just try to by heart. Okay, so we're going to the first question. So the first question is, a survey was made to assess malnutrition among children. 100 children from rural area and 100 from urban area were taken. 30 from rural area and 20 from urban area were found to be malnourished. Which test can be used to find out if this difference is significant? So what are they asking you, or what is this question all about? See, we are going to discuss something which is very important and very commonly asked, that is your tests of significance. Okay. So what do you mean by tests of significance? You see the options here, right? Chi-square test, pair t-test, student t-test, ANOVA test, and there are many more. All these together are called as the tests of significance. So what do you mean by that? See, whenever you do a study, we cannot do a study in the whole population, right? So we take a sample from the population and we do a study. Maybe we are trying to compare two groups and the difference between the weight of girls and boys, something like that. So we do the study in a sample population, and then the results we get, we are saying that okay, this result will be almost correct for the whole population. That is, we are trying to extrapolate our result in the sample to the whole population. But when we do study, sometimes we get results just because of chance. There might not be anything significant, but just because of chance, you can get a result. So to see whether what you got actually is true or not, or whether the result you got in your study is statistically significant or not, for that we use something called the test of significance. Okay. So test of significance, first point is, it is used for comparing two or more sample or groups. Okay. And second one is, so what is the use? Whether we are seeing whether the results you got in your study is actually true or not, or in other words, is actually significant or not. It's actually statistically significant. Okay. So before we go to the answer of this question, we just need to know a few things about test of significance and which test to use in which situation. So basically, you have two types of tests under test of significance. You have parametric test and non-parametric test. Okay. So that's the first concept you have to learn. So here we have something called parametric test and non-parametric. Okay. First point, in what distribution you have to use which test. So parametric, always remember this ghost here I've put. Ghost is something that is paranormal, right? Paranormal activity. So always remember the word paranormal. So parametric is always used for normal distribution. Okay. So parametric, first point, it is used for when you have data that is normally distributed. So obviously non-parametric test will be used for non-normal distribution, right? Or other words, you can say skewed distribution. So first point is parametric for paranormal, parametric for normal distribution, and the non-parametric for your non-normal distribution. Second is, what is the type of data, whether it is quantitative or qualitative. Usually normal distribution we get quantitative data. So parametric test is used when you are comparing quantitative data. So obviously non-parametric is for your qualitative. Okay. So since it is quantitative data and parametric text, what will be getting in the question? The data will be expressed in terms of mean, right? So here you get mean plus standard deviation will be given, or standard error will be given. So for qualitative data, how do you express? It can be expressed as percentages or proportions or maybe fraction. Okay. So normal distribution parametric, non-normal is non-parametric. Here you have quantitative, this side you have qualitative data, and parametric is for mean standard distribution data, and the other one you express in terms of percentage, proportion or fraction. Now, out of all the tests, you have to remember three names which are examples for parametric test. Okay, rest whatever test is coming is a non-parametric test. So how do you remember parametric test? For that, remember PAT, parametric test. Three examples starting with P, A and T. P for your Pearson's test, or more correctly it is Pearson's correlation test. Okay. A for your ANOVA and T for your T-test. So PAT, Pearson test, ANOVA test, T-test. These are examples of your parametric tests. Whatever test other than these, that can be your chi-square test, your Spearman test, there are many other tests. All these will be coming under your non-parametric test. Okay, I hope this much is clear to you. So now, next thing is I'll just to show you a table of all the parametric and non-parametric tests used in these different situations. The table is like this. See, you have groups, you have type of variables, you have different types of tests. So how do you remember or summarize this table? We have 3 easy steps for that. Okay. So whenever you get a question asking for which is the type of test, follow these 3 steps. First step, check how many groups are being compared, whether it is 2 or more than 2. If I'm comparing girls and boys, I'm comparing 2 groups. If I'm comparing 3 classroom of students, class A, class B, class C, I'm comparing 3 groups, right? So first step is see how many groups are being compared, whether it is 2 or more than 2. Okay. After that, next step is see what type of data you're comparing, whether you are comparing quantitative or qualitative. In other words, whether they are expressing it in terms of proportions or mean. So here we have 2 superstars in the on a screen who will help you remember these. Okay, remember PC for Priyanka Chopra and MT for Mammootty. Okay, so PC Priyanka Chopra, P for C. That is when you have a test which is having proportion, your test will be starting with C. So it can be either chi-square, most of the times it's chi-square test. Otherwise, you have something called a Cochrane's test. Okay. So if it is a proportion, you have PC Priyanka Chopra proportion for C. Test starting with C, mostly chi-square, and in one particular situation, it's Cochrane's test. Okay. So another thing is your MT. Okay. Here, if you have a test starting where the means are compared, or for mean, MT is for means are compared, you have a test starting with T, that is T test. It can be paired or unpaired, but now remember mean T test when you are comparing 2 groups. Okay, for MT, mean T test. Then, but in case if there are more than 2 groups, this MT doesn't hold. Here you have ANOVA test if there are more than 2 groups. So PC, Priyanka Chopra and MT Mammootty. P for proportion, test starting with C. If it's a mean, it's T test. In case of 2 groups, more than 2 groups, you have ANOVA test. Fine. Next is, so 2 steps have been over. Third step is you have to see whether the groups are independent groups or related group. What do you mean by independent group or what is related group? See, when you're comparing 2 different groups, I'm comparing boys and girls. These are called independent groups. Okay. In related groups, you can say it is actually there is only one group, but you are comparing it as before and after. Maybe before the treatment, this was the data. After the treatment, this is the change. So before and after comparison is your related groups. Okay, so these are the 3 steps. How many groups are there? First, you check that. Second, you see whether it's a proportion or mean. Then remember PC and MT. Third is whether it's independent or related groups. Fine. Now we'll see how do you find out the test. Okay, so this is a table. So here you can see a bigger table. First, focus on this part, this much of the table. Okay, till your parametric test, because this is what is most commonly asked. So this much part at least you should know it. Non-parametric test you might get, but most probably you are going to get a parametric test in your question. So, what was the first step? You say whether there are two groups or more than two groups. See this two. Here, up to this part, this table is showing two groups, okay? If it's more than two group, you have the lower part of the table. So if it is two groups, second one is, so now first I'm focusing only on the two groups part. So if it's two groups, second, what was the step? Whether it is a percentage or a mean in your question. So if it is percentage, see, if it's percentage, you always go for a test starting with C, which is your chi-square test, okay? Again, two independent group or related group, whatever it is a chi-square test. Here also percentage I can see chi-square test. But when there are more than two groups, if it is independent, you actually go for the chi-square test. But more than two related groups, you have something called a Cochrane's Q test. This is the only place where it's not a chi-square test, it's a Cochrane's Q test. Otherwise, for percentage, usually you have a chi-square test. Similarly, if it is M, that is two groups, mean you are going to see, then what is the test? In case of mean, you go for a test which is having a T, MT, Mamuti, right? So T test, you have T test here. Can be either student T test or a pair T test. But mean with more than two groups, you go for ANOVA test. Fine. So next is, what is the next step? Whether to see whether the groups are independent or related. See, in case of PC, Priyanka Chopra is always constant. There is no change. Whether your group is independent or related, you have a test starting with C. Okay. So here it's chi-square test in independent groups, related groups also chi-square test. More than two independent groups, you have chi-square, but more than two related groups, you have another test with C, which is Cochrane's Q test. But in case of your mean, when the groups are independent, you go for your student T test, okay? But when the groups are related or they are actually before and after, that is they are paired, then you go for a pair T test, fine? And when there are more than two groups, for me, you take the ANOVA test. So this is how you remember your tests of significance. Whatever I've told now is the parametric test. Similarly, you have a non-parametric counterpart, okay? Non-parametric counterpart in case when you get a distribution which is not normal. So here, in case of your non-parametric, if this is becoming too much for you, you can, if not possible, at least try to remember till the parametric test, okay? So still I'm telling the non-parametric part also. Here, in case of your PC is constant, I told you. Whether it's parametric or non-parametric, if it's a percentage, it's chi-square test in most cases. And more than two related groups, you have Cochrane's Q test. But in case of your, instead of your T test, you have a non-parametric counterpart. Here, instead of your student T test, for two independent groups of mean, you have something called a Wilcoxon's rank sum or Mann-Whitney U test. Similarly, here instead of your pair T test, then for non-parametric counterpart is your Wilcoxon sign rank. So when there is a T test, the counterpart is always the non-parametric counterpart is always a Wilcoxon test. Okay, so it can be either rank sum or it can be your sign rank. Okay. And for ANOVA, here if it is more than two independent groups mean, here you have Kruskal-Wallis instead of your ANOVA, and then you have another test that is Friedman test instead of your ANOVA in case of two related groups but a non-parametric distribution. Okay, so I hope your tests of significance are clear to you. Now we'll go back to our first question. What was the question? So the question was a survey was made to assess malnutrition among children. Okay, so basically they are going to find out the malnutrition status in children from rural area versus malnutrition status of children from urban area. So what are they actually comparing? First step, how many groups are there? Two groups, right? Children from rural area and children from urban area. And what are they actually comparing? That is the malnutrition status of children in rural as well as urban area. And what is it, whether it's a mean or a proportion? They're actually seeing proportion, right? Because they're saying, see, 30 from the rural area out of 100 as well as 20 from the urban area out of 100 had a malnutrition. That is, they are seeing the proportion or a fraction. So it is PC. Two groups, proportional fraction. Whether it is related group or unrelated, here it is unrelated group, right? Because it's completely two different groups. PC holds true. So your answer will be PC is chi-square test. So fine. So here your answer is chi-square test. This is how you get the answers for your test. So now I'll give you a few examples. where you have to tell me what is the type of test used. Okay. First one, you are checking the albumin status of dengue patients, okay, before and after treatment. So I'm telling the mean albumin status, the albumin value of dengue patients before treatment was somewhere around 3.2, and after treatment the mean albumin value was 3.5. I want to see whether this is statistically significant or not, which is the test that I'm going to use here. So in this case, you see how many groups are there? 2 groups. What am I comparing? Mean. So it is MT. So I have to use a T test, right? Which T test should I use? You see the groups whether it is independent or related. It is before and after. That means it is related. In this case, the T test you are going to use will be your related or your paired T test. Okay. This is how we are going to do the test. Second question. I want to compare the percentage of intake of IFA tablets among ANC women during their pregnancy versus incidence of low birth rate among their babies. Okay, so I have 2 groups here, and which is the test of significance. So in this case, I am having 2 groups. Okay, one group where IFA intake is adequate, there is a good percentage of IFA intake. Another group where there is a lesser percentage of IFA intake, and I want to see the incidence of low birth weight in both these groups. So again, I have 2 groups here. Number of groups is 2, but is it mean? No, I'm comparing the percentage or the proportion of how many of the IFA, that is IFA also I'm telling in terms of percentage of proportion, as well as the incidence is also you're telling it in terms of rate, right? So in this case, which test is used? So you have 2 groups, you have P, here you go for PC or you go for your chi-square test. Okay. So just like this, following these 3 rules, you will be able to find out all the name of the tests. I hope this is clear to you. Now let's move on to the next question. There's a technical error. Let's just take a short technical break. അതിൻ്റെ സ്ക്രീന് പോയി. ഞാൻ ടെക്നിക്കൽ ബ്രേക്ക് എന്ന് പറഞ്ഞിരിക്കുക, കട്ടായിട്ടില്ല. നിങ്ങളാരും വിളിക്കാനും പറ്റുന്നില്ല, മറ്റേ സ്ക്രീൻ ഓഫായിപ്പോയി. So we are back. So taking up the second question. The question is, mean value of marks in a distribution of 100 students in a class is 105 and standard deviation is 10. How many students will have their marks in the range 85 to 125? Okay. So here what they have given? They have given you the mean, right? How much is the mean? Mean distribution of 100 students is 105. And you have the standard deviation which is 10. And they have asked us this 80 to 85 to 125, how many students will be there in that range. So when you see mean plus minus 1 standard deviation, how much will you get? You will get minus 10 plus 10, that is 95 to 115. This is your mean plus or minus 1 standard deviation. So within 1 standard deviation, 68% of the value lies within mean plus or minus 1 standard deviation, right? Similarly, here when you see mean plus or minus 2 standard deviation, that is your 105 plus or minus 2 into 10, which is 20, that will give you 85 to 125, which is your question, right? So mean plus or minus 2 standard deviation, how many percentage of the values will lie, or what is the confidence interval we say? It is 95%, right? So the answer here is option C, that is 95%. Okay. Now, if they have told mean plus or minus 3 standard deviation, it would be 99.7%. Okay, now what is this plus or minus standard deviation? What is this, 95% CI or 68% CI? What does it mean? Okay, we'll just see it in this, with this diagram here. What you see on screen is your normal distribution curve, right? So here in center, you have the mean, and towards both sides, you have the 1 standard deviation, 2 standard deviation, and 3 standard deviation. So here, I'm just marking this much part, okay? So when I say 1 standard deviation, it is mean plus or minus 1 standard deviation. That means, and the confidence level for that is 68%. This is CI for mean plus or minus 1 standard deviation. Similarly, for 2 standard deviation, that is what was asked in your question. Here, so from this to this, if I'm taking mean plus 2 standard deviation minus 2 standard deviation, this much area, you have your 95% of your CI. What does it mean? What does this mean, this 95% CA? See, the meaning is, it's the interval where 95% of your values are lying. Okay. When I say the 95% CI in this case of your students is between 85 and 125, that means out of the 100 students in this class, 95% of the students will have a mark between 85 and 125. Okay. So what is the interpretation of a 95% CI? It means it is the interval within which 95% of the values in a normal distribution would be lying. That is what I mean by 95% CI. So in this case, your 95% CI was, in your question, it was 85 to 105. That means 95% of marks in this particular population will be between somewhere around 85 to 105. Okay. So that is the meaning of 95% CA. 95% of the times the value will be in that particular range. But there is a 5% left, right? It's 95%. So outside you have a 5%, that is 2.5% towards this side and 2.5% towards this side. That means 2.5% is that those are the values which are outside your 95% CA, outside this 85 to 105 range. Okay. Next thing, what would you like, whether a narrow CI is good or a bigger or a wider CI? See, always a narrow CI is good, right? Because that is more precise. When you ask me what is the mean value of hemoglobin of all the students of a class, if I say it is somewhere between 5 and 15, that's quite a big range. That's not a precise one. So that doesn't give much of a data, right? But instead, if I say the mean value of hemoglobin in this classroom is between 8 and 11, that means it's a narrower CI. So which is more precise, you get a better answer. So always we opt a narrow CI. But how to get a narrow confidence interval? You get when your sample size is more. Okay. When your sample size is more, that means your CI will be narrow. Similarly, smaller your ST, standard deviation, your CI will be narrower. Okay. Now we are moving on to the next question. What you see on the screen, you see a graph, you see an image which is called a box and whisker plot, right? So the question is, match the following box and whisker plot images with their distributions. You have 3 box and whisker plot images and the options are positive skew, negative skew, normal distribution. Okay. So what is actually a box and whisker plot? So box and whisker plot is nothing but a way of, representing or illustrating your data in a pictorial form or in a graphical form. Okay, so this is what you call by a box and whisker plot. There's a box and there are whiskers. And what does this mean? The box, the center value of the box, this is your median. And then you have the first quartile and the third quartile values. And both sides will show the smallest value in that data set, and this side will be the greatest value in that data set. And the difference between that, or this shows your range. Okay, so you have 3 types of distribution. You can basically you have 2 types of distribution. That is, one is normal and another one is non-normal distribution. Under non-normal, you have a positively skewed distribution and a negatively skewed distribution. Okay, so these can be shown in the form of box and whisker plot as well as your curves. So you can see here, see this the center one you see here, it is a normal distribution. In a normal distribution, it's a bell-shaped curve where mean, median, mode, everything is the same. But when you have another curve, okay, if it's a skewed distribution, you don't get mean equal to median equal to mode, doesn't hold there in a skewed distribution. And always in any graph, the highest point will be the peak of the curve. Peak of your curve the peak of your curve will give you the mode. Median is always the middle point, right? Middle is your median. And the tail is your mean. Okay, always remember the tail part of the curve. You see here, this is the tail here, right? This is the tail here. The tail part shows the mean, and the highest point or the peak will be always the mode. Okay, and the median is always the central part. So with the help of this tail, you can say whether the distribution is right skewed or left skewed. Right skewed is also towards the right side is positive skewed, towards the left side is your negative skewed. Okay, so you see this in symmetrical distribution, there is no skewing. So in your options here, which one is the symmetrical one? The first one. There is no tail, nothing, there is no skewing. The thing is coming in the center. Both the squares are of both the rectangles are of the same size. So your this first diagram will be your normal distribution, right? But whereas in the positive and the negative skew, that is the right and left, you see the direction of the tail. Okay, see here in this diagram, the first one, the tail is towards the right side or towards the positive side. Hence, it is a positively skewed. Similarly, in the box and whisker, you see the tail is this one. The whichever one is the bigger part, that is your tail. So that is your positive skew. Okay, and in this one, in the last image, you see the tail is towards the negative side or towards the left side, and this is again towards the left side. So this is your negative skew. This is how you identify whether the data is normal distributed, positively or negatively skewed. Okay, so with that, your answer here will be option C, which is 1 is a normal distribution, correct? 2 is a positive skewed here towards the side, and 3 is a negatively skewed. Fine. Okay. Now we'll move on to the next question. Value of one parameter can be estimated from related parameter by means of option A, bar chart, then you have correlation, then you have scatter diagram and regression. Okay, so what is that thing that helps you to predict the value of the one variable with the help of another variable, or what helps you to find out the value of one parameter from another parameter? It's not just a relationship, you want to say the value. So in this case, the answer is your regression. Okay, regression is the test, or regression is the method which helps you to predict the value of your dependent variable from your independent variable. Okay, what is bar chart? Bar chart is just a graphical representation of data where you represent qualitative data. Okay, so we'll just see the other options here also. The answer here is regression, but we'll just see the other options. Bar chart is a method of representing your qualitative data, right? Bar chart, you know, there is gaps, right? Between the bars you have gaps. This is a simple bar chart. There is a similar thing which looks similar to bar chart, but there are no gaps, something like this. This is your bar and this is your histogram. Bar chart, I told, is used for qualitative data, whereas your histogram is used for quantitative data. Okay. That's about the first option. Then what is a scatter diagram? Scatter diagram is nothing but your relation between two variables you are showing in forms of dots. If you're plotting the relation between weight and height, you're showing it in form of dots. Usually in correlation, we use a scatter diagram. So that's a form of a diagram. Then you are left with two options, correlation and regression. You know, both these help to find out the relationship between two variables, x and y. So what is the difference between correlation and regression? We'll see in detail, okay? So correlation, you have two variables, variable x and variable y. Usually towards the y-axis, we write the variable which is dependent. Y-axis, you have your dependent variable, okay? And x-axis, you will plot your independent variable. So, by correlation and regression, you want to find the relationship between your independent and dependent variable. But correlation just says the relationship, whether with one variable, the other one is increasing or not, and what is the direction. If one is increasing, the other one is increasing, and what is the strength? How much is it increasing? Whereas regression helps you to predict the value. That is, if x is equal to this much, then y is equal to this much. That prediction comes from your regression, okay? So first, we'll write the points regarding your correlation, okay? So correlation, first point, it shows the relationship between two quantitative variables, right? So when I say relationship, it can be two things. It can be either strength of the relationship and also the direction. So your correlation shows the relationship between two variables in terms of the strength and the direction. How do you say correlation? You have something called as the correlation coefficient, right? Correlation coefficient, which you represent as R. Can be plus R or minus R. Okay. So when I write the correlation coefficient, now for example, I'm writing it as plus R. It can be plus 1 or whatever value. Usually the value is not whatever, it is between minus 1 to plus 1. The range is usually can range from minus 1 to 0 to plus 1. That is your range of the correlation coefficient. So here you see two things, right? You see a sign and you see a number. Okay. The sign will show you the direction. That is, if x is increasing, y is increasing or decreasing. If the height is increasing, whether the weight is increasing, or when height increases, whether weight is decreasing. So that thing between that is, if one variable is increasing, what is the direction of change of the other? That you get by the plus sign, plus or minus, whatever the sign. The value will give you the strength. Okay. You can say whether it is a good correlation or a mild correlation, like that. It gives the strength of the association. Okay, that is your correlation coefficient. So one gives the direction, the other gives the strength. Usually, we say if the value is somewhere between 0 R and 0.3, you have a weak positive correlation. Okay, if it is between 0.4 to 0.6, you have something called a moderate. If your R value is more than 0.7, then you say it is a strong correlation. Okay. And if it is 0, that means there is no correlation. And correlation coefficient, this is just an extra point. Here you have two types of correlation coefficient. One is Pearson's correlation coefficient. Similarly, you have the counterpart, which is your Spearman's. Pearson is, we have already studied under parametric test, we have studied this name, right? PAT for parametric, Pearson, ANOVA, and t-test. So Pearson is your parametric part, whereas the counter non-parametric part is your Spearman's correlation coefficient. Okay. So this is about correlation. Now what is regression? We have been talking about correlation for so long. Now we'll talk a few things about regression. Okay. Regression, the first point is it is used to predict the value of your dependent variable based on the value of your independent variable. That is the first point about regression. And regression is usually expressed as y equal to a plus bx. What is this? You have studied it in maths, right? This is the equation for a straight line. So this is how you get regression. So if I know x, which is the independent variable, I can easily calculate the value of y, which is the dependent variable. That is the advantage of regression over your correlation. Okay. Again, just like in correlation, here you have something called a regression coefficient also. Here, when I said y equal to a plus bx, this b is actually your regression coefficient. A is a constant. Okay. Now, simple example to tell you this. If I say the relationship between study hours and the exam score, how much hours you spend for studying per day and your exam score. If I say if you study more, you get more exam scores, just that much. I'm just telling the relationship, that is a correlation. But if I say if you study this much hours, you get a score of 500. If you study for 10 hours, you get a score of 550. So I'm predicting the score with respect to your number of hours of study. That becomes regression. Okay. Now, these are different types of correlation. Based on correlation coefficients, there are different scatter diagrams where we are plotting the relationship between two variables. So, one, it's not that clear. I'll just zoom it. Okay. So you have something called positive correlation and negative correlation. When R is in the positive side, if it's with the positive side, these are all positive correlation. The picture 1, 2, 3 both show positive correlation. In the first one, the R is 1, or the dots are very much close to each other. So that's a perfect positive correlation. The second diagram you see here, R is 0.8. Again, it's a strong positive correlation. Third one, R is 0.5. It's comparatively weak than the other two. Okay. You see the last diagram here. Here there is no correlation. The correlation coefficient is 0. That means there is no correlation. Everything is scattered. You cannot define a relationship between x and y. Okay. Other three diagrams, you see the direction is opposite. There's a negative minus sign here. Okay. That is when one is increasing, the other variable is decreasing. So these are all negative correlation. Just like the above, you have a weak negative correlation in the first one. Second is a stronger negative correlation with R of minus 0.8. And you have a perfect negative correlation when R is minus 1. Okay. So this is in general about regression and correlation. Fine. Now we'll move to the next question, which is about your sampling methods. Okay. So the question is, simple random sampling provides least number of possible samples, equal chance to each for collection to certain number of a sample, picking every 5th or 10th at regular interval. Sample represent the corresponding strata of the universe. Which is the correct option for simple random sampling? Any answers? Okay. Nobody has answered yet, so I'll give the answer also. The answer is option B. You know what is simple random sampling? It's just like a lottery method. Okay. There are so many people, you're putting them all together, you're taking the lottery. That's everybody has equal chance of being selected in that lottery method, right? So simple random sampling is where there is equal chance to each for collection of certain number of a sample. Everybody has the equal chance. That's a simple random sampling. Now, what are the types of sampling? Quick revision. Sampling, you have two types, right? You have a random sampling. Okay. If one is random, definitely the other one is non-random. So you have random sampling and non-random sampling. Other names, for random sampling, you also call it as a probability. Probability sampling. So non-random is your non-probability sampling. Sometimes non-random is also called as purposive sampling. Okay. So your random becomes non-purposive. We'll quickly see all the sampling methods. So I have two slides here. One is all this is simple random sampling, systematic sample, stratified sample, cluster sample. All these are examples of your probability or your random sampling. Okay. So 4 types of random sampling can be simple random sample, where you can remember it as a lottery method, right? Everybody has equal chance of being selected. That's one of the best sampling methods we have. But what is the issue? You should have the line list. You should know the whole population. Only then you can do a simple random sampling. You should have the list of all the people in that sample. Then you put their names and you take the lottery. It's just like that, right? So you should have the whole list. That is the issue with your simple random sampling. We'll just write down the important points of each sampling. So first one, simple random sampling. You can remember it as the lottery. Okay, that is actually one of the methods only, but that's for ease of remembering. You remember it like that. Everybody has equal chance of being selected. But the thing is, since you need a line list of everyone, it is applicable only for small, homogeneous, and readily available groups. If it's a very big group, if you don't know what are there in the group, you can't do a simple random sampling. That is the first method. Second one is your systematic sampling. Systematic sampling is where every kth person, that's either every third person selected or every fifth person selected. That is an example of your systematic sampling. Okay. So systematic sampling, you have every kth unit chosen. So another one here is your stratified sample. So simple random and systematic sample is over. Now we'll discuss about this stratified sampling. So when is that stratified sampling done? I told you simple random sampling is done in a homogeneous population. But when the population is heterogeneous, there you have to apply the stratified sampling. So when the population is heterogeneous, first step is you make it homogeneous. Try to make it homogeneous by making them into different strata. If it's a mix of males and females, you try to stratify them according to male, female. And then from males, you choose a particular number, and from females, you choose a particular number of people. According to that, your distribution of their size, how many males are there, how many females are there, based on that ratio, you choose. So that is what you mean by stratified sampling. Just write it down here. So stratified sampling is non-homogeneous population converted. We are trying to convert it to homogeneous. Then what you do, that is by making strata. Sample is drawn from each strata by random. This sampling from strata you choose by random, okay? But in proportion to size. That is your stratified sampling, okay? Now what is cluster sampling is when you have to select groups instead of individual people. If you are studying in clusters, there you choose a cluster sampling. Again, cluster sampling is also an example of your random sampling or your probability sampling, okay? So cluster sampling, you see here, this is cluster sampling where you are choosing clusters. Instead of individual people, you are choosing groups of people, okay? So that is cluster sampling is done when units of population are clusters, simple, or groups. Famous cluster sampling example is your 30:7 cluster technique. Where is this used 37? This is used to check your immunization coverage. Okay. Right, to see what is the immunization coverage in a particular area, this method is used, that is 37 cluster sampling. That means 30 clusters, and from each cluster 7 kits are chosen. Okay, that is your 30:7 cluster sampling, and these kits are usually between the age group of 12 to 23 months of age, and then you check for the immunization coverage of these kits. So that is what you do in your assessment of immunization coverage. So remember, 13:7 cluster is an example for your cluster sampling. Okay. Now we'll come to your non-random samplings or non-probability samplings, okay? Under non-random samplings, these are the examples. Convenient sample is there, voluntary response is there, snowball is there, purposive is there. Convenient sample is according to my convenience. If I am the researcher, whoever is coming to me, if I, according to my convenience, I'm choosing. I go to a shopping mall, whoever I find, I give my questionnaire, complete and come back. That's convenience sampling. Okay. Purpose of sampling is according to my purpose. If this is my objective, these are the people I want to get to execute my questionnaire. So I purposively choose my study population. There is no random thing. So that is purposive sampling. Then you have something called a snowball sample. Where do you use a snowball sample? So you know what a snowball is, right? It, by the time from up it comes down, it accumulates more snow and it becomes a bigger one, right? Just like that, in cases of population which are difficult to access because of stigma or some issues, for example, in sex workers or in IV drug abusers. If I want to do a study in sex workers and if I ask all the sex workers to come to me, they won't do. No. So it is because of the stigma, everything. So what we have to do is you find out one person and then you ask what are the contacts, and then through that person you find out some other people. Then through the second people you find out the next set of people. So just like that, this is called your snowball sampling. So snowball sampling again is an important question. You see, you do this in case of difficult to access populations. Okay. Okay. Now let's move on to the next question. Next question is, a research is being conducted to find the association between aniline dye exposure and bladder cancer in workers who have worked in the industry for more than 20 years. Two groups were formed, one directly involved with dye handling, other consists of office clerk not directly exposed to the dye. Years of occupation noted from records. What type of study is being performed? Okay. This type of question is a short question. You will be given a scenario and you will be asked to say which is the type of study used. Okay. So we'll just see this question. Okay. What's given here in this question? So you have a study conducted to find out the, what are they going to find out? As we'll write that. So they are going to find out the association between aniline dye exposure and bladder cancer. So you have aniline dye exposure status on one side. You have exposed group and you have non-exposed group, right? You are choosing those who were directly involved with dye handling, that is directly exposed, and other group not directly exposed. So you have two groups here, and then you have, you're seeing about their disease status, whether they are developing CA bladder or not. This is your study. So see the direction of the study from where it is going. So here you have your cause, your exposure. So this study is progressing from exposure to outcome, right? So which is a study that progresses from exposure to outcome? That is definitely a cohort study. Okay. If the study was the other way around, if I have chosen cases and controls, cases who had CA bladder and controls who did not have CA bladder, that is diseased and non-diseased, and then I was trying to find out the exposure, whether the diseased were more exposed to the aniline dye or what about the non-diseased, what is the percentage of exposure in them. If that was the direction, that is from outcome to exposure, then my study design would have become a case control study. But in this case, they have started from the exposure to the outcome. So this is a example for a cohort study. And what type of cohort? You know, there are three types of cohort. You have a retrospective cohort, antispective cohort, and a prospective cohort. Prospective cohort is where the exposure has not occurred, the outcome has not occurred. You're standing here, then you're following up the person where first the exposure comes and then the outcome comes. In retrospective cohort, both have happened already, just like in this question. The aniline dye exposure and the outcome has already occurred. You're just doing a record. From the record, you're getting the data. Okay. So this is an example of a retrospective cohort. Okay. So now I'll just say what is the retrospective and prospective cohort and then we'll take a break. So I told you case control study is from cases and controls and you go to this is direction. From case to control, you go to your outcome. So that is a case control study. In cohort study, the direction is always from the risk factor, from the exposure to the outcome. See, when the researcher is here and both the risk factor and the outcome has already occurred, that is a retrospective or a historical cohort. But when the researcher is here and the risk factor and outcome are about to occur, not occurred till now, that's a prospective cohort. But if the researcher is somewhere here, risk factors occurred but outcome has not occurred, in that case I'm in the middle. In that case, it's an ambispective cohort. Okay. So now we'll take a short break. So welcome back. So that was about your study design. Just quick revision, we'll just classify all the study designs and then we'll move forward to the next question, okay? So you know your study designs, you basically classify them into two types, right? You have your observational and your experimental study. Under experimental, where the researcher is doing an experiment, so the interventions from the researcher side. Here you have all your trials. You have your RCT, clinical trials, field trials, etc. Under observational, you have two types again. You have your descriptive and analytical. So descriptive is just describing the situation. What is the burden of the disease? That much. That's your descriptive. So for that, you have examples of your case series, case report. These are all descriptive studies, okay? Then cross-sectional study. See, cross-sectional can be both descriptive or analytical. If I'm just finding out the burden of a disease, what is the burden of anemia? That is my simple study. That's a cross-sectional descriptive study. But along with that, if I'm going to find out the burden plus some of the factors associated, then it becomes a analytical study, okay? But mainly in analytical, we say two types of study, which are the cohort and your case control study. Plus, as I told, cross-sectional can be analytical also. Fine, this is just a classification of study designs. Quick revision, your observation or your descriptive study helps in hypothesis formation. Your analytical study designs are used in hypothesis testing. But to confirm your hypothesis, you have to do an experimental study, okay? Confirmation, okay. Now, cohort study, two famous examples of cohort study. One is your Framingham Heart study. Second one is your Dolan Hill study. With the second study is the one which found out the association between smoking and lung cancer. Okay, these are all examples of a cohort study. Cohort study always exposure to outcome and it has a follow-up time. That follow-up is the catchword there. Follow-up is always there in a cohort study. Okay. Now, so this is just showing the cohort study and case control study. We have already told. Some more points we'll just quickly say. In case of a case control study, you know it's a retrospective study, right? Retrospective. Then you go from deceased or non-deceased, that is cases and controls, to your exposure. Outcome to exposure is the one. Then usually you do case control for rare diseases. Then what is the issue with the case control study? One thing is recall bias because you are taking the history, right? Somebody had a disease, then you're going to asking them about the exposures, recall bias is there. Second one is you have to match the cases and controls, right? So matching is part of case control study and matching is sometimes difficult because it's difficult to find similar controls. So that these are all issues of a case control study. Now when I say cohort study, it is a follow-up study. There is a longer study, long-term follow-up is involved. Cohort studies, the issues, it's more costly, taking more time. But what's the best part of it? This study can actually give you risk, which cannot be got in a case control study. All the risk, your relative risk, your attributable risk, your population attributable, all these are the message of association in a cohort study. Whereas in case control, you were getting something estimate of a risk, which is your odds ratio. Okay. Then, if they are asking you, which is a study to find out the natural history of the disease, the best study design would be cohort because you have a long-term follow-up and you can actually study the natural history of the disease in a cohort study. Then, but issues with cohort study is just not just the cost and time. There can be, since it's a longer time, there can be people who are lost to follow-up or you can have attrition. Okay. So this is generally about case control and cohort. So what about your cross-sectional study? Cross-sectional study is also called as your prevalence study. Okay. Study everything, exposure, outcome, everything occurs at a time and you're just taking a snapshot and seeing what is the relationship between exposure outcome or not even the relationship, just the burden. Maybe what is the prevalence of this particular disease. All those are your cross-sectional studies. So it's a prevalence study and you take a snapshot, just like you take a photo. Okay. This is your cross-sectional study. Okay. Now, ecological study, what was that? All the studies we told till now, whether it is case control, cross-sectional, everywhere, the unit of study was a individual, right? Individual person was a unit of study. But in ecological studies, you are comparing populations. So, ecological study is also known as a correlational study. You're basically saying in terms of population, that is, there is more chocolate consumption in one region compared to in Switzerland, there is more chocolate consumption and there are more Nobel Prize winners. In India, we have lesser chocolate consumption, lesser Nobel Prize winners. So I'm just saying that increasing chocolate consumption can lead to more chance of getting a Nobel Prize. Something like this, that is, you're comparing the population, is an example for an ecological study. What is the issue with an ecological study? That's an ecological fallacy. Because I'm saying everything in terms of population, right? But what I'm saying might not be true in case of each person. If I take an individual from that country and then if I try to apply this, your relationship might not hold true. This is the issue with ecological study, which is known as your ecological fallacy. Okay, so that's all about your study designs. Now, okay, one more extra point. See, what you see here is two different studies which we have not told yet now. One is your nested case control and another one is your case cohort study. Okay, see, both these are studies embedded within a cohort. These are examples for studies embedded within a cohort. Suppose a cohort study is going on to find out the risk factor, find out the association between a risk factor and a disease. Okay, the cohort study is keeping on going on. It's a longer study, having a longer follow time. Why not I do a case control study in between? So what I do is from my cohort, some people are developing disease, right? They had the exposure, and some people will develop disease, some will develop afterwards. So those are developing diseases. Those people, I'm taking it one at a time. One case I choose from that cohort, and then at the same time I choose another person from the cohort who has not yet developed a disease. So I got a control. So case 1, control 1. Then I check second case, similarly a second control. Likewise, if I select this kind of study, which is embedded, this is a case control study, which is embedded within your bigger cohort, this is called a nested case control study. Okay. Similarly, you have another study called a case cohort study. Here also it's just a similar thing. From your defined cohort, you are choosing cases, but you're choosing the cases at a time. Case 1, case 2, case 3, case 5. 5 cases, suppose I'm taking. So 5 cases I'm taking to choose. But controls, I'm not taking simultaneously. After the end of my 5 cases, I just choose 5 controls all of a sudden at a single point of time. That is your case cohorts. Both these are examples of case control studies that are embedded within a cohort. Okay. So now we'll move on to the next question. Again, it's from epidemiology only. We'll see calculations. Okay, we have to know how to calculate the measures of association. I told you in case control study, the measure of association is, okay, I'm seeing answers. All your answers are correct only. Retrospective cohort study is the answer, but this is coming with after a bit of lag, so I'm not able to follow up accordingly. Okay, but please keep giving your answers so that at least you can know whether you're correct or not, right? And even if you go wrong, if you know the correct answer, next time you will never go wrong in that particular question. Okay. So next question is, you'll be asked to calculate the measures of association. In case of a case control study, they'll give you the scenario, you have to calculate the odds ratio. In case of a cohort study, you can be asked to calculate relative risk or attributable risk, population attributable risk. Then there's something called the NNH and NND, that is number needed to treat, number needed to harm. You can get all these calculations from cohort or related studies. Okay. So we'll just see. See the question here. So question number 7, in an investigation to study the effect of smoking on renal cancer. Effect of smoking on renal cell cancer, it is observed that 30 of the 50 patients are smokers as compared to 10 out of 50 control subjects. So you see the odds ratio of renal cancer associated with smoking will be, they are asking you the odds ratio. Before that, even if the odds ratio is not given, just tell me what is the study design. You know, I know it's a case control, but how did you come at that? See, what they have taken is patients, right? What they've taken is they've compared patients with control. So that is cases and controls they've taken, and then they are seeing the smoking or the exposure status. So this is definitely a case control study. Now we are asked to calculate the odds ratio. Whenever it's a odds ratio calculation, relative risk calculation, first step, draw your 2/2 table. Okay, don't go wrong in that. So here also we are going to draw the 2/2 table. So this is your 2/2 table. So while drawing a 2/2 table, always remember disease is on the top. Okay, disease is the truth. That is what is there really. So truth is always on the top. So disease is always on the top. And on the side, what you draw is your exposure status. Okay, so this is the 2/2 table for a case control study. So here you have disease positive, those who don't have disease, and this side you have those who are exposed and those who are not exposed. So from the question, totally they have given how much? Of 30 out of the 50 patients were smokers. That means what is the total number of disease or total number of the patients? You have 50. Okay. Out of the 50, they say 30 were smokers. So out of the deceased, 30 had the exposure or 30 were smokers. And out of the non-deceased, again a 50%, that's a control group. Out of the 50, you had 10 were smokers. So 10 smokers. So what is the rest? So 50 minus 30 will give you 20 here, and 50 minus 10 will give 40 here. Okay. So this is a 2 by 2 table. Now it's simple, right? Odds ratio is a cross product ratio. You just have to do the cross product. So odds ratio will be, or it's also known as cross product ratio, will be this by this. So 30 into 40 by 20 into 10. How much is it? 6. Sorry, 6% is the answer. Okay. So here your option C is the correct answer. That is 6% is the answer. And how do you interpret this? When I say odds ratio 6, that means there is a 6 times higher odds of people in smokers. There's 6 times higher odds of developing your renal cell cancer compared to non-smokers. That is how you interpret this odds ratio. Okay. So odds ratio, draw the 2 by 2 table and do the cross product ratio. Simple. Now, similarly, now you have a question where you are asked to calculate the relative risk. Okay. And always remember, sometimes in questions you see here, they will be giving you table. But you make sure whether this is actual 2 by 2 table or not, whether the disease is on the top, whether the exposure is on the side. Sometimes what happens is they'll just reverse it and give, and students without checking it, they'll just do the cross product and get a wrong answer. So always make sure if they've given the 2 by 2 table, it is what you actually need, whether the disease is on the top, whether it's following all your particular criteria. Okay. So this question number 8, the table given below shows cases of breast cancer occurring in a RCT of new drug designed to prevent the disease. In the study, 1,000 healthy women between the ages of 60 and 65 were given the drug, and 1,000 were given the placebo for 5 years. What is the relative risk of breast cancer in patients exposed to drug? This is actually an RCT. Even in RCT, you get all the risks. So relative risk, attributable, everything can be, you can get questions to calculate these things in an RCT or a cohort study. Okay, so we'll see. What is the relative risk of breast cancer in patients exposed to this drug? So again, if it's a RCT or a cohort, just like you made a 2 by 2 table for a case control, here you have to make a 2 by 2 table where instead of disease, you have the outcome. The outcome can be disease also. But here you are putting outcome positive, outcome negative. And this side is again exposure positive and no exposure. This is the same, there is no change. And I'll just fill the values given here. What they have given is breast cancer. So they have tried to develop a new drug to decrease the or to prevent breast cancer, and to one group they are giving to their intervention group, they are giving this new drug and seeing whether the breast cancer incidence is reduced or not, and to the other group they are giving a placebo drug in this particular RCT. Okay, and total you have 1,000 patients, right? 1,000 people in both the arms. So here you have 10. So the exposure here is your new drug. It's a protective one that they are going to check again, but the exposure is new drug. So how many people were given the new drug according to your question? 100, right? 100 were given the new drug. Sorry, 1,000 were given the new drug, and the other 1,000 were given the placebo, or there is no exposure, right? Then out of those who were given the new drug, according to your question, 10 developed the outcome or breast cancer. So remaining 90 did not develop, right? Similarly, out of 1,000 who were not given this drug, how many developed? 40 developed the outcome, and 960 did not develop the disease. So what they have asked you is to calculate the relative risk. So what is relative risk? So you've been asked to calculate relative risk. Relative risk is got by the formula incidence in exposed divided by incidence in non-exposed, right? So what is the exposure here? The drug. So what is the incidence of occurrence of this disease in exposed? So 10 out of your 1,000 exposed people, that is 10 out of your 1,000 exposed. That is the incidence in exposed. Similarly, in non-exposed, that is 1,000 non-exposed, you have 40 people developing disease. So divided by 40 out of your 1,000. This is the incidence in non-exposed. This will give you the relative risk, which you will get it as 0.25. Okay. So the relative risk here you got is, if you do the calculation, you get 1/4, that is 0.25. That means, what is this? This is protective, it is a risk factor, there is no relationship. So our odds ratio or relative risk, if it's 0, that means there is no, sorry, if it is 1, then there is no relationship. But if it's more than 1, it is a risk factor, and less than 1, it's a protective factor. Here the relative risk is 0.25. That means this drug is actually protective, or it's actually protective against this breast cancer. Okay. But in your question, they have given it in percentage, so the answer becomes 25%. Ideally, relative risk, you don't write it as percentage. You don't convert it into percentage. You just write it as 0.25 or 0.3 or whatever. But as the question is given in percentage, we are just writing it as 25%. But the meaning is relative risk is 0.25, which is protective. Okay. So just like relative risk, what are the other risks that you're calculating? So in a cohort study or even the RCT cohort. So one is, you know, your relative risk, right? That is incidence in exposed by incidence in non-exposed. Okay. Second time, next risk is your attributable risk. That is your incidence in exposed minus incidence in non-exposed. Okay. If I'm writing it in form of a rate, it becomes like this. Incidence in exposed. So incidence in exposed minus incidence in non-exposed by incidence in exposed will give you attributable risk. And in case of your population attributable risk, it is incidence in total population minus incidence in non-exposed divided by incidence in total population. Or you should know these formulas by heart and the meaning also. Each one, what do you mean by attributable risk, what do you mean by population attributable risk, what is relative risk, and how do you calculate this. This should be known to you. There should be no doubt in that. Okay. So what do you mean by this attributable risk and what is the difference between this attributable and population attributable risk? We'll see that with the next question. Okay. This is a conceptual question. Question is, attributable risk calculated to understand the relationship between smoking and lung cancer is 90%. Which of the following is true? So they are saying the attributable risk between smoking and lung cancer is 90%. What does this sentence mean? Okay. The options given are 10% of lung cancer in smokers is not associated with smoking. 90% cancer of lung can be eliminated and population of smoking is eliminated. 90% of cases of lung cancer are due to smoking and 10% can be eliminated if smoking is eliminated from the population. So the answer here is attributable risk. The answer is option C. That is 90% of the cases of lung cancer are due to smoking. So simple words, what is attributable risk? What is population attributable risk? Okay. So we'll see this example. You see, in this particular example, they are showing the relationship between smoking, the exposure to smoking and development of lung cancer, right? Okay. When I say a relative risk, when I say it's a relative risk between the smoking and lung cancer is 2, that means smokers have a twice the risk of developing lung cancer than non-smokers. That's simply your relative risk. When I say attributable risk, if I say attributable risk is 90%, that means 90% of this, you know, is because of, I'll just write it down. That is, if I say it is 90%, that means 90% of this CL lung can be attributed to this risk factor in exposed people. Okay, that is what we mean by attributable risk. Whereas population attributable risk is, if I say 90% is the population attributable risk, that means 90% of the disease in the whole population can be attributed to your particular risk factor. Okay, so once again, you have a total population. Out of this group is exposed to your risk factor, and attributable risk is the percentage or this much of the percentage of the disease is attributed because of this smoking to this particular exposed group. That is your attributable risk. Whereas population attributable risk is the percentage or the attribution because of that risk factor in the whole population. That is your population attributable risk. Okay, we just write it down. 1. What do you mean by attributable risk is so much disease among the exposed. It is among the exposed. Okay, it's not the whole population. Can be attributed to this exposure. That is your attributable risk. So if I'm removing the attributable risk, then I can decrease that disease from that particular exposed group, not the whole population. Okay. Second one is your population attributable risk. This means so much of the disease or that amount of disease in the total population can be attributable or attributed to this particular exposure. Or in other words, if you risk is eliminated, if you just stop smoking, you can this much percentage of the disease in the population can be reduced or can be brought down. Okay, so that is population attributable risk. In terms of policymakers, or if you want to, do a new intervention and all, policymakers mainly focus on the population attributable population attributable risk, because they want to find out, not in the exposed, they want to find out, if I do this, if I do a smoking preventive intervention in this population, how much of the disease can I decrease in the total population. So in such cases, your population attributable risk is more important. Okay. Now, two more things, simple. Now I told you there is attributable risk and population attributable risk. Now just let's focus on the attributable risk. Okay, we say risk in terms of harmful exposure, right? Attributable risk is told in terms of harmful exposure. But sometimes when the exposure is not harmful or when the exposure is beneficial, we have another term, that is absolute risk reduction, or ARR. According to your calculation, it's almost similar. Attributable risk and calculation and absolute risk reduction formula is almost the same, but the concept is attributable risk is in case of your harmful exposure, it's a risk, whereas the absolute risk reduction is in case of a beneficial exposure. And 1 by attributable risk will give you what is called as the number needed to harm. 1 by attributable risk is equal to number needed to harm, whereas 1 by absolute risk reduction, 1 by ARR, is equal to number needed to treat. I'm telling you because sometimes you may get the question to calculate number needed to harm. You know attributable risk, but you don't know that 1 by AR will give the number needed to harm. Because just because of that, you might not get the answer. Okay, so remember, NNH, or number needed to harm, is 1 by AR, 1 by absolute attributable risk, whereas number needed to treat is 1 by ARR. Okay, so what is AR? It's risk among exposed minus risk among unexposed, or incidence in exposed minus incidence in non-exposed. This is your attributable risk, right? If I'm not saying it in terms of a rate where I'm putting the, like, this is also attributable risk, but if I write it like this without the by part also, this is also attributable risk. Okay, so your number needed to harm will become 1 by incidence exposed minus incidence non-exposed, or 1 by AR is your attributable risk. Similarly, you have your, in case of beneficial exposure, you have what is called absolute risk reduction. This is risk among your unexposed, because this is a beneficial exposure, right? So you will get a lesser risk in the exposed because this is a beneficial exposure. Risk among exposed. This is your absolute risk reduction, and NNT, number needed to treat, will be 1 by ARR. Okay, how do you remember this? This is how I remember. Okay, ARR is for AR Rahman. AR Rahman's music can never be a harm for anyone. It is always a treatment, or it's always a music therapy. So ARR is related to treat, or number needed to treat. So ARR is equal to 1 by number needed to treat. Okay, so ARR is related to number needed to treat. Remember AR Rahman and treat. And the other one, the AR is related to number needed to harm. Fine. Now you moving on to the last question of this segment, which is your concepts corner. So I hope some of your concepts in epidemiology and biostatistics are clear now. So let's move on to this question. So the question is, false about randomized controlled trial is, you have options, results of attrition are included in the analysis, randomization is done while selecting subjects for the study, double blinding is the most common form of blinding observed, and crossover design helps removing ethical concerns. Okay. So for this, you need to know a bit about randomized controlled trial. Okay, randomized controlled trials is a type of experimental study design, right? You have two groups. In one group, you are giving the intervention. In the other group, you are giving the control. The other group is the control group of the placebo group. And then finally, you're seeing the outcome in both the groups and compare. So in an RCT, how do you start the study? First step is you, in RCT, first is you select your eligible patients. Okay, you select your eligible patients, then you take their consent. After consent only you start the study. Okay, you select the eligible patients who are giving you consent, and then you do what is called randomization. What do you mean by randomization? It's a procedure by which the person coming to you can be allocated to any one of the group. So if I am a study subject, if you are the researcher, if I come to you, I have no idea in which group I'll be, or even you also cannot say in which group I'm going to be in, whether I'll be the intervention group or whether in the control group. I have an equal chance of being in the intervention group as well as the control group. This is called randomization. This is what we are doing by randomization. So first you select the eligible subjects, take the consent, and then you do the randomization. And under randomization, either the patient goes to the treatment group or the control group. Okay. And then what you do? Then you see for the then you follow up them up and you see for the outcome, and then you come at your analysis and your observations. Okay, this is how you do a RCT. So you see this option here, randomization is done by selecting subjects for the study. That is the wrong answer, right? It is not done while selecting the subjects. You do it after selecting the subject, and then you take the consent and then you randomize them. Okay, rest are actually true. Result of attrition are included in the analysis. Yes, it is true. Double blinding is the most common kind of blinding observed. It is true. Again, an MCQ point. Most common form of blinding, double blinding. Okay, crossover design helps removing ethical concerns. That's also correct. Now, few more points from MCQ point of view which you should know. So in RCT, unit of study is individual, but more better would be patients, right? Actually, we do clinical trials in patients, on patients. So unit of study is patient. Then basically you have two types of RCT. Okay. You have something called a concurrent parallel design, and you have a crossover design. That is your last option. See here, crossover design. So RCT can be of two types. It can be a parallel or a crossover design. What happens in a parallel design? You have two groups, A and B. One group you give the intervention, other group you give the control, and then you, just like we told in the initial, the steps of RCT, you just follow them. That's a concurrent parallel design. Concurrently, you have two different groups, and then you are doing this test. Okay. But in case of a crossover design, what is happening is you have an experimental group and a reference group. Okay, initially. Okay, then what happens is you switch them over, you cross over. That is, after a point of come, your reference group becomes the experimental group becomes your control group. That means you're equally exposing them to both your, whether your intervention and both the control, you're equally exposing them. So there is ethically, it has less issues than the concurrent parallel design, because in concurrent, one group is only getting one exposure, another group is getting another intervention, right? Both are getting different exposures. But in your crossover, since they are crossing over the groups after a point of time, both are getting almost all the same interventions. So ethically, it's better. Crossover design is a better. So that is also correct. Then, what is the other point? What's first point? Results of attrition are included in the analysis. So, what is that? See, how do you analyze the results of an RCT? You have two types of analysis, okay? When we are talking about analysis of RCT, you have, it can be either ITT, that is intention to treat, and you have something called per protocol. Okay, so in intention to treat, what happens is, suppose I'm doing an RCT where my intervention group is given medication and the control group is given surgery. Surgery is the usual mode of treatment for a particular disease, but in my study, I'm going to see whether medicine is also better than the surgery option. So my intervention is medicine and the control group is surgical group. Okay, but what happens is, after some time, one of my patients feels like, no, I will just stop this thing and I'll go and do the surgery. So my patient just leaves there and he goes and joins the surgical group. And something else can also happen. Somebody in the surgical group thought that, okay, why risk my this thing for a surgery? I'll better go for a lesser riskier option than a surgery. So I'll go to the medicine group. So they can change. So people can change the groups also in some RCT. Or sometimes some people can be lost to follow. They're like, no, we are not going to continue the study. We're just leaving. So these things can also happen. But so what happens is, if there are such changes and such attrition, your randomization is lost. What you wanted equal chance of a person to be in both the groups, right? If these people keep on changing, the main aim or the randomization part is lost. So in analysis, I don't want this randomization to be lost. So what I do is, I analyze them as per the groups in which they were assigned earlier. Whatever I've assigned them, where I have assigned them in the initial, whether they've changed or not, I'm going to analyze it just like that. That is your intention to treat analysis. Okay. Whereas in your per protocol, what happens is, whatever changes happened, I'm accepting it, and as per what changes happened in reality, that I'm going to analyze. That is your per protocol analysis. Okay. Most commonly, we go for this intention to treat analysis. And results of attrition are included in the analysis. Yes, in intention to treat analysis, we do include the results of attrition. And what is this blinding? Okay, so this is again the same thing only. RCT, study population, randomly assigned, new treatment, current treatment, improve, do not improve, you just see the outcome. I put in heart A. Why? Randomization is the heart of RCT. This is actually an MCQ question, okay? Is the heart of your RCT. Then blinding, right? You have three types of blinding. single, double and triple blinding. The image I've shown here is double blinding. Okay, double blinding is when the researcher as well as my subjects don't know in which group you're going to be assigned, whether the patient is going to the treatment group or the control group. Researcher also doesn't know, the patient also doesn't know. Both sides are blinded, that is double blinding. If only the patient is blinded, that is I know where I'm going to put the patient, but the patient doesn't know which intervention he's going to get. That is single blinding. Triple blinding is when the doctor or when the researcher plus your patient plus the analysis person, all three are blinded. Nobody knows what's happening. So that is your triple blinding. Okay. Now, a few, before we move on, I'll just write a few important points about randomization. These are all MCQ points, that's why I'm writing it down. Randomization. Okay. It's a statistical procedure by which participants are allocated into either of the two groups. Either two groups. By here, what happens is people have equal and known chance of falling into either of the groups. Okay, this word is important here. You see, equal and known chance of falling into either of the groups. This also was the previous year MCQ. So randomization and make sure that everybody has equal and known chance to be falling into either the control group or your intervention group. Then, what are the other uses of randomization? It helps in eliminating your selection bias. That is one point. Then ensures comparability between your groups. Removes both confounding and bias. See, randomization, which is the heart of the RCT. This is what makes RCT superior to your case control, cohort and all those. RCT is superior, right? Because one point is your randomization. Because of randomization, you can remove the bias as well as the confounder. When I say confounder, there can be two types of confounder. One is known confounders and unknown confounders. For example, known confounder, you can know, your age or your gender. These are known confounders. If there are two people, two groups, but the age is completely different, and if I'm saying something like mortality status is my outcome, and obviously the people who are in the older age group, they have a higher chance of mortality than the younger age group, right? So things like that can happen. So, but this is a known confounder. Age, sex, and all are known confounders. But again, there are unknown confounders. Sometimes some genetic factors or things like that which we don't know. But in randomization, you are giving an equal and known chance for the person to be in either of the groups. Thereby, you are actually controlling the known confounders as well as the unknown confounders. But in matching, when you do matching you do in case control studies. In matching, you can only control the known confounders, not the unknown confounders. Okay, randomization you can control both, but in matching can only control known confounders. Hence, you say actually randomization, because it can control both, is superior to matching because it can control both known as well as your unknown confounder. Okay. Now, next diagram. What is this? What do you see on screen? What do you call this? This is your evidence pyramid. This is how the quality of your evidence from different studies. This is how it's represented in the form of a pyramid. So at the least, you have all the expert opinions, case series, case report and all. Then you have case control study. Then you have cohort study. RCT told is superior. And on top of RCT, you have something called systematic review and meta-analysis, where what you're doing is you're combining results of many studies. There are studies based on one, maybe hypertension among adolescents. It's a study which has been done in different parts of the world by different people. So what I'm doing in systematic review and meta-analysis is I collect all these studies and then I try to combine their effects, or I pool their effects and I get a value. So overall, from all this, this is the effect, or this much is the hypertension prevalence. So that study is actually, it's not just one single study, right? So many studies results you're combining. So that has the highest, place in this evidence pyramids. That's your SRM, your systematic review and meta-analysis. So direct MCQ point, what? First preference, which is a study which is the preferred for establishing causality. That is your meta-analysis. Okay. When I said causality, you should all know the Hill's criteria of causation. I'm not repeating it here. I've already told that in the previous live session. So just as a reminder, before you go for exams, just go through the Hill's criteria of causation also. Okay. I'm not explaining because of lack of time. So next thing, evidence pyramid. I told you. One more point is evidence-based medicine. Who is the father of evidence-based medicine? This has been asked. This is David Sachet. Okay. Now we have completed the questions in this confusion segment or the concept segment. Now we'll see some more concepts. Okay, just some points about your p-value, about your type 1 error, type 2 error, what is p-value, what is this type 1 error, what is this type 2 error, and what is the statistical significance, things like that, which people usually get highly confused. But if you're if you're very firm, your idea is very clear, then it's okay. If your idea is not clear, you're still confused what is p-value is, what is type 1 error, type 2 error, please be attentive and listen to this. Okay. So first thing we'll see what is the concept of p-value. Okay. So you should need, when I'm going to explain this concept of p-value, you should know what is p-value, what is a null hypothesis, what is an alternate hypothesis. Okay. So p-value is measure of your chance alone. Okay. That is your first point. So initially I told you we cannot study the whole population. Whatever study you're doing, you have to take a sample. So I have a whole population here, and from this population I take a particular sample and I do my study, and I have some hypothesis which I want to test. So for that, from my whole population I take a small sample and I do the study. So I got the conclusion, results, everything, and now what I'm going to do is I am going to extrapolate it or generalize my results to your population, right? So there, sometimes the result that I got might be just due to chance. Okay, you cannot eliminate chance 100%. There will be some chance, or just because of luck, or just coincidentally I got the result. That can also happen, right? That is what p-value measures, whether the result you got is, how much of the result is actually just because of chance or just because of your luck or coincidence. Well, that is how much is not true. That's what your p-value is going to measure. Okay. So then, hypothesis. What do you mean by hypothesis? Hypothesis is just an assumption. Okay, you can have any hypothesis. Every study will have a hypothesis. We have two types of hypothesis. One is your null hypothesis. One is your alternate hypothesis. Null stands for no. So null hypothesis means there is no difference. Alternate hypothesis means there is a significant difference. Okay, so p-value, it's just a measure of chance. Then you have something called null hypothesis. I'm writing it as H0. Okay, null hypothesis saying there is no difference. And you have something called a HA is for alternate hypothesis, saying there is a significant difference. To better understand, maybe you're comparing two drugs. Okay, I'm comparing drug A and drug B, and my null hypothesis is there is no difference between the outcome that you get after administering drug A and after giving drug B. That is my null hypothesis. But in my alternate hypothesis, I'm going to say there is a significant difference, right? So my alternate hypothesis will be there is quite a significant difference between the outcomes you get from giving drug A as well as drug B. Okay. So you know what p-value is, what is H0, what is null hypothesis, what is alternate hypothesis, fine. Now, p-value, I told you, we are taking a cutoff. We are taking an arbitrary cutoff of 0.05 is your cutoff for p-value. Okay. So p-value, we are taking a cutoff of 0.05 or 5%. What does this mean? If I say p-value, in my study p-value is 5% of 0.05. This means that 5% of the time, the difference observed in my study, or whatever result I got in my study, is due to chance alone. That means it is not actually true, but whatever I got is due to chance alone. That is what your p-value is saying. So you want a lesser p-value, right? Up to 5% is okay, we can allow. But more than 5%, if your result is just coincidental, just due to chance, it's not statistically significant. So up to p-value of 0.05, you take it as okay. So a p-value which is less than 0.05, you're happy because your result is significant. But if a p-value is more than 0.05, just like this chimp here, no, you are sad because its result is not significant and whatever you got is highly due to chance also. So up to 0.05, you are happy. Okay. So this is basically what you mean by p-value and simply about hypothesis, null and alternate hypothesis. Now we'll just take a short break. After the break, we'll see a bit more about the p-value and what are the types of error. You have type 1, type 2 error, alpha error, beta error. We'll see that after a short break. Okay. Okay, so we are back with p-value. No, so you know p-value allowed level is less than 0.05. That means only 5% is due to chance. It's okay. I'm accepting. Fine. Now, same thing, we're just tabulating it, right? So p-value less than 0.05 is significant. Yes, that means there is actually an effect is observed, or your alternate hypothesis is true. Alternate hypothesis is the one which says that there is a significant difference. Yes, that is true because your p-value is significant, which is less than 0.05. So you're going to accept your alternate hypothesis saying there's a significant difference. So you're going to reject your null hypothesis. See this diagram here? So p-value less than 0.05, reject your null hypothesis, fine. Similarly, the counterpart, if p-value is more than 0.05, that means it is not significant. Whatever you got is just coincidental, just due to chance or just random error. So not significant, no significant effect observed. Alternate hypothesis is wrong, you're rejecting it, and you're going with your null hypothesis. That is p-value 0.05 and 0. More than or less than 0.05. Okay. Now we are upgrading to the next level of difficulty, which is your type 1 error, type 2 error, alpha, beta errors. Okay. So I told you we are doing a study, and whatever you get in the study, and there is a result that you get in the study, and there's a truth that is actually there, right, in the population. So we are going to just represent it in a 2 by 2 table. See, always truth prevails, or truth is always on the top, right? So here, so this is your truth or the reality. Just like you put disease on the top, the truth or reality is always on the top. So this side of the table is your reality, and this side, what you see here, reject null hypothesis, fail to reject null hypothesis, what you are doing or your researcher is doing, okay? This is what your researcher got, and above is what actually is happening. Okay, now there are two types of researchers. Okay, we'll study this with the help of your 3 Idiots movie. We have two kind of people in 3 Idiots. One is your virus. Remember virus from 3 Idiots? This guy is Raju, poor Raju from 3 Idiots. So you have virus as well as you have Raju. Okay. Type 1 error occurs when a person like virus, somebody who's very over smart, over cunning, boasting kind of person does the research. Okay. So virus is for type 1 error. I'll tell you what it is. So this is, think it as an over smart, boasting kind of personality whom you cannot stand. It is type 1 error. Okay, what happens in type 1 error? Suppose you think virus is doing an experiment. He wants to find out whether there is a difference between drug A and drug B. What happens is really he did not get a difference. Okay, he's just boasting about there's actually no difference. But he is actually kind of an egoistic person. He won't agree that see, there is actually no difference. No, he will just cook up data and he'll just say, no, there is a significant difference, or my alternate hypothesis is correct and my null hypothesis is false. That is what he's going to say. That is, in reality, null hypothesis is true. Okay, there is no significant difference. But because your virus is over smart, over cunning, egoistic person, he cannot accept that. So he'll just say a lie, or he'll just cook up things saying that there is a significant difference, or my alternate hypothesis is correct and I'm rejecting the null hypothesis. That forms your type 1 error or your false positive. So virus is an example for your type 1 error. That is, in reality, there is no difference, but because I'm over smart, over cunning, egoistic person, it's difficult for me to accept that. So I'm saying there is a difference in spite of not having a difference. So that is your type 1 error. That's wrong, right? So that is type 1 error. Now we'll see what is type 2 error. In type 2 error, it's just the other way around. Okay, type 2 error, remember our Raju. Raju, you can remember in case of your type 2 error. So in type 2 error, what happens is, Raju was doing a research, but he did not have the confidence and all that, so he just stopped the result in the middle. But he did not continue the research, or he was not very confident about his studies, so about his research. So what happens is, actually, the drugs he was studying, drug A and drug B, actually there was a difference. But because he dropped in the midway, or he did not have the confidence, so he did not analyze it properly, he did not get the result. Okay, so he is saying the null hypothesis is true, or there is no significant result in my study. But in reality, it was the alternate hypothesis that was true. That was, in reality, there was a significant difference, but he stopped it in the midway and all that. He didn't get it. So type 2 error, or what happens with Raju, is your type 2 error. That is, in reality, there is a difference. There is actually a difference, but you fail to realize, or the researcher fails to say that there is a difference, or wrongly he accepts null hypothesis than the alternate hypothesis. That is your type 2 error. Okay, so that is type 2 error. So type 1 error, remember virus, actually there is no difference, but he's saying yes, there is a difference, but the truth will come out one day, right? So it's a type 1 error. Type 2 error, remember Raju, actually there was a difference, but he did not have the confidence to go about it, so he stopped the study and he says there is no difference in spite of there being a difference in reality. That is your type 2 error. Then you have two other options, right? That is, when actually there is no error and the researcher also says, sorry, when actually there is no difference and the researcher also agrees there is no difference, then it's a correct outcome. Similarly, when there is actually a difference and the researcher also says there's a difference, that's also correct outcome. There is no error. So there is only type 1 error and type 2 error. Okay, I hope the concept is kind of clear to you. Now we'll just write it down. Okay, what is type 1 error and type 2 error? So type 1 error, type 1 error, what happens? Null hypothesis is true but rejected. In reality, null hypothesis no difference, but you say there is a difference by just being over smart, so it's rejected. That is your type 1 error. In type 2 error, what happens is your null hypothesis is false, but not rejected. Actually, there was a difference, but you go with the null hypothesis. That is type 2 error. So type 1 error. So the probability of type 1 error given by your p value. Okay, and then you have something called the alpha level or the significance level. This is the maximum tolerable probability of your p value. Okay, so to keep type 1 error minimum, what should you do? P should be less than alpha, right? So you want to keep all the errors minimum, okay, whether it's type 1 or type 2. So P should be less than alpha to keep your type 1 error minimum. Okay, then only the results become statistically significant. In type 2 error, we told null hypothesis is false, but it gets rejected, but it is not rejected, and the probability of your type 2 error is given by beta. That is probability of declaring no significant difference when actually there is a difference. It is present. It is present. And your 1 minus beta or 1 minus type 2 error is type 2 is given, gives your what? Gives the power of your test. Okay. Power is measures ability to demonstrate an association when one really exists. That's the power. Okay. To increase power, you can increase sample size. With sample size, your power will also increase. Okay. So just summarizing, type 1 error, type 2 error. Type 1 error is p-value, okay, and alpha. Type 2 error is beta. Alpha is the first letter, right? So it's type 1 error. Beta is the second letter, so type 2 error, okay. 1 minus beta or 1 minus type 2 error will give you the power. Power of a test is the, the ability of the test to demonstrate an association or demonstrate a significant association when actually there's an association. That's a type 2 error. So I hope your type 1 and type 2 error are different. Last question, which one is more bad? Type 1 error or type 2 error? Which is the worst? Simply, who is bad? Virus or Raju? Who's the worst? Virus, right? So type 1 error is always bad. It is bad than your type 2 error. All errors are bad, but type 1 is more bad. Okay. So that was about your concept section. Now we are moving on to a second segment of this class, that is color coded essentials. We'll just study some of the colors in PSM. Okay. Very simple segment. Now I know you're all saturated with the type 1, type 2 errors. So now we'll just move to a simpler one. Okay. So we are going to study different color codings in PSM. Okay. So first, when you say color coding, first thing that comes to your mind will be obviously your BMW or biomedical waste management, right? Very important, sure short question. Okay, the question is cardiac pacemaker is discarded into which one? Which bag? Yellow, red, blue, puncture proof. You know, cardiac pacemaker is a, what is cardiac pacemaker? It's actually a metallic implant, right? And metallic implant goes to your blue cardboard box. So cardiac pacemaker will be discarded into your blue cardboard box. Okay. So we have we'll just quickly revise all the color codings where each kind of biomedical waste put. So you have your red, okay. So just write biomedical waste management, okay. You have your red, then you have yellow. What else? You have your white, consider this as white, okay, and blue. Red, yellow, white, blue. We'll first see red. Red is for recyclable. So in red bin or in the red cover, you always put recyclable waste. And most commonly you get plastic waste, right? Plastic is recyclable. So red R for R, red for recyclable waste. Tell me the examples for the things that you put in the biomedical waste that are going into the red bin. So red, you have all the plastic things you see in your ward, IV tubes, your catheter, then your urine bags, then syringes. But note that syringe without needle. Okay, if there's a needle, don't put it in the red. You go for the white or the translucent where you put all the sharps. Syringe without needle, IV tube, catheter, your urine bag, everything comes in the red. One more important thing that comes in the red is your gloves. Okay. See, the other things, most of the things, if they are contaminated with blood, okay, suppose it's a not a cotton, any syringe or vacutainer. The vacutainer without blood, it's a normal vacutainer directly going to recycling, that is put in a red. But in case there is blood in it, if there's a blood in the vacutainer, you cannot just remove the blood, it won't go away like that, right? So in such a case, what you have to do is you'll have to put it in the yellow bin. Usually the things in the red, if they're soiled with blood, you tend to put it in the yellow bin. Whatever the anatomical waste, the soil waste, the blood content, the infectious things mainly go to your red, sorry, yellow. But in case of gloves, remember, if the gloves is having blood or not, whatever, glove is always going to the red bin. Okay, gloves with or without blood, you have to put it in the red. Okay, and what is the method of treatment, or finally what do you do with the red waste? It goes for autoclaving. Finally, first step is either you do autoclaving or microwaving or things like that, and then next thing is you just shred it, shredding and mutilation of the things after autoclaving. Then you can send it for recycling or whatever purpose. So autoclaving is usually for red. Okay, not just for red, whatever we are going to tell white, blue also, right? In white, blue also, mainly the last process is autoclaving most commonly. Okay, so that was about red. Now coming to yellow, first point is I've told all others mainly autoclaving. Yellow waste should always be incinerated. Okay, so yellow waste go to your incineration most commonly. Okay, but in some yellow waste you have to do a pre-treatment before incineration. Sometimes you can just directly put the waste into the incinerator, but in some cases you have to go for a pre-treatment before the incineration. Okay, now we'll see, this is the biggest one, more questions and more to write under the yellow category. Yellow category waste can be grouped from A to H, A, B, C, D, E, F, G, H. Okay, you have A, B, C, D, E, F, G, H. Yeah, you have A, B, C, D, F, G, H. Under A, what is the waste you put? You have human anatomical waste and animal anatomical waste. Both these goes to the yellow bin. Okay, so anatomical waste goes to A. But in A, you put human anatomical waste. The other one is animal anatomical waste. So biomedical, what is biomedical waste, by the way? Biomedical waste is any waste that is generated during the process of treatment or in investigation or your immunization of your humans or animals or research related activities. This is the biomedical waste. So all your anatomical waste goes to the yellow bin. Category A of yellow is the human anatomical waste. Category B is your animal anatomical waste. Okay. Now C, you remember C for cotton. Okay. Cotton goes to your yellow bin. Cotton is again a waste that's going to your yellow bin. Along with cotton, especially the soiled. Okay. Then D you have, under D, remember D for discarded medicines. Discarded medicines. Again, an important MCQ, most people fail to write this. Discarded medicine, most people don't consider it as a yellow waste. But remember, discarded medicine plus cytotoxic drug. These things also go to your yellow bin. Okay. Then E is for chemical waste. Chemical waste. F is for F for fluid. F is for fluids. You have all kind of fluid except blood. All other body fluids. Okay, it can be your tap fluid, or it can be tears, or any kind of body fluid except blood comes under F category. Then G for gown, remember, just like you remembered C for cotton, G for gown. So you have gown, your mattress, patient use, whatever the patient is using, your linen, mattress, gown, everything comes under the G. And H usually has your microbiological infectious waste. Okay, usually the things coming from your microbiological lab plus blood. Blood comes under category H. Okay, so A, B, C, D, F, G, H. A, B, anatomical waste. One is human, the other one is animal. Then you have C for cotton, D for discarded medicines, F is for fluids except blood, H is for microbiological and infectious kind of waste plus blood. G is for gown. Okay, out of these things, all the A, B, C, D, F, G, H, the last three, the fluid, the gown, the F, G, H, these things should be pre-treated before incineration. Okay, rest of the things pre-treatment is not necessary, but these three, F, G and H, they should be pre-treated before your incineration. Okay, so that is yellow. Now white and blue are very simple. White you have white is usually a puncture proof container, because you're going to put sharps in it, right? So you cannot use a plastic cover or things like that. It's a puncture proof container, you can't use anything else, and it's usually white, or sometimes they say translucent instead of white. That can also be asked. Here you have sharps including your metals. So question, syringe alone red, syringe with needle which is a sharp white. Okay, Blue, you have your glassware, then your metallic body implants. Okay, these are coming under the blue. So your question was cardiac pacemaker, which is an implant, so going to the blue. Okay, that is about the biomedical waste. Just two more things about the biomedical waste. One is how do you manage a blood spill? Second one is how do you manage a mercury spill? But mind you, mercury is not a biomedical waste. It's a hazardous waste. But you know, the BP machine and all that. Now, actually, you are not supposed to use a mercury, sphygmomanometer, but still it's being used. So again, mercury spill is also a chance full event in a hospital setting. So you should know what is a blood spill, what you do about in a blood spill and what you do in a mercury spill. But remember, mercury is not a biomedical waste, it's a hazardous waste. Okay. So first we'll see what you do in case of a blood spill. You see a blood spill in the hospital. What would be the first step? Secure the area. Don't let anyone come inside. That's the first step, right? Secure area. That's the first step. Second one, your security is the second one. You have to use a gloves. So wear gloves. The third one is, now you have to apply your disinfectant. For blood, it's always 1% sodium hypochlorite. Okay, initially in the under the yellow bin, I told you the last three categories have to be pre-treated and then only they are sent for incineration. Again, the pre-treatment is using this sodium hypochlorite. Okay, I forgot to tell it here, so just telling it here. So then you apply 1% sodium hypochlorite. You directly go and clean? No, you wait. Let the chlorine act, right? So you wait for 15 minutes. It should sit there and then you can clean. Then you go for cleaning with cloth, paper or tissue, whatever you can clean. Then you dispose it in which bin? You dispose it in yellow. Contaminated with blood goes to yellow. Another question here, wearing gloves, right? You're wearing the gloves. You, after the clean, where do you put that gloves? Even though it's contaminated with blood, since it's a gloves, it will go to the red bin. Okay. That is blood spill. Another one, under this category, your mercury spill. Mercury spill also, the initial things are the same. Securing the area and all that. So I'm just writing it like an arrow. Secure the area. Then you find the mercury spill. See, blood is very easy to find out. You can easily see there's blood, right? But mercury you have to actually find out. It will be kind of difficult to see. Then what do? You collect the mercury. Collect and store in glass containers which has water in it. Glass container with water. So secure the area. You collected the mercury in a glass container which is having water. Close it. Close it. And then cover it. And what do? We don't know what to do. We are just sending it back to the manufacturer. Okay. Send it back to manufacturer. That is what you do in case of your mercury spill. Now I'm moving on to the next question. So color coding, first part, BMW waste management, over. Second one, a sexually active long distance truck driver's wife comes with the vaginal discharge under syndromic approach. Which drug should be given? So you have a wife, you have a lady coming with vaginal discharge. Okay, question is quite simple, direct. They've asked you, it's vaginal discharge. What is the drug to be given under the syndromic approach of syndromic management for STIs? So what is the answer? Okay, so the answer here is, to know the answer here, you should know all the classifications and the color codings, different kits which comes under the syndromic management of STI and what is the treatment in each one. Okay, here it is vaginal discharge, it's a green kit or the kit number 2, and for that vaginal discharge the treatment is secnidazole and fluconazole. Okay, now how did you get this? We'll just study it. Okay, this is the table. You have how many groups? You have 7 groups here. Okay, I'm just writing the numbers. 1, 2, 7 kits. 1, 2, 3, 4, 5, 6, 7. Okay. See, there is no shortcut. Actually, you have to study the 7 kits. What is each color meaning and what is the condition? But we can try remembering with certain mnemonics. Okay, we'll try. Okay. So you have kit 1, kit 2, kit 3, kit 4, kit 5, kit 6, 7. So 1 and 2, you can remember it as go green. So one color is gray. Okay. Second one, the second kit is green color. Okay. So go green is the first and second. So you have total 7. I'm starting with gray and I'm going to end it with black. The extreme shade of gray becomes black, right? So starting with gray, ending with black. First and second is go green. This much is clear. Then you have 6. 6 divided by 2 is 3, right? So this is for PID. 3-letter word, PID, pelvic inflammatory disease. Again, you can remember it as a yellow kit. Yellow has 6 letters. 1, 2, 3, 4, 5, 6. 6 letters in it. So yellow kit with 6 letters is for your 3-letter word, which is your PID. Okay. One more thing is again related to 3. In all these things, you can usually see 1 or 2 drugs. For example, vaginitis we told, right? Vaginal discharge, it is secondary fluconazole, 2 drugs. But in PID, you have 3 drugs. You give cefixime, you give metronidazole, and doxycycline. So 3 drug treatment, PID. Again, kit number 6, 6 letter, color is yellow. Okay, this is how you remember 6. So 1, 2, go green. 6, PID. 7 is for black. Black is, what is black death? Black death is your plague, right? So, or you can remember it as bubo, black for bubo. So black is for black kit. Kit number 7, black is for bubo, inguinal bubo to be specific. The kit number 6, which is yellow, is for PID. Here you have 3 ducts. And kit number 1 and 2 is go green. So kit number 1 or gray kit is used in case of urethral, anorectal or cervical discharge. Urethral, anorectal, cervical discharge. Kit number 1 gray. The treatment is azithromycin plus cefixime. Okay. Vaginal discharge or the green kit or kit number 2, you are giving secnidazole and fluconazole. That was your question. Now you have 3, 4, 5. 3, 4, 5 are there, right? These 3, 4, 5, these are all your genital ulcers. 3, 4, 5, all these are genital ulcers. It can be either herpetic or non-herpetic. We'll write it the other way around because in the order, first comes your non-herpetic, right? Or it can be herpetic. Again, non-herpetic, you have blue, white and blue. And herpetic is always red. Okay. So, genital ulcer category 3 or kit number 3 is white. You give penicillin plus azithromycin is given. But in patients who cannot tolerate penicillin or those who have penicillin allergy, instead of penicillin, you have to supply doxycycline. So, the kit change. Kit becomes blue kit. So, kit number 4 is genital ulcer to patient allergic to penicillin. So, instead of penicillin, you are giving doxycycline plus azithromycin. Then you have genital ulcer disease, which is herpetic. Herpetic is virus. Herpes is a virus, right? Herpetic, you give acyclovir. So that's a treatment for just 1 tablet. So acyclovir 400 mg TDS for 7 days. It's kit 5 or red kit for herpetic. So this is how you're going to study your STI syndromic approach. Then remember this name, Suraksha Clinic. This is the clinic. STI clinics are called Suraksha Clinics. Do you know why these color codings are given? This is actually, this treatment is not aiming, this color coding is not aiming the doctor. Even the health center, from the health center, the ENM can actually give the treatment. The staff nurse can give the treatment in a health setup, in a rural health center setup. So if the person comes with this particular discharge, this particular color kit can be given. If it's a vaginal discharge, you give the green kit so that these medicines are there. Okay, that's why you are using this. Remember the Suraksha Clinic. Okay. Now, going to the next color coding. So we have dealt with 2 color coding. Now we are going to the third one. That is on your pneumonia. A 10-month-old child is brought to a PHC with history of, it is off, okay, history of cough and cold. On examination, he has respiratory rate of 48 breaths per minute, and there is absence of chest indrawing. Weight is 5 kg. He is probably suffering from pneumonia, severe pneumonia, none. So, what are they asking you? They are talking about the IMNCI classification for pneumonia followed in India. Okay. So, 2 things are there. One is IMCA, one is IMNCA. The IMNCA is the one which we are following in India. IMCA is the world version. Okay. So, first point here you're going to remember is IMCI is the global one and IMNCI is for India. Okay, IMNCI is for your Indian version. Now, initially, if you have been following the older PARC, there's an older classification. Now, as per the latest PARC or as per the latest recommendation, you are classifying a child with symptoms of pneumonia into 3 groups only. That is either no pneumonia, pneumonia, or severe pneumonia. Initially, we had a 4 classification system that I'm not going to say that. If somebody remembers that, forget it. Focus on this one. Okay, this is the correct answer. If you write down the older one, you'll lose the mark. So, remember, according to IMNCA classification, child, the age group is more than 2 months. Because less than 2 months, everything is considered as a severe disease and the baby should be taken to the hospital. Okay. This is from 2 months to 5 years. 2 months to 5 years child brought to you with cough, cold, fever, symptoms like this. Okay. So according to INI-CET, you can classify the child as 3 groups under any one of these 3. One is no pneumonia. Next you have pneumonia. Then finally you have your severe pneumonia. Okay. So what is the color? We were talking about color coding, right? There is different color coding for INI-CET. Your no pneumonia has a green color code, just like your triads. It's okay. Patient can be sent home, ambulatory. Okay. Pneumonia has a yellow color code, needs more care. Okay. And your this thing, severe pneumonia, you will be expecting red, but it's actually not red. Like we are dealing with children. Children are cute, so we go for a cuter color, which is pink. Okay. So you have no pneumonia, pneumonia, and severe pneumonia. And when do you say a child is having pneumonia? When do you say there is severe pneumonia? If the child is having, listen carefully, if the child is having either fast breathing or chest indrawing. This is different from your older classification where it was different. Here, if the child is having either fast breathing, it is pneumonia, or chest indrawing, it is pneumonia. Both fast breathing and chest indrawing, pneumonia. Okay. So that is the classification for pneumonia. If the child is not having fast breathing, no chest indrawing, it's just a cold or a cough, things like that, it's no pneumonia. Severe pneumonia, you say in case the child is having danger signs. Okay, we are going to see what are the danger signs. If the child is having any danger sign, even one danger sign, you classify the kid under severe pneumonia because the treatment varies completely. Okay, so you have no pneumonia, pneumonia and severe pneumonia. So what is this fast breathing and chest indrawing? Chest indrawing is the chest wall is indrawn. Sometimes you can get an image of chest indrawing and you can be asked, this is, can get it as an image question also. So that's chest indrawing. Fast breathing is you count the number of the breathing rate of the child for 1 minute, and then you decide based on certain cutoffs whether this child is having fast breathing or not. What are the cutoffs you know of? So for fast breathing, we have 3 cutoffs. Okay, for fast breathing, I'm writing it here. You have can be more than or equal to 60. If the breathing rate is more than or equal to 60 in a child of less than 2 months, it is fast breathing. Okay. If it is more than or equal to 50 in a child between 2 months to 1 year, again it's fast breathing. More than or equal to 40 for 1 to 5-year-old child. Okay. Since we are not dealing with the less than 2-month baby here, the 60 won't be, most probably won't be get. So you concentrate on this 50, 60, 50, 40, concentrate on this 50 and 40. Okay. So this is fast breathing. If a child of 2 months to 1 year, more than 50 is the breathing per rate per minute, it's fast breathing. 1 to 5 years, 40 is the cutoff. So that is fast breathing, chest indrawing. And what do you do? If the child is having pneumonia, no pneumonia, you don't have to do anything. Just home care is enough. Symptomatic treatment, you can give symptomatic treatment for cough, cold, fever, home care. Bas, ho gaya. If it's a pneumonia case, what should you do? If it's pneumonia, that's either fast breathing or chest indrawing, you have to give an oral antibiotic, and then you can send the child home. You don't need to admit the child. You give an oral antibiotic and send home. Which is antibiotic you are giving? Amox. It is Mox, okay? Amoxicillin is the antibiotic of choice. Initially, it was clotrimazole in the previous classification. That's why I'm focusing. Repeatedly telling this time it is amoxicillin, okay? Don't go wrong in there. Severe pneumonia is something severe which you cannot manage it in your PHC level or in your health center level, okay? So in severe pneumonia, you give the first dose of antibiotic and refer the child. That's the next best management, and refer. Okay. So now, what are the danger signs of having severe pneumonia? Just write it down. So severe pneumonia or danger signs. See, these danger signs are simple. Okay. These are the usually the danger signs you see in casualty. When is a child brought to the casualty? You see pediatric child is brought to the casualty. Everybody runs and comes and does all the investigations, everything. Gives the management. Those are the danger signs. What all are the danger signs? A child is not able to drink, not taking any feeds. So obviously if the child is not able to drink, child can be lethargic. So even the child is lethargic or persistent vomiting. He's drinking and eating, but whatever is putting it, it's going out. Persistent vomiting, or you can be seizures. Seizures always a danger sign, right? can be seizure or stridor. Seizure or convulsion, stridor in a calm child. Okay, this much you will remember. The next one is one that you're going to forget. That is a child with severe malnutrition. Child with severe malnutrition is always a danger sign. Okay, so these are your severe, danger sign examples. Now, question here is 10-month-old child brought to PHC with 10-month-old child. Now you see what is the breathing rate given? 48 breaths per minute. So what is the cutoff I told you? 50 or more, right? 48 breaths per minute. It is okay. Fast breathing is not there. No chest indrawing. Fast breathing is not there. So only up till this, if you're reading, your answer will be no pneumonia, because there is no fast breathing, there is no chest indrawing. But the catch is coming here. This is the trap, okay? They have told the weight is 5 kg. You think for a 10-month-old baby, 5 kg is enough? No, 5 kg is severe malnourished. Okay, 10 month, 5 kg is severe malnourishment. Because of that, you have a danger sign. So your answer becomes what? Severe pneumonia. Just because the child is having a danger sign, yes, the answer becomes severe pneumonia. If they have not given the weight, or if the weight was normal, then this question, the answer would be no pneumonia. Okay. So that is how you classify your pneumonia as per the IMNCS classification. Same thing only given. Here in this diagram, you will get the PDF also. So here you see the initial part was your previous classification and treatment. Please don't sit and read this. I'm just cutting it down. Don't study this. This is what you have to study. This is the availability, newer criteria is this one. Okay. Now, next question. What else? Where else do you see colors in PSM? You see it in the Anganwadi growth charts, right? So let's see that. Question here is type of growth chart used by Anganwadi worker. Anganwadi is related to your ICDS for growth monitoring. NCHS growth chart, IAP, MGRF, CDC. There are lots of growth charts, okay, in the world available. Even in India, we use many types of growth chart in different situations. But for Anganwadi worker, their ICDS growth chart is based on MGRS. Okay. Anganwadi growth chart is based on MGRS. I hope all of you have seen the growth chart, right? Anganwadi growth chart, you have two different growth charts. One is for boys, one is for girls. Boys, blue colored growth chart. Girls, pink colored growth chart. Okay. And what are you plotting in the growth chart? Usually it's the weight for age. Because in Anganwadi, that's the easiest thing to plot, right? You measure the weight, you plot it. And why not height? Why not height for age? See, what is the use of the growth chart? We are actually plotting the weight. You are asking the mother to bring the child at regular intervals. So there's a chart in which the Anganwadi worker, when the child comes, takes the weight and marks it. So next month again the mother comes with the child, again you mark the weight. Like that you get how is the weight progression. Whether the child is actually gaining weight, if it's going down, if the weight is going down, that means it's indicating malnutrition. So things like that you can get easily if you plot the weight. But height, do you think height changes that rapidly? No, height takes time to change, right? Even if the child is malnourished, only if the child is chronically malnourished, there is a fall in height. And not a fall actually, the child does not attain the required height in case of a chronically malnourished. But the height already attained, it won't go down. But it's not like the case in the case of weight. Weight, even if it's already attained, if the child is starving or malnourished, that weight can actually come down. So weight for age is a better criteria to mark, to plot growth. That's why we are using weight for age. So that is actually an MCQ. Your what is used is your weight for age. Okay. So what is MGR standing for? Multicentric. There was a study called your multicentric growth reference study. Okay. There is a multicentric growth. There was a multicentric growth reference study. What was this? This was a big cohort study. It's a big cohort study done in more than almost 8,000 healthy kids, 0 to 5 years, from 6 countries. So it was a cohort study conducted, multicentric growth reference study. It was a cohort study done on around 8,000 something population, 8,000 kids of the age group less than 5 years, okay, 0 to 5 years, from 6 countries, 6 different countries. And you have to note that the children were actually healthy. They have to define the cutoff. The children selected were exclusively breastfed, healthy kids were selected for this cohort study. Based on this cohort study only, we have all the cutoffs saying that this is the value for 2 standard deviation, this is 3 standard deviation, or below this weight, this is malnourishment. Everything comes from this cutoff for the ICDS growth chart. Okay. So, which are the 6 countries? You have a mnemonic here, your big sun. Okay, we'll just write it down. P is for Brazil, India, Ghana. S is for your states, sorry. S is states or USA. That is United States of America. I'm just writing it as S. Okay. O is for your Oman and N is for your Norway. These were the 6 countries which were involved in this MGRS study. Okay. Now, we'll see some points about your ICDS growth chart and your WHO growth chart. What I'm going to show, what I have in picture is actually your ICDS growth chart. I don't have a WHO growth chart picture. Please go and just Google it down and just see how a WHO growth chart looks like. Okay. So this is your ICDS growth chart. You have a growth chart, weight for age growth chart for the boy. You have a great weight for age growth chart for the girl. It's not just a weight. You get many other details also. You get the date of birth. You get this. It's actually a book. It's a card, right? That there's a date of birth. There are details about the mother's ANC, any risk factors during her ANC. The child's birth weight is marked in the growth chart. Then regarding details regarding the sibling. So many things you get from the growth chart. So this is how a boy's growth chart looks like. And what are the 3 lines? There are 3 lines in a growth chart which you should know. Okay, I'm drawing those lines here. So one line is like this. That's the first line. This is your second line, and here you have your, this is your third line. Okay, you see 3 lines are there in the growth chart. I'm saying this because in the WHO growth chart you have only 2 lines, but in the MGRS or the ICDS growth chart you have 3 lines. And what is this? This first line, that is the above the green, is your reference standard. Okay. Now what is this? This one is showing minus 2 ST, that is below 2 standard deviation. Similarly, the third line is showing minus 3 ST, it is below 3 standard deviation. Okay, so the green first line is the reference standard, then you have a minus 2 ST line, then you have a minus 3 ST line. This is for boys chart. Similarly, same thing applies for the girl chart also. 3 lines, reference, minus 2 ST and minus 3 ST. Okay, now because of these lines, you see 3 different color zones. You have a green, you have a yellow, you have a orange kind of color zone. So what is this green? Green is actually good. Your green is your normal zone. This between your reference and above your minus 2, this is your green. That is your normal zone. Okay. Other than green, what else you have? You have your yellow. Yellow is for undernutrition. Between minus 2 and minus 3 is undernutrition. And then you have your red, which is your severely undernourished. Okay. So what is our aim? We want to keep the child in the normal zone. When you're plotting the weight of the child, so in this chart, when the mother comes, the weight's being plotted, right? So when you're plotting the weight of the child, you want the weight to be in the normal green zone. That means you're safe. So your objective becomes, so objective is keep child, the weight of the child in your green or your normal zone. Okay. Now, when you're plotting, sometimes what happens is instead of this growth chart is also known as a road to health chart. Okay, the road to health chart. So it should go in this way. But sometimes what happens is instead of progressing, it might, come down, or there should be a flattening of the curve. That is actually danger. So if there is a flattening of curve, it signals what? Growth failure, which can be an earliest sign of protein energy malnutrition, early sign of PM, flattening of the curve. Okay. Now, few points about the WHO growth chart. We'll just add that also. Whatever I've told now is regarding your MGRS or your ICDS growth chart, which you have usually see. But they can ask you questions from the WHO growth chart also. Okay. I'm just writing down the few points on the WHO growth chart. So WHO growth chart. You have only one chart. There is no separate chart for boys and girls. One chart for boys plus girls. No separate chart. First point. Okay. Then I told you in the MGRS you had, or ICDS you had 3 lines. In WHO growth chart there's just 2 lines. Okay. Suppose this is the growth chart. There is just Not exactly this, but something like 2 lines. In WHO growth chart, you see only 2 lines. And what are the 2 lines standing for? First line or the top line is for your boys. It shows the weight of boys. So that's the 50th percentile. 50th percentile of boys weight. And here it's the girls. The lower part is your girls' third percentile weight. Okay, the lower graph. Okay, and this area, this area, you see between this. So the child should actually, the weight of the child, for the normal child, the weight should come somewhere between this, between these 2 lines. This is your road to health. This is actually what is called your road to health chart. Okay, this is where your baby's weight should come. Then, and this is based on not MGRs. WHO growth chart is based on NCHS standards. It is the National Center for Health Statistics. Just remember NCHS standards, okay, for WHO growth chart. So that is about your growth chart. Now, and so another name for growth chart, road to health chart. Then what is part it? Weight for age, okay. Then types of growth chart. ICDS uses MGRs, fine. Now, we are moving on to the last color coding, which is your triage, okay. So, okay, I already told the answer to this question. So, during a disaster, rapidly classifying the injured on the basis of likelihood of their survival. Important sentence. How do you classify them? In a triage is on the basis of likelihood of their survival. With prompt medical intervention is part of your triage. Simple question, all of you know it. So, not just in disaster, even in the casualty, the triage system is followed, and it is not based on triage system is not based on first come first served the basis. It is based on the survival, the chance of survival or the likelihood of survival. Based on the injury, you see how much this person can be survived. What is the likelihood of survival? That's the basis for triage, and it's not first come first served basis. Okay. So in triage, you have the color coding. You have 4 colors. You have red, yellow, green, and black. Red is the highest priority. Okay. Red is the highest priority. In under red, who are there? Patients who require immediate treatment. That is, patients whose life or limb can be saved if immediate interventions are done within the first 6 hours. Those people come in your red. That is a patient requiring immediate treatment. Under yellow, you have patients stable at the moment, but they will require treatment. No, if there's a surgery, if it is posted within 6 hours, the surgery has to be done. The patient should be in the red category. If the surgery is needed, he needs treatment, he needs admission, but surgery can wait up to 24 hours and all that. Then the patient goes to the yellow. Okay, so it is the patient is classified under the yellow category. Okay, this is high priority. Then green is ambulatory patient with mild defects only. That person can be just managed and you can send the patient home. So green is your low priority. And black is the dead patient. There is no point of surviving, no point of doing anything, right? So that's your least priority. Okay, remember highest, high, low, least. Then what else about your disaster? So since this question is based on disaster, I'll just say a few MCQs from disaster management. Tell me the most common disease you get in post disaster phase. In the post after a disaster, its most commonly seen disease is diarrhea. Yes, gastroenteritis. There is no safe water. There is no proper after a disaster, suppose an earthquake or any disaster, there is difficulty in getting safe water for drinking. Sanitation, you don't have water, no proper excreta removal. So things like that happen. You are very much prone for gastroenteritis. Okay. Then second one, most common vitamin or nutrient, micronutrient deficiency is because of diarrhea. And what are the other diseases you can get? You can get measles. Patient can have the people living there in the post disaster phase can have vomiting, measles, diarrhea. All this causes a loss of vitamin A. So the most important vitamin deficiency is vitamin A. Other than vitamin A, you also get deficiencies of because of there's no proper food. There is vitamin C deficiency. The patient can come with scurvy. Vitamin A units, night blindness, right? Then patient can have niacin deficiency causing pellagra. Even if the nutrition is not poor, after a period of time, patient can develop iron deficiency leading to anemia also. Okay, so most common vitamin deficiency is your vitamin A. Then regarding some points about the what is the foremost step for disease prevention and control in post disaster. So what's the first step that you should, to prevent and control disease? What is the first step that should be done after a disaster? First step, always important, is safe water and sanitation. Okay. So the first step for safe water is chlorination. Okay. A foremost step to be done in a disaster phase. It's not vaccination. You're not going to vaccinate everybody. Yes, I know it's a disease-prone situation, but there's no point in giving vaccine to everyone, right? Before that, you have to ensure there is safe water and sanitation. And safe water, we have one step, which is your chlorination, and the level of residual chlorine. How much is the level of normal water, you say? What is the level of residual chlorine? After well chlorination, say at least 0.05. That is your chlorine residual should be there. But in case of post-disaster, 0.5 is not enough. So you have 0.7, okay? 0.7 ppm. Your chlorination, the residual chlorine should be more than 0.7 ppm in case of post-disaster, okay? So it's vitamin A, gastroenteritis. And regarding vaccines, routinely we don't recommend, immunization, vaccination for people affected in post-disaster areas. Yes, you do give vaccines to your healthcare workers who are going and helping them. And if at all, if there is one vaccine that has to be given, that would be the measles vaccine. Why? Measles vaccine, because I told you there's already vitamin D deficiency. There's measles, there's high chance of measles. Again, the vitamin D deficiency will further increase. And measles vaccine for whom? For children. Okay, less than 5 years, you prefer measles vaccine to be given in post-disaster phase. But routinely, there is no policy for routine vaccination in a post-disaster phase. Okay, this diagram is nothing but your disaster cycle. Okay, this is your disaster cycle. You have the different phases of disaster. You have first, there is an impact. This is the disaster impact. Then you have the first response. Then comes the recovery or rehabilitation. Then goes the mitigation, and finally preparedness. You should know the order in the cycle. They can ask you to write in the select the logical sequence of events in a disaster cycle. Can be asked. Okay. So response, recovery, mitigation, and preparedness. What is this mitigation? Mitigation is nothing but you are trying to minimize the effect of the disaster, or the textbook definition says mitigation, steps taken to minimize the impact or minimize the effects of the bad effects of the disaster is is mitigation. Okay, so but the textbook definition, I'll just write it down. Mitigation is measures designed to either prevent hazards from causing emergency or to lessen the effect of emergency. Okay, I'm writing this down because this was actually asked, okay? The other way around. Measure designed to either prevent hazards or is called dash. It is mitigation. Okay. Now, that was about your segment. We have finished 2 segments only. We have finished your epidemiology, that is your concepts, confusion controls over. Your second segment, that is your colors, are over. Now we are going to a bit more kind of theoretical segment again, but it's important from your exam point of view. Here we'll be discussing demography, important points only from demography, family planning and screening. Okay, these are also your, at least you get at least one question from demography and family planning and screening. These are sure questions you will definitely get. Okay, so demography, first question: true about late expanding phase of demographic cycle. Options are: birth rate is lower than the death rate begins to decline while the birth rate remains unchanged, death rate declines still further and the birth rate tends to fall, and high birth rate and high death rate. Just read the options and think which is correct about the late expanding phase. They have told what late expanding phase, what is true regarding the late expanding phase of the demographic cycle. Okay. So the answer here is the late expanding phase of the demographic cycle. Option C. You see, death rate declines further and the birth rate tends to fall. This is there is no 6 here. Okay. Death rate declines further, birth rate tends to fall. This is the correct answer for your late expanding phase of demographic cycle. Okay. To understand this, you should know what a demographic cycle is. You should know all the phases of the demographic cycle, what happens to the birth rate and death rate in each cycle, and examples of countries belonging to different phases. Okay, very simple. Listen carefully. Don't try to buy hard. Just try to understand this with me so that you are clear with the demographic cycle, the phases, and all the questions you will know if you just understand this particular graph. You see a beautiful diagram on screen, right? So what is it showing? This is your demographic stages or the phases of the demographic cycle. Okay, so this is your demographic stages and your 5 phases. Okay, so you can see 1, 2, 3, 4, 5. That is 5 phases in a demographic cycle, correct? Then what is plotted? On your y-axis, you have birth or death. It can be either birth rate or it can be the death rate per thousand with your population. Okay. X-axis, you have the time, the progression of time, and then you have 5 phases. See, every country will actually have a change, will actually transit through all these phases. Every country will begin with a phase 1, then later once the country is developing or there's more of industrialization or the country is changing from a developing country to a more developed country, what happens is the phase also changes. From phase 1, we just move to 2, 3, 4, 5 like that. Along with the development, the phase also changes from 1 to 5. For example, India was initially in the phase 1. Now we are in the phase 3. So that changes happen for every country, but at a particular different pace for each country. Okay. Now, in your demographic cycle, you can see 2 graphs here, right? One is the pink one showing the birth rate and the blue one showing the death rate. So, every demographic cycle, all stages are based on the changes in the CBR, crude birth rate and crude death rate. Okay. So you have your birth rate and you have your death rate. Okay. According to the changes in the birth rate and death rate, you change the phases. Now, we'll just write down what is happening in each. Okay. So, you have your death rate and birth rate, and then you have something called demographic gap, DG. I'm writing it as DG only. DG is the difference between birth rate and death rate. That gap, demographic gap is death rate, sorry, birth rate minus death rate. That is a demographic graph. Okay, so you have birth rate, you have death rate, you have demographic graph gap. Now we'll see what is happening in each stage and we'll try to name all the stages. Okay, see the phase 1. In the first phase, you see here what happens is initially when a country is in the developing or in a very primitive phase, what happens is we don't have much of medicines, we don't have much of family planning, we don't have very good treatments. So you have a very high death rate because we don't have good treatments. People are dying like anything. So very high death rate. Plus there is no family planning at all. So very high birth rate. So you have high birth rate and high death rate in the first stage. That is what you see here. See, both the graphs are at the topmost, right? Both you have high birth rate as well as you have a very high death rate. So both are high. Birth rate is also high, your death rate is also high. This stage, everything where both birth and death rates are high, this is called your high stationary. Okay. So this stage is called your high stationary. So phase 1 is high stationary. Then coming to your next phase, then what happens? So once the country starts progressing, you think which will improve, which will become better first, whether it's the medicines or the family planning. You give more importance to the life and the medicines and treatment part, right? So once the country is starting improving, once the country is developing further, what happens is you have better medications, you have better treatment, whereby you are able to bring the birth rate down. Sorry, the death rate down. Because of the better treatment, you are able to bring the death rate down. So what happens in stage 2? Stage 2, your death rate starts coming down, but nothing with the birth rate, it's still high only. See, the graph birth rate is still at the higher level, but because you have improved your medical treatment center and all that, your death rate starts coming down. So this stage where birth rate is high and death rate start coming down is called your early expanding phase. Okay, high stationary is over. Now we have your early expanding or phase 2. It's called early expanding. And you see the gap here between the birth rate and death rate. This gap is actually the highest here, right? You see here, compared to all other, the gap between your birth rate and death rate or your demographic gap, DG, is DG is maximum in phase 2, okay, or the high expanding phase. That's why it's called expanding. The population has a population explosion or population is expanding like anything in your phase 2. So here DG is high. This is maximum here, okay. Maximum demographic gap is seen in your phase 2, okay. In phase 1, DG is very narrow. There is no much difference between your birth rate and death rate, so it's narrow. But in this phase, it is actually high, okay. Now, if there is an early expanding, obviously there should be a late expanding phase, right? So the phase 3 is called the late expanding phase. What happens here is, because of the betterment in your health sector, your death rate is actually decreasing, okay, but it's a slow decrease. But now what happens is you started thinking about family planning methods. So you started focusing on family planning also. So because of that, because of better family planning methods, now your birth rate also comes down. Okay. So your birth rate comes down, but your this thing death rate is also coming down. This is your what phase? This is your late expanding phase. So birth rate is coming down, death rate is also coming down. Okay. Then what happens is, again, once the country progresses further, again your birth rate comes down only, but this time slower than the initial one, okay. But your this is also slow. Then in phase 4, again the birth rate is also coming down, death rate is also coming down, but both are at a lower phase, okay. Slow fall, and it's almost again the same. The gap is very narrow here. Okay, this phase where both are low is called your low stationary. So you have high stationary, early expanding, late expanding, low stationary, and low stationary both are low. Birth rate is low, death rate is low. In high stationary, both were high. Okay, and here also your DG is narrow. And one thing I forgot to tell about late phase 3 or the late expanding phase here. In late expanding phase, your demographic gap starts declining, because in phase 2 or the early expanding phase, you had high birth rate and very low. Death rate was starting to fall, so that gap was very much, right? But once your birth rate is also coming to fall, what happens is this gap between the birth rate and death rate is coming narrow, right? It's shrinking. So the phase where the demographic gap starts shrinking is your phase 3. Phase where the demographic gap is maximum is your phase 2. Okay. Now, once it develops further, and almost the death rate, what happens is after a point of time, that is when you come towards the last phase or phase 5, which is called the declining phase, death rate almost stabilizes. You can't bring it further down, okay? It's almost low or stabilizes. But your birth rate again starts falling, okay? So here what happens is birth rate goes below the death rate. You have higher fall in birth rate. You see the graph here, birth rate is coming lesser down than the death rate. And what happens to the gap? It is reversed, right? DG, the DG is the birth rate minus death rate. So if death rate is, this is the more, then this becomes reversed, or this is declining. Okay. So you have high stationary, early expanding, late expanding, low stationary, and declining. 5 phases. Demographic gap maximum in phase number 2. The demographic gap starts to shrink in phase number 3. Then declining is the phase where your birth rate is very low. Then it comes lower than your death rate. And examples are India was initially, very years back, it was in phase 1. But now India is currently in phase 3. Okay. So the 3 is where India is. How do you remember this? Late expanding, okay? Just for the sake of mnemonic, I'm saying, no offense, but we Indians have a tendency to be late. We are always late for the classes, late for exams, late in our studies. We have a tendency, we are kind of quite lazy, so we have a tendency to be late. Because of that, India is the late expanding phase, okay? So late expanding is where India is. Declining phases in your developed countries. Highly developed countries like your maybe your UK, Japan, Germany, all these people have the currently are facing the phase 5 or in declining phase. Okay, so India is in phase 3. Two more words I want to tell you here is demographic gift and demographic trap. Okay, so see, when the birth rate is actually high and death rate is low, what happens is you have more of a younger population in the country. Okay, so but when the birth rate is falling further, it's more of an aging population, right? So as far as your phase 2, phase 3 is concerned, phase 3 especially, what happens is in phase 3 you have more of a younger population, or the productive group is more. Okay, here in phase 3 you have more of youth, right, than the aged population. So because of this is called a demographic gift. It's good, right? Having more of the productive age group is better than having more of an aging group as far as the country's development is concerned. So phase 3 is currently in the demographic gift, or we Indians, we are gifted. Indians are actually gifted people, okay? Even though we are late, we are gifted. We are gifted with talents, everything. We are gifted to be born to a country like India. So Indians are gifted. One tip for you. So, and India is in the late expanding phase. You should remember. What is this demographic trap? Trap happens in your phase 2, okay? In phase 2, you have something called demographic trap. Phase 2, I told there is an explosive population growth. When there is such a high population growth, what happens is the country is unable to cater to so much people. At a stretch, the population expanding like anything. Country is failing to cope up with such a high population. This is called a trap. This is phase 2 has a demographic trap. Okay. Now I hope that is correct. Just see if I've missed some points. Phase 2, you have explosive growth. High fertility rate is in phase 2. But DG starts increasing, that's the demographic starts increasing, and the maximum demographic gap is seen towards the late part of your phase 2. Okay, in phase 3, that is in India where we are belonging, we Indians belong to the phase 3, DG starts decreasing. You have to think about the demographic gift here. Then phase 4 is actually the ideal stage. No much issues, no liability, nothing. Phase 5 is called a kind of dying population, or the declining population, or the aging population. Phase 5, birth rate is coming very low, so you have more of a older population. That is phase 5. Okay, so that was about the demographic stages. You can get n number of questions from this cycle. Just study this cycle. Just try to understand it and study 5 phases. What is happening to birth rate and death rate in each phase, and certain particular terms like your demographic gift, your gap, then which country belongs to which phase, like that. Okay, so that was demographic cycle. Just like demographic cycle, you have something called an age pyramid. Okay, this is what you can see on screen. What is this? This is an age pyramid. Age pyramid is a structure where a country's population based on the age and sex is depicted. Okay, it shows the age distribution as well as age distribution pertaining to the different sexes in a country is shown by something called the age pyramid, which you see on screen. Doesn't it mean when you just twist it, it looks like a histogram, right? Two histograms combined, but in the twisted way. So age pyramid is actually a double histogram. Okay. So what you see on screen is your age pyramid. Okay. Or it's also known as your population pyramid. It's all the same. Okay. Age structure diagram. It's all different names for your age pyramid. Fine. Now, what is depicted here? This side, you have two sides. This side is always the male and this side is always the female. Okay, you have male and females represented, and your y-axis you have the age groups, usually age 5-year gap is shown. Okay, this is your numbers shown for the percentage, how many people are belonging to this particular age group. You have the age, if you can see, 0 to 4, 5 to 9, 10 to 40, likewise 5-year age groups are taken, and then you show how many percentage of population belong to this particular age group in an age pyramid. Okay, so age pyramid is also known as question double histogram. True. Then what else can you understand from this age pyramid? See, height of the pyramid. Height of the pyramid is actually showing the life expectancy. Okay. You see the highest point here, it is 90 plus age group. So the more the height of the pyramid, that means the country is having a higher life expectancy. So height of the pyramid is approximate for the life expectancy. What about the symmetry? Symmetry of the pyramid. It shows your what? Symmetrical sex ratio, because it's showing male to female, right? So if there's a symmetrical pyramid, that means the number of males is almost equal to the number of females. That shows your sex ratio. Height shows the life expectancy. Then what are the shapes of pyramids? Types of pyramid. You have the typical pyramid shape, that is, you have a broad base with narrow apex or narrow tip. This is our India's pyramid. Okay, here we are. India is having a pyramid like this. This is the common one you see in developing countries. like India, where we have more of younger population because your birth rate is actually high compared to the death rate. But in developing countries where there's a declining population, you see something called bulge. Bulge in the middle, bulge in the middle point. It looks something like, like this. It looks something like a spindle. Spindle shaped pyramid is seen in developed countries. Okay. This is about the age pyramid. Just one more point. What we missed is what is the dependency ratio? Dependency ratio, you can be asked to calculate, you can get questions to calculate the dependency ratio. It actually tells how many people are dependent to the working population. That is, it gives dependency ratio is your children, number of children less than 15. They are considered dependents, right? Plus uh, elderly people who are more than or equal to 65 is the numerator, divided by your productive age group, 15 to 64 years. This ratio of dependence per your productive age group is your dependency ratio. Okay, this is your working population. Okay, this is the formula for dependency ratio. Children above less than 15 plus elderly more than or equal to 65 comes in the numerator, divided by your working age group, which is between 15 to 64 is the dependency ratio. Now we'll just take a short break for lunch. After lunch break, we'll be continuing with we have 1, 2, 3 questions, few questions from your family planning. Fertility indicators we'll be discussing post lunch. Then we'll be discussing 1 or 2 questions from screening. Then we'll go on to the nutrition part. Okay. So with that, I'm winding up now. Thank you. Hey, Mike. So welcome back. Now we are going to take up a question which is about your fertility indicators. Okay, the question is number of live birth per 1,000 women in the reproductive age group in a year refers to. The options are total fertility rate, gross reproduction rate, net reproduction rate, and general fertility rate. Okay, so what you're asking is in the numerator they have number of live births, and what is the denominator? Denominator they are talking about per 1,000 women in the reproductive age group. So what is this indicator? What is the fertility indicator which gives number of live births per 1,000 women in the reproductive age group? Yes, it is your GFR or general fertility rate. Okay. So now what are the fertility indicators? We'll just quickly revise all the fertility indicators. These are important. You can get questions from these. Okay. So first we'll understand what each fertility indicator is, okay? What is a GFR? GFR or general fertility rate is total number of children a female will bear during her reproductive years, okay? So GFR can be written as total number of children a female will bear during her reproductive years, okay? That is your general fertility rate, okay? Now what is TFR? TFR is the total number of children a female will bear during her reproductive years, assuming the current age specific fertility rate. Okay, so GFR or general fertility rate is the total number of children a woman will have during her reproductive years. Okay, whereas TFR is similar only, total number of children a woman will have during her reproductive years, assuming the current age specific fertility rate. What is this age specific fertility rate? That is, the fertility differs based on age, right? Obviously, the 20 to 24-year age group, they have a better chance of fertility than comparing to somebody who's above 30 years, right? That is age specific fertility rate. When we are considering that also, then your measure becomes TFR or total fertility rate. Now we have two more things. One is your GRR, then is your NRR. Okay, I'm just changing the color. Okay, so third you have GRR or gross reproduction rate. R is for reproduction. Okay, this is the total. GRR is total number of daughters. Okay, in the others, GFR or TFR, when there's an F in the middle, we are talking about the total number of children, be it girls or boys. But when you're talking about R, GRR, remember R for daughter, DAUGTR, right? So GRR or NRR, what we'll be seeing next. When there's an R in the center, your numerator will be always total number of daughters, not sons. Okay. So total number of daughters a female will bear during her reproductive years, assuming this is all the same, just like your TFR, assuming the current age specific fertility rates. Okay, that is your GRR. Next, you have NRR. Okay, NRR is net reproduction rate. Here, N, think of newborn. Okay, it's again the total number of daughters, but not a female. It's a newborn who's going to bear. A newborn baby girl. How many number of daughters she is going to give birth in the future, assuming the current age specific fertility rate plus the current mortality rates. This is the indicator where you are assuming in the assumptions, you are also taking into consideration the mortality rate. Whereas in the GRR, we were not concerned about mortality at all. We were talking only about the age specific fertility rate. But here, when it comes to NRR, one thing is it's the total number of daughters a newborn girl, NRR for newborn girl child will give birth to in future, assuming age specific fertility rate as well as mortality rates. Okay, so I'm just writing it down. So it's the total number of daughters a newborn girl child will bear during her entire life, assuming the current age specific fertility rates and your age-specific death rates. That is, taking into consideration mortality also. Okay. So once again, your GFR or TFR, its numerator is total number of children. Whereas in R, when there's an R in the middle, when it's GRR or NRR, it's always the daughters, total number of daughters. Okay. Now, how do you say about the formulas? CBR or crude birth rate, again, that is also a fertility indicator. It's just like your GFR, GRR, NRR. Crude birth rate is a fertility indicator, but it's kind of a crude value, right? Because it just gives the total number of live births per 1,000 mid-year population, per 1,000 population, which is the mid-year population, number of live births. That is your crude birth rate. Okay. So, see. So, your crude birth rate is number of live births, LB is live birth, okay, by mid-year population into 1,000. Okay. Now, I've put all these things together. You know why? Because the numerator for all these indicators, that is your CBR, GFR, GMFR, and ASFR, all these indicators, the numerator is number of live births. Okay. So, crude birth rate is number of live births by mid-year population into 1,000. Your GFR or general fertility rate is your, again, number of live births, but instead of mid-year population, you are only considering women in reproductive age group. Okay. Into 1,000. Then you have general fertility rate. In that, if I add the marital marriage also, it becomes GMFR, that is general marital fertility rate. That is the number of live births by, instead of women in the reproductive age group, I am seeing all the married women. Okay. Married women in reproductive age group into 1,000. Okay. The last one, ASFR or age specific fertility rate, is again number of live births. There is no change in the numerator. Okay. Divided by, women in that specific age group, whatever age group they are mentioning, that one. Okay. If it's if it's 15 to 19, you take it that, or your 20 to 24, like that, whatever specific age group is, that is the denominator, women in that specific age group into your 1,000. Okay. So CBR, GFR, GMFR, ASFR all have numerators live birth, only the denominator is changing. And what is this reproductive age group? I forgot to tell. Women in reproductive age group means women who's in the age group of 15 to 49. That is the reproductive age group. Okay. So CBR, 4 indicators where the live birth is numerator is over. Now, another relationship between your CBR, crude birth rate, and your TFR. This you should know. Okay. Crude birth rate is 8 times your total fertility rate plus 1. You should know this formula. Sometimes they can give you the TFR and you will be asked to calculate the crude birth rate. So you should know this formula. Now we'll come to the other 3 indicators, that is TFR, GRR, and NRR. Okay. You see here, the TFR is total fertility rate. It is average number of children a woman will have throughout her reproductive years. It is average number of children. It can be girl, boy, whatever. Okay. And the TFR, actually, how do you calculate? It's not a direct value, because if you want to calculate the TFR, you have to wait for the all women to complete the reproductive age, then only you will get the TFR, right? So instead, what you're doing is you calculate all the age specific fertility rate. TFR is kind of a sum of all the different age specific fertility rates. Okay. Now your GRR and NR, I told you if there's an R in the middle, remember R is for daughter. Okay. So your GRR is the number of girls. Number of girls born to a female in the reproductive age group, assuming the age specific fertility rates. Okay. Whereas NRR is number of girls a newborn girl will bear. Sorry, number of daughters a newborn baby girl will bear in future, assuming your age specific fertility rate along with your mortality rate. Okay. And what is the relationship between GRR or NRR and TFR? Usually, the GRR, the gross reproductive rate or a net reproductive rate, approximately it will be half of your TFR. Again, they can give you TFR and ask you to calculate GRR. Okay. Now, you say NR or net reproductive rate is equal to 1. This is called the replacement level. This is called the replacement level of fertility. That means one generation is actually one generation is equally replacing another generation. One doctor after her life, another daughter. That is the NRR equal to 1 means that is where your replacement level, the fertility attains a replacement level. And you should know that you know something about CPR, that is couple protection rate. Couple protection rate is a value which gives the prevalence of use of contraception, right? Couple protection rate is after the total eligible couples, how many couples are actually using a method of contraception. That's a couple protection rate. So to attain an NRR of 1, your couple protection rate should be more than 60. Only if a population has a couple protection rate of above 60%, then you can attain an NRR of 1. Okay. Now we'll move on to the next question from contraception. Contraceptive efficacy is measured by, your options are Pearl index only, Pearl index life table analysis, Pearl index couple protection rate, and life table couple protection rate. All of you know that couple protection rate, Pearl index is, Pearl index is something that is used to measure your contraceptive efficacy. Okay, but the answer here is not Pearl index, it is actually B. Pearl index as well as life table analysis. Both are methods used to measure your contraceptive efficacy. Okay, so in fact, the best method is life table analysis. So we'll just write down the MCQ points. Best method for contraceptive failure rate, it's actually not Pearl index, it is life table analysis. Even though Pearl index is the one which we are most frequently used as Pearl index, but best methods are always life table. Okay. Second one, it's a one MCQ. Most commonly used is your Pearl index, no doubt in that. And what is Pearl index? Pearl index is the number of failures. By failure, contraceptive failure means number of accidental pregnancies, right? Number of failures per 100 women years. You also write it as like this, HWY. Okay, this is your of exposure. This is your Pearl index. Out of 100 women is how many accidental pregnancies occurred. Okay, that's your Pearl index. And who is an eligible couple? You have heard the term eligible couple. Eligible couple is a couple where the woman is in the married couple where the woman is in the or the wife is in the reproductive age group. That's an eligible couple. Okay. So Pearl index, what is the formula? Pearl index, you get it by total number of accidental pregnancies divided by total months of exposure. For calculation purposes, this is the formula you use. Okay, the same thing what I've written above, just writing it as a numerical formula. Total accident pregnancy by month of exposure into 1200, because 1 year has 12 months, so we're converting it, so it becomes 1200. This is the formula for your Pearl index. There is one more formula for the Pearl index, that is same thing, total number of pregnancy or failure by total number of cycles, menstrual cycles in a year, into 1300, because we are assuming in a year a woman will have in an average of 13 menstrual cycles. So if that is given, you can calculate Pearl index by total number of accidental pregnancy by total number of menstrual cycles in a year into 1300. Both these are formulas for Pearl index. Okay, then so you know the formula for Pearl index. Now we should know, you should know the Pearl index for some contraceptives. Okay, suppose there is no contraceptive use. If the couple is not using any contraceptive, the Pearl index is very high because there is high rate of pregnancy failure rate. So no contraceptive, it's 80. If somebody is using condom, can be either male or female. The Pearl index is 2 to 14 for male condom and 5 to 21 for female condom. For IUD and OCP, you have actually comparatively very low Pearl index. That is a higher protection from pregnancy. Okay, IUD is 1 to 5 and OCP is 0.1 to 2. and Sahel or your Centroman, the Pearl index is 1.8 to 2.8. Okay, these have been asked. Your IUD, OCP, even the male or female condom, one of them was asked. Your Pearl index. Then in the options you had something called the couple protection rate. I told you couple protection rate is it gives a prevalence. It gives a prevalence of the contraceptive practice in a community. How many contraceptives are being used? How many couples are using contraceptives? Okay. So your CPR or couple protection rate is the total number of eligible couples. Who is an eligible couple? Married couple where woman is in the reproductive age group. Eligible couple protected by total number of eligible couple protected by any of the 4 approved methods. Which are the 4 methods? I'll tell you. So, total number of eligible couples protected by any of the 4 approved methods divided by total number of eligible couples in a community into 100 will give you your couple protection rate. And what are the 4 methods? According to the program, the 4 methods which are used in calculating couple protection rate, one is condom, IUD, OCP, and sterilization. It can be either tubectomy or vasectomy. Okay. So this is the couple protection rate. And we have something called effective couple protection rate. This effective CPR, if you ask, here what happens is same as couple protection rate. But in addition, you are considering the effectiveness of each contraceptive. Okay. That is the effective couple protection rate. And the current CPR of India. How much is the current CPR? It's 54%. And I told you only if the CPR is above 60%, we will be able to attain the net NRR of 1, which is the replacement level fertility. Okay. Now we are moving on to the next question. The question is, a woman on combined OCPs forget taking them on 2 successive doses. Next line of management is. So there's a woman who's using OCPs. She forgot to take the tablets on 2 successive days. So what do you do next? So here, the answer here is she have to shift to a barrier method. Okay. So if somebody forgets to take OCP on 2 successive doses, the answer is shift to barrier method of contraception. Okay. So if it's forgotten only on 1 day, there's a female committee, she want to take OCP on 1 day, just 1 day, then what do you advise her? If it's a 1 day, forgot for 1 day, then she should take the tablet as soon as possible, or she can take 2 platter. Instead of that, she can take 2 tablets the next day. Okay. If somebody forgets OCP for just 1 day, you should advise the person to take the tablet as soon as possible, or she can take 2 tablets the next day to compensate for this. Then after that, from the 3rd day onwards, she can continue uh, routinely as 1 tablet per day. There is no issue with that. But suppose somebody forgot to take tablets on 2 days, then there is no point in, because the whole cycle will get interrupted. So if somebody forgets to take the tablet on 2 successive days, then the option is she has to stop the OCP. She has to shift to a barrier method of contraception, and at the end of the cycle, she should do a UPT test because there's high rate of failure or high rate of pregnancy. So that is your answer for this option C. So if it's forgot on 1 day, then take the pill as soon as possible, or 2 pills next day. After that, follow the usual 1 pill per day. Okay. If she forgets on 2 days or 2 or more than 2 days, then shift to barrier method plus advise her a UPT, urine pregnancy test. Okay. Now we'll just see some of the contraceptives and commonly asked questions. Just a quick review. Okay. So what is this you see on screen? You see iPill, right? iPill is your progesterone only pill. Progesterone only pill. What is it used for? Emergency contraception. For emergency contraception, what are the options you have? Emergency contraception can be done using OCPs, your progesterone only pills, even IUD. IUD is also a very good method for emergency contraception, provided you have to take it within a particular time. So, for example, in case of your progesterone only pills, in case of oral pills, the for emergency contraception, the first tablet should be taken at least within 72 hours of the intercourse. That is important, okay? But in case of IUD can be inserted within 5 days of the intercourse, following the intercourse, for emergency contraception. Actually, IUD is a better it's more effective than your progesterone only pills or all the pills for emergency contraception. But due to the difficulty, inconvenience, because IUD person cannot put it alone, right? They'll have to go to health sector. So because of that, usually most preferred is your pills, which is mainly your progesterone only pill. Okay. So what is the dose in I pill? You have 0.75 mg LNG oral tablet, right? In one pill, you have 0.75 mg LNG oral tablet to be taken within 72 hours. You take the earlier, the better, but at least within 72 hours. This is the first dose, and second dose should be repeated, the same dose only, that is 0.75 mg LNG 12 hours later, 12 hours after taking the first dose, take the second dose. Okay, now what is this diagram you see here? Second one you're seeing an OCP pill. In the OCP strip, what you'll have 21 days of OCP or the hormonal pill, and then on the time when the girl is menstruating, you will give her 7 days of red pill. What is the red pill? Actually, it's actually INI-FA, or it's iron, not IFA, iron tablets. It's ferrous fumarate. Okay, is given. Fine. Now, Mala N and Mala D both are OCPs. Yes, they have both progesterone as well as estrogen. So, what is the difference between Mala N and Mala D? N is for no cost. Okay, whereas Mala D you have to give 5 rupee per pack. Both these Mala N and Mala D are under the program. We are supplying it at health center levels, but Mala N is free of cost and Mala D is having a subsidized cost. Okay, so what is this Nishchay? Nishchay, anyway, nobody is going to show you this Nishchay kit and ask you to identify it, because everybody knows it's a UPT kit, right? But they can ask you the name. Nishchay is your UPT kit. Nishchay, okay? Whereas something else, you have Nikshai, right? Nikshai. Kshay is TB. This is related to TB. Nikshai is your TB portal. Nishchay is your UPT kit. Okay? Moving to the next question. What do you see here? This is it's already written on, name is already written. It's a vaginal sponge. Okay? This is your vaginal sponge. The brand name is Today. What is a vaginal sponge? It's actually a barrier method only. Just like condom, it's a barrier method of contraception. But along with the barrier method effect, it also has a spermicidal agent in it, which can kill the sperm. Okay. Then, what is the difference from barrier method? Cannot offer protection from STDs. Okay, there is no protection from STDs. Barrier methods, usually the condoms and all, they also, along with allowing contraception, it also gives protection against sexually transmitted diseases, including HIV. But in this sponge or your vaginal sponge, there is no protection like that. And also, it has a risk of toxic shock syndrome. Okay, that was sponge. Now, few points about this. What is this? Noristerat is a depot formulation. It's an injectable progesterone. Okay, injectable progesterone. Other than this, you have your Antara, which is your DIMPA. Depot medroxyprogesterone acetate is another option for your injectable this thing, which is given once in 3 months, right? So what is this? This is your natural method, one of the natural method of contraception, which is called the rhythm method or the calendar method. Okay, where the couple should abstain from intercourse during that ovulation period. Okay. Now, what is this? You see, something implanted on the forearm. What is this? This is your implant, or this is actually Norplant. Okay. No, this is actually the Norplant is the contraception with very low failure rate, or you can say the lowest failure rate. But actually, we are not providing this in the program. But the one with the lowest failure rate is actually Norplant. Okay. And what is this? Norplant has 6 elastic capsules. Each have 35 mg of LNG. Okay, this is your Norplant. Now on screen, now what I'm going to show you is copper Ts. These are all different. Sorry, these are all different IUDs. Okay, you have 1, 2, 3, 4 photos here. So the first one is your Mirena IUD. Your second one, this is your copper T380A. Third one, what is this? This is your multi-load. Yes. And finally, what is this one? Very famous. Previous year question also. This is your lippish loop. So IUDs, you should know the classification. What are the first generation IUDs, second generation, third generation? First generation is inert IUDs, no medicine, nothing. Second generation is your medicated IUDs, and third generation you have your hormonal IUDs. Lippish loop, Grafenberg's ring. There is something called a Grafenberg's ring. I don't have a photo here, but if you just search, you can see the Grafenberg's ring. It looks like a ring, a copper colored ring. That is also an example for your first generation or your inert IUDs. Okay. Then two more questions about IUD. Which is the most common side effect? Most common side effect of IUD is what? Bleeding. Okay. Bleeding PV is the most common side effect. But what do? You actually bleeding will subside after 2 or 3 months. Initial phase, the lady will have bleeding, but after 2 or 3 months, you just reassure her bleeding will actually subside. But what's the most common side effect resulting in removal of IUD? It is not bleeding, it's actually pain. Some women will have abdominal pain and all that. This pain is usually the most common side effect, which leads to the lady telling, I don't want IUD, I just want to remove it. So removal is pain, otherwise the most common is bleeding only. Okay. Now what is this Sencromen? And two Sencromen tablets I've put here, right? One is your Saheli, then one is your Chaya. Both have your Sencromen only. Okay. And what is the content in this? Ormel, Ormeloxifene is the chemical name. And what is this? It's actually a selective estrogen receptor modulator. Okay. Now, what is the dose? It is 30 mg tablets. So, for the first 3 months, you give it as twice weekly. Okay. Twice weekly she had to take for the first 3 months. Afterwards, it is given once weekly. So, it's also known as, week pill or weekly given pill. That is your Saheli or Chaya. Then Antara, we already told, it is the medroxyprogesterone injection, not DIMPA injection you give. And what is the dose here? This is DIMPA, dipot medroxyprogesterone acetate, 150 mg IM is the dose. 3 monthly. Every 3 monthly you have to give. Okay. What is this? This one with 2 rings. The condom with 2 rings is a female condom. One MCQ is the only contraceptive which can be initiated and controlled by a woman for HIV prevention. It's actually female condom. Okay. It's not just HIV, any STD prevention, but initiated or controlled by women for HIV prevention. This can be a female condom. Okay. So that was about family planning contraception. Now we have a question from screening. Okay. So screening, the question is, which of the following statement is true? Options are: positive predictive value increases with increasing prevalence, specificity depends upon prevalence, sensitivity depends upon prevalence, and positive predictive value decreases with decreasing prevalence. Which one of the following is true? What is the relationship between positive predictive value and prevalence? And what is the theorem? What's the name of the theorem which states this relationship between your predictive value and your prevalence? It is Bayes' theorem and they are directly proportional. Yes, positive predictive value is directly proportional to your prevalence. So, when prevalence increases, positive predictive value increases, and when prevalence decreases, positive predictive value decreases. Okay. If you have a doubt, you can actually just draw and look, just draw two 2 by 2 tables. Take the population as 1000 in both, take sensitivity 90%, specificity 90%. Okay. And one table do for a prevalence of, considering a prevalence of 5%, and this side take a prevalence of 20%, and just see and just do the calculations and see, and you can see that positive predictive value is actually lesser when you have a lesser prevalence, and positive predictive value increases when you have a greater prevalence. Okay. Similarly, just like I told about positive predictive value, what about negative? It's inversely. NPV is inversely proportional to your prevalence. And what do you call this theorem? It is called your Bayes theorem. Okay. Your option A, positive predictive value increases with prevalence, is the correct answer here. Okay. Now we have to see what do you mean by the sensitivity, specificity, positive predictive value, negative predictive value. Very simple, but still confusing and always asked. Okay. So for any screening test, there are certain inherent properties of the screening test. So those are, one is your validity and one is your predictive values. So what is validity? Validity is the accuracy by which your test measures what it is supposed to measure. Okay. So what the test is supposed to measure, whether the test is measuring it correctly or not, accurately or not, that is your validity. And validity has two components. One is your sensitivity, the other one is your specificity. Okay. And what is sensitivity? Sensitivity is how well your test detects those who are actually deceased from the total pool of the deceased population. Okay. How correctly your test says true positives, or correctly your test selects the true positive or those who are actually deceased from the total diseased population. And what is specificity? How well your test can actually exclude those who do not have the disease, or how well your test says these people don't have the disease from the healthy population. That is your specificity. Okay, I'll just write it down, and after that, after writing this down, we'll say what is the predictive values. Okay, so let's start a page here. Okay, so we are going to write what is validity. Validity is how well or what extent your test measures what it is supposed to measure. Right. You have two components of validity. You have sensitivity and you have specificity. Okay. Sensitivity is how many are correctly picked as deceased or true positives from truly deceased or the total deceased population. Similarly, specificity is how many are correctly picked as non-deceased or not having the disease, okay, from healthy population. Clear? Sensitivity, specificity, I hope it is clear. Now, what is this predictive values? You have a positive predictive value and negative predictive value. Okay, you can remember it as predictive values are something which measures the diagnostic power of a screening test, okay, is measured by your predictive values. There you have, under predictive value, you have your positive predictive value, PPV, and your negative predictive value. Okay. So diagnostic power of a screening test means if there's a screening test and how correct the results of your screening test are. If your screening test is saying this many people are positive, in reality, whether they are positive or not. Okay, that is your positive predictive value. Similarly, negative predictive value is out of those people branded as not having the disease by your test, how many are actually not having the disease. Okay, so that is basically based on what your test says and what is the truth. So that's a predictive value, that is positive predictive value and negative predictive value. Okay, now that is power to, or positive predictive value, you can say it's a power to correctly identify the deceased. Power of the test to correctly identify the disease. Similarly, this will be power of the test to correctly exclude the non-deceased. Okay. Okay. So this is your predictive value. And just one more concept. You know what I'm going to say, right? We are going to talk about the reliability and validity. What do you mean by reliability? Reliability is your repeatability. Same test without changing any situation. If I'm doing it repeatedly, I should get the same value. That is, it should be repeatably consistent. So that is your repeatability. It's also known as the precision. Whereas validity is whether your result is correct or not. That is your accuracy. Okay, for example, this, see, these are my test results, okay? But this is the correct value. See, my test results are nowhere around the correct value, but their consistency repeatedly coming in the same area. So this is actually the reliability or repeatability. That is, this case you can say reliability is there. But if for the value to be valid, it should come here. Okay, see you this in this case, what happens is here there is validity. It's all coming near your bullseye, near the central point, so it's valid. But again, reliability is not that much because these points are scattered. But if I have something like this, here I am having some dots like this, okay? This is both reliable, that is repeatably you're getting in the same place, plus your answer is correct actually, so it's valid, okay? Now, last one from screening, how to calculate. How do you calculate the sensitivity, specificity, positive predictive value, negative predictive? When you're given a calculator, when you're given a numerical question from the chapter of screening, first step, just like your odds ratio, relative risk and all that, draw the 2 by 2 table, okay, compulsory. In the 2 by 2 table, always disease is on the top, those who are with the disease, those who don't have the disease, okay? Then you have screening and positive and screening negative. This is your test result. According to your test, who is positive, who is negative, okay? So if the person is disease positive and screening positive, he is a true positive, right? If the person is not having the disease and the test is also saying not having the disease, is a true negative. The rest will be false positive and false negative. So just make the table like this, and this is how you calculate. If I put two arrows like this, okay, here this will give you the sensitivity, and this is your positive predictive value. Or sensitivity will be, numerator will be TP. TP, true positive, divided by, this is the direction, right? So here I have TP and FN. So TP plus FN is your sensitivity. Positive predictive value, the numerator is again TP, or true positive, divided by, this is the direction. So it's TP plus FP, right? Similarly, if I want to calculate specificity, I'll just draw the arrow like this, and negative predictive value. So specificity, it will be Tn divided by Tn plus Fp. This is the direction. Whereas negative predictive value will give you Tn by Tn plus Fn. So these are the formulas, these are the concepts about the sensitivity, specificity and the predictive values. Draw the 2 by 2 table, mark the arrows, do the calculation and get the mark, okay? So that is about screening. And okay, one more point about screening is your testing in series and testing in parallel, okay? Tests in series is when you do one test after the other. You do first test, if it is positive, then you do the second test, if it's positive, you do the third, like that. Or you do first test, if it's negative, you stop it there. That is testing in series, is one kind of testing. Second one, you have something called tests in parallel. That is simultaneously, you do, if there are 3 tests, all the 3 tests are done at the same time in the same person. Simultaneously doing test 1, test 2, test 3. It's not the one after the other, just like your testing in series. So that is test in series and test in parallel. The question you will get it, what will happen to the sensitivity, specificity and the predictive values in case of combined sensitivity, specificity and predictive values when you are doing tests in series, and what happens in case of tests in parallel. So I have a simple mnemonic for you. Remember this thing. There are different TV series, right? We have lots of TV series. We have so many TV series to watch on Netflix and all that. So TV series, once the TV series came, it actually decreased your sensational news viewing. We are all started, we are all addicted to TV series, so we are watching that. So we are not watching any sensational news. We have decreased the news watch time. So this is my mnemonic for remembering tests in series, okay? So what I want to say is, TV series, remember tests in series. So in test in series, what is being decreased? Your sensational sensitivity is also decreasing, and news view, that is your NPV. Negative predictive value is also decreasing, okay? Series testing decreases the overall sensitivity and overall negative predictive value. So what will be increased? Just the vice versa. If sensitivity is decreasing, that means specificity will increase. So NPV is decreasing, that your positive predictive value is increasing. Just the opposite, if you write, you will get the answers for tests in parallel, okay? Now, one more question here is, what is this? What's the diagram you see here? This is an ROC curve, or the receiver operator characteristic curve, right? What is the use? It is used to compare 2 or more tests can be used to compare 2 or more diagnostic tests, 2 or more screening tests. Basically, it's used to compare 2 or more tests. How? See, this ROC curve is a curve which plots the sensitivity and 1 minus specificity. For any screening test to be the best, what do you want? We want the highest specificity and the highest sensitivity, right? Then only the test is the ideal or the best test. So for that, whatever test you have, you're just plotting on the ROC curve and you see which one has the highest specificity and sensitivity. So that will help you to choose the best test. Okay. So here I have different colors. I have a green test, I have a blue test, I have a red test. Two more tests are there. Okay. So if I'm asked to choose which is the best test, it's always this one. The one which is nearer to the upper and the left corner, because this is the point where you have highest sensitivity and highest specificity, because we are plotting between sensitivity and 1 minus specificity. So specificity highest in this side and sensitivity highest in the top. So it's the topmost and towards this side, this corner, whichever graph is towards that, that will be your best graph or best test which is having the both sensitivity and specificity on the higher side. Okay. So that's all about your this nodule, this segment, which was on family planning, family planning, demography, and we talked about screening also. Now we'll move to the something about nutrition. Okay, nutri nuggets. Okay, we'll see some questions, important questions from nutrition. So first question is pellagra. Pellagra in overeating population is due to. Options are niacin in bound form, deficiency of tryptophan, excess of leucine, and high consumption of milk and milk products. Which of these is the reason for pellagra in your overeating population? Okay, you know, try to say the answer. Okay, all of you know that pellagra is due to niacin deficiency, right? Niacin is your vitamin B3. Okay. Pellagra is occurring due to niacin deficiency. Correct. So, if you know this much, you have a tendency to mark the answer A, where niacin in bound form, because then you'll think, okay, it is deficiency. No, that's wrong. In Jover eating population, niacin is not in the bound form. Niacin content is actually very less. You know, tryptophan and niacin, both the contents are actually very less, but it is not in the bound form. The answer here is excess of leucine. Okay. What happens is, you know, this is a conversion happening, right? You know, tryptophan is the amino acid which gets converted to niacin, right? Biochemistry. Okay. So there is another amino acid, that is your leucine, the one which is abundantly seen in the Jover. So your leucine is another amino acid, and what it does, it blocks this. Okay. It blocks the transmission of tryptophan to niacin, thereby causing niacin deficiency and pellagra. So, excess of leucine in this Jover is the cause for niacin deficiency and pellagra in this Jover eating population. Okay. See the other options, I told niacin is not in the bound form. There is no deficiency of tryptophan. No, there is tryptophan and niacin, but a very low amount. High consumption of milk and milk products. No, high milk and milk products are actually good sources of, are told to be good sources of B3 or niacin. So they're actually given for the treatment part of pellagra or to prophylaxis of pellagra. It's not a correct answer here. Okay. Now what is this? You see, very famous image. This is the typical image that you get when you search pellagra online. Okay, what is this? This is called the Kessel's necklace. Okay, that is a pigmented scaly rash, because on the neck, that is a sun exposed area. Neck is the one of your most sun exposed area, right? So in patients who are having niacin deficiency or pellagra, or those who are suffering from pellagra, when there is sun exposure, it can cause a scaly pigmentation here around the neck in this form of a necklace. That is called the Kessel's necklace. Again, here you can see all the dermatitis and all that. So what are the 4 Ds of pellagra? You have diarrhea, dermatitis, dementia, death. Even other than this, patient will have weight loss, patient will have some kind of psychosis, some people will have bursitis, stomatitis, many things are there, but usually the 4 Ds are diarrhea, dermatitis, dementia, and even death can occur in case of a pellagra. Okay. So now you tell me which are the good sources of niacin. Good sources. Sources of your B3 or niacin can be meat, fish, egg, milk, all animal foods. Okay. Then you have your nuts, legumes, even whole grains. All these are good sources of NIAS. Okay. And the RDA, recommended daily allowance of niacin, is 16 mg per day for male and 14 mg per day for female. Fine. Next question. Next question is about food adulteration. Yes. So question is, in a village, it is observed that several farmers have cross gait and use stick for support to stand up and walk. So something neurological. Patients are having gait issues and they are needing a stick to walk. Due to poor yield from farms, they consume meals containing rices and pulses only. Supplementing their diet with which of the following vitamins could have prevented this? So what are we talking about here? We're talking about a condition called lathyrism, right? Lathyrism is occurring because of the patient's cross gait, stick for support. This is all the correctly they are describing the different stages of neurolathyrism. Okay, and the reason is consumption of kesari dal and on lack of the other good nutrients. So that causes lathyrism. So they have already told meal consuming of rice and pulses only. So this is typically a picture of lathyrism, and one of the treatment options or the prophylaxis options for lathyrism is consumption of vitamin C. So here your option is which vitamin could have prevented this is vitamin C. Okay, now we'll just see about lathyrism. Lathyrism because of consumption of Lathyrus sativus. Okay, lathyrism, you have two types. You have neurolathyrism and you have something called osteo. But this is what we are concerned about. This is in humans. The other counterpart is seen in animals. Okay, so cause of this is diet with more than 30% of kesari dal. Okay, if taken for about 2 to 6 months, the patient can get neurolathyrism. And what is the toxin? This kesari dal or the Lathyrus sativus, if taken in excess, what happens is the toxin in that kesari dal, that is the BOAA, it gets accumulated and it causes this neurolathyrism and all the symptoms. Okay, this is the active ingredient or this is a toxin. This is beta oxalyl amino alanine. Okay, I'm not writing the full form, BOA. Okay, then what are the interventions you do to prevent? Interventions you can do is you ban the crop, ban this kesari dal. Okay, that is one. Then vitamin C prophylaxis we already told. Parboiling. Parboiling is also an option to remove this toxin. Now this is the stages. So you have a 1 stick stage, you have a 2 stick stage, you have a crawler stage. These are all stages of your neurolathyrism. You can be given image also, and they can ask you what is the condition or which is the toxin responsible or which is the which is the active ingredient. Anything they can ask you. Okay, and vitamin C protects from neurolathyrism. Now, other than neurolathyrism, you have something called epidemic dropsy is there. Then you have your endemic ascites, and you have aflatoxicosis. So there are certain food adulterants and the diseases concerned. I'll just make a table so that you know all these. So yeah, we have a page here. So we'll write down the disease, the toxin, and the adulterant. Okay. So you have your disease here, then you have your toxin, and you have the adulterant use. Okay. First one, lathyrism, we have already discussed. I'm not writing it down. Second one is epidemic dropsy. The toxin is sanguinarine. Okay. And argemone oil. This is the adulterant. Where is this oil mixing? Where are you mixing this argemone oil? In mustard oil. Okay. Mustard oil is usually use is edible oil, which is commonly used, especially in the North India. So what happens is in the mustard oil, you just mix some argemone oil, okay, as an adulterant. But the argemone oil has what is called as sanguinary. So consumption of this, adulterated oil will result in the patient having epidemic dropsy. Okay. So contamination, where I contaminate in mustard oil. Then your endemic ascites occurs due to pyrrolizidine alkaloids, and the adulterant is crotalaria seed, also known as jun seed. Okay, crotalaria seed is the one responsible for your endemic ascites. So ascites is related to liver, right? So this is actually a hepatotoxin. This pyrrolidine alkaloid is a hepatotoxin. Third one, aflatoxicosis. Simple. Aflatoxin is a toxin due to the fungus aspergillosis. Then you have the something because of the claviceps, the clavine alkaloid, and you get what is called your ergotis. Okay. So this is in summary about your food adulterants. Some more extra point is epidemic dropsy. That is your mixing of adulteration of mustard oil by adding argemone oil. How can you detect it? It can be detected by, you can detect it by nitric acid test is there. Then you have paper chromatography. Better option would be paper chromatography. Okay. That is one way. What happens is in your epidemic dropsy, what is the pathophysiology is the toxin, it blocks the pyruvic acid conversion. So there is pyruvic acid accumulation, and because of that you get all the non-inflammatory edema and all other issues. Then what are the symptoms? You get dyspnea, sometimes you can get heart failure, even glaucoma is there, can also lead to death. So all these are because that pyruvic acid gets accumulated because of your sanguinary toxin. Okay, so that is epidemic dropsy. Remember nitric acid test and paper chromatography. Now we are moving on to the next question. As compared to cow's milk, human milk has more proteins, less carbohydrates, more iron, less of vitamins. What is the correct answer when compared to your cow's milk? What does human milk have in extra? Okay. So the answer here is more iron. Cow's milk have more of proteins and carbohydrates, but iron content comparatively it is more in your human milk. Okay, the iron content of cow's milk is almost 0.2 milligrams, whereas for human milk iron content is 0.35. Not much, but still slightly iron content. In terms of iron content, human milk is superior. Now some more things you should know. Some points about human milk or breast milk. Some values you should know. Okay, just writing it down. Breast milk per 100 ml, how much is the energy and how much is the protein? You have 65 kilocalorie of energy you get from breast milk for 100 ml, and protein is 1.1 gram of protein. Okay, that is the first point. Second point, maximum output of breast milk. When is the maximum output of breast milk? It's actually just before weaning or complementary feeding, because up to 6 months we are telling exclusive breastfeeding, right? So baby's growing, so around that 4 to 6 months the baby's need is more, so there is more breast milk production. So 4 to 6 months is the time when the mother produces the highest amount of breast milk. After that, once the 6 months period is over, we start weaning the baby and all that, so then the requirement is also less, so breast milk is also less. You can remember it like that. Okay, so then this point is important, right? Human milk is richer Compared to cow's milk, human milk is richer in what all things? Carbohydrates. To be specific, lactose. Okay. Then when we already told iron, right? Iron content, water content, carbohydrate content. Okay. This is what human milk is richer in than your cow's milk. But what is cow's milk richer in? Cow's milk is richer in all other things like your total protein content, fat content, calcium. Iron was more in human milk, but calcium is more in cow's milk. C for C. Okay. Then protein, fat, calcium, and you have your energy, total energy content. This is all more in case of cow's milk. Okay. Then now we'll see some food items which are good sources of. We will be asked which is the richest source of this thing, or which of the following is a poor source of this particular vitamin. So some points we'll just say, okay, which have been previously asked many times. So first we'll see about the poor sources. Food items as poor sources of nutrition. There's no point in giving these, okay? We'll have to substitute something else if the person is taking these. So you're first talking about poor sources of nutrition. Okay. So first you have milk. Milk is poor in iron and vitamin C. Second one, meat. Meat is poor in, milk is rich in calcium, but meat is poor in calcium. Okay. Third one, fish. Fish is poor in your carbohydrates. Okay, CHOs I'm writing as carbohydrates. Then you have egg is poor in vitamin C and carbohydrates. Then now we'll see which are the rich sources. Okay, food items as rich source. More than poor source, you will get this rich sources of nutrition. Which of the following is the richest source of this particular item? You get questions like that commonly. So first one, vitamin A and vitamin D. You have your liver oil. Halibut liver oil is the richest source. Then you have for vitamin C, which is the richest source of vitamin C is your Indian gooseberry or amla. That is very rich in vitamin C. Then you have B1. Rich source of vitamin B1 is gingerly seed. This was a recent NEET question. Okay. B1 is your thiamine, right? Then ragi is rich in calcium. Then for iron, richest source is your pumpkin seed, also your pista. These are all rich source of iron. Okay. Then when you're talking about rich source of protein, you cannot leave our soya bean, right? Soya bean also again a favorite area. This is the richest source of protein among pulses. Okay, richest among pulses. 43.2% protein content. Plus, it's not just the protein that soya bean is very good in. It's also rich in calcium, iron, and vitamin B. Then you will see what is net protein utilization in the next question. But for the time being study, then NPU for soybean is 55. Okay, so 43.2 is the protein content and 55 is the net protein utilization. But there's a limiting amino acid in soybean, that is your methionine. Okay. Now the next question is about the methods for assessing your protein quality. So which one of the following is the best indicator of protein quality for recommending the dietary protein requirement? So basically, which is the best indicator for measuring the protein quality? Okay. Now there are different indicators for measuring the protein quality, but they've asked you the best one, and the best one is not there in the options. So the answer here is none. The best one is your TIAAS. This is the best indicator as of now. This is the best indicator for measuring your protein quality. This stands for digestible indispensable amino acid score. This is the best indicator of protein quality. Okay. So what are the other indicators? We'll just see. The other options are, you have your protein efficiency ratio, PER, that is your ratio of weight gain to amount of protein consumed. Okay. Then you have something called your NPU. Net protein utilization is the ratio of nitrogen used for tissue formation versus amount of nitrogen digestion. From the nitrogen digested, how much is used for tissue formation? That is your net protein utilization, or how much is utilized for tissue formation. That you get from the formula BV into DC by 100, where BV is your biological value and DC is your digestibility coefficient. Okay. Next question. Next question is on your acute severe malnutrition. So SAM. It's actually severe acute malnutrition. That is SAM is what they are asking. The SAM diagnostic criteria include all except bipedal edema, visible severe wasting, mid-arm circumference below 11.5 and or 115 millimeter, weight for height below 2 standard deviation of WHO growth standard. Simple question. All of you know the diagnostic criteria of SAM, I suppose. First three are already there. Bipedal edema, visible severe wasting, yes. Mid-arm circumference less than 11.5 is SAM. But the last option, that's weight for height, it should be below, not -2. It should be -3 standard deviation for saying this is SAM. So the option which is wrong is option T. Okay. So what is this? What is this diagram you're seeing here? What is this tape, or what is this called, and what's the use? So this is your Shakir's tape. Shakir's tape. SHAKR. Shakir's tape. And used to measure mid upper arm circumference. Whom do you check mid upper arm circumference? In children less than 5 years. Okay. So 6 months to 5 years. That's the age group where you check the mid upper arm circumference. And what is the normal value? Normal value is more than 13.5. Okay. Then you say, so this is the green. So this is actually used by the health workers. Okay, they can go from house to house and then use this tape and see the mid upper arm circumference and see whether the child is having, whether the child is normal, or whether there is a wasting, whether there is undernourishment, or whether it's normal. So normal is green is more than 13.5. Then you have yellow, that is between 12.5 to 13.5. This is your mild to moderate malnutrition, and less than 12.5 is severe. That is the red color. This is according to this tape. But when you specifically ask the diagnostic criteria of SAM, for SAM, it should be less than 11.5. MUAC less than 11.5 is considered as your SAM, or severe acute malnutrition. What is this you see here? This is a diagram of a nutritional rehabilitation center. These are specific centers where children, in the hospitals, you have specific centers where children of SAM are sent, so that for their rehabilitation. Also, not just the children, it's also the bystander. Usually the mother is also sent there, and is also taught on how to make nutritious rich food, or how to prevent this from happening again. So that's nutritional rehabilitation center. Okay, this slide is just to discuss the limiting amino acids, because frequently asked, what are the limiting amino acids in cereals? Cereals, you have threonine, lysine. These are the limiting amino acid in the cereal. Then for pulses, you have cysteine, methionine. Okay, here cereals are deficient in lysine and threonine, CLT, calicate, that's how I learned it. Then pulses are deficient in PCM, or paracetamol is PCM, right? Pulse is deficient in cysteine and methionine. And you should also know what maize is deficient in. Maize is deficient in tryptophan and lysine, okay? Now, few points about your egg. Egg is known as the reference protein, correct? A 6-gram egg, 60-gram egg will contain 6-gram protein, 6-gram fat, 30 mg calcium, high cholesterol, 250 mg cholesterol, okay, and around 60 gram, so around 60 kilocalories of energy, okay. But it is poor in which vitamin? Vitamin C, because egg is actually poor in vitamin C. Now, again, what is this? This is your reference man and reference woman, okay? Reference man and reference woman. The cutoffs have changed. Okay, now if you're somebody who's learning the older versions of PARC, no, these values might be wrong. What I'm writing now is the correct or the updated values. Okay, reference man and reference woman. The initial part is the same. That is the person to be free of the disease, 8 hours of work, then 8 hours in bed. Those things are the correct 2 hours and sitting around. So all those things are the same. The changes are the reference man, the age group has changed. Now it is 19 to 39 years for both reference man and woman. Okay, that's the first point. Then the weight. Weight is 65 kg here and 55 kg here. Okay. Height is 95th centile for adult male. Similarly, 95th centile for female. Then the BMI is 18.5 to 22.9. That's the same here. 18.5 to 22.59. That is the ideal BMI you want for a reference man or reference woman. Okay. Now we'll wind up nutrition with two more things. One is what is the log of this and what is this. These are the two schemes related to nutrition. The first one you see here, this is your ICDS, right? ICDS, Integrated Child Developmental Services. And what is the heart of your ICDS? It's the Anganwadi. It's actually a question, okay? I'm not just making up. So, heart of ICDS is your Anganwadi. Fine. Now, what else? So, they give nutrition and you should know the beneficiaries of Anganwadi and what is given in the Anganwadi and all that. What is the functions of Anganwadi? I'm not repeating it. Please go and check. So, the point is administration unit of an ICDS will be your community development block. Okay. Then you have a higher person, you have a CDPO, community development officer there, followed by you have supervisors, and then under supervisors you have Anganwadi workers and helpers, right? This is your, you see children sitting around and eating, right? That's your midday meal scheme. This is the logo of your midday meal scheme. Now it has been renamed as PN Portion. Okay, initial name was midday meal scheme. Now it's a renamed as PM Portion. The main objective was actually, you think midday meal scheme, the main objective was to improve nutrition. No, the main objective was to improve school attendance, so that when food is provided free of cost, at least children will come to school for food. That was actually the main objective. Along with that, we also want to improve the nutrition. So universalization of primary education, that was the main objective. Plus, you're also improving nutrition. Of course, nutrition is also getting improved in the midday meal scheme. Remember, the new name of midday meal scheme is PM Portion, and this is the logo. Okay. Last point here. What is Portion Abhiyan? Portion Abhiyan is actually, an overarching scheme or an umbrella-like scheme where they are bringing around all the programs related to nutrition, your SADS, your midday meal scheme, everything is brought under the single umbrella of Portion Abhiyan, whereby they can actually monitor and guide all the nutrition related programs. That is your Portion Abhiyan, or it's also known as your National Nutritional Mission, NNM, of 2017-18 it was started. It's actually an apex body to monitor all the nutrition related programs. And what are your aims? Decrease stunting, decrease undernutrition of under 5 children, okay, decrease slow birth weight by 2% per annum per year, okay, and decrease anemia. This is in the children as well as women of reproductive women, okay. by 3% per annum. So under Poshan Abhiyan, we are aiming to decrease stunting, undernutrition and low birth weight by 2% per annum and anemia by 3% per annum. So this is just roughly about the programs of nutrition, and you should know the RD of some of the RTA of certain vitamins and minerals, all the deficiencies, the food adulterants, then what is the protein quality indicators. So all these are coming under your nutrition. Now we'll take a small break, and after break we'll be discussing on vaccination. Thank you. So hi, we are back. Now we'll discuss some questions from vaccination. So we have already covered up to nutrition. Now we have 5, 6, 7, 8, 9, 10, 6 more segments are left. So starting with vaccination. So first question, most heat sensitive vaccine is, options are BCG, polio, measles and DPT. So you should know which are the heat sensitive vaccines, which are the heat labile vaccines and heat sensitive vaccines. And here the option answer is polio. Okay, polio is the most heat sensitive vaccine out of the given options. But if they had given reconstituted BCG instead of BCG, the answer would have been that. But this is just BCG, so here the option is polio. So heat sensitive vaccines, this is the starting point. Okay, reconstituted. Because BCG follows the open vial policy, you can reconstitute it, and sorry, it doesn't follow. So reconstituted BCG, then followed by your yellow fever. Again, that's not given in the option, but this is the order. Then you have your OPV, PV or IPV. Okay, so that's the heat sensitive vaccine. Now, this is your range of vaccines arranged in the order of heat sensitivity, most sensitive to least sensitive. So, always remember the T vaccines, that is your hepatitis T, so hepatitis or your penta, those things are actually not that sensitive to heat. Actually, they are heat loving, they are sensitive to cold. Okay, so sensitivity to heat and sensitivity to cold, this is the order. OPV and IPV are very sensitive. Then you have influenza, MMR, penta, BCG, JE, hepatitis B. But you see, reconstituted BCG is more sensitive than your OPV, and followed by yellow fever, OPV, then measles. So this is the order. So remember, the most thermolabile vaccine is your reconstituted BCG, and most thermostable vaccine is your TT, right? Now, what do you see here? What is this? Identify. This is your ILR, right? In the ILR, this is how it's based on the temperature only. This is how your vaccines are arranged. So you should be knowing this. Then what is this? This is your VVM, or vaccine vial monitor. So this is showing whether to use the because of the temperature, whether something has happened to your vaccine, or whether this vaccine is fit to use or not. So you have an outer circle and an inner square, and when the color of the square and the circle are the same, or if the square is more darker than the circle, both these conditions you have to discard. Other than that, you can use the vaccine. That's about the VVM. Then, what is this open vial policy? Open vial policies is to decrease the vaccine wastage. What you do is, some vaccines, if we are opening the vaccine, you can actually reuse it. After this vaccination section, you can actually maintain the cold temperature, everything, and reuse it within 28 days. Okay, that is what you call as open vial policy. But there are certain vaccines which do not follow the open vial policy, or once opened, they have to be used within 4 hours or 6 hours. You can't keep it and you cannot use it for the next session. Those vaccines name you should know, which do not follow the open vial policy, because if you know that, rest is easy, no? Rest whatever comes usually follows the open vial policy. So those which do not follow the open vial policy are your BMJ vaccines. BMJ is a journal, I hope all of you know. So BMJ vaccines is the ones which do not follow your open vial policy. B for BCG, M for measles, and measles, MMR, MR, everything comes. J for J. Okay. J, once opened, you have to use it within 2 hours. Okay. 2 hours is the maximum time you can keep. If it is remaining as waste, you have to discard it. You can't use it. Measles and BCG and all you can use for 4 to 6 hours, not after that. Okay. So next question. So we'll move on to the next question. Okay, just there are 2 more vaccines other than this BMJ. Your COVID vaccine. All your COVID vaccines also do not follow the open vial policy. Once opened, you have to use it and finish it. You cannot keep it for the next session. Fine. Next question is, a 27-year-old child, sorry, a 2-year-old child who is a case of nephrotic syndrome has to be put on steroids. Okay, has to be put. Before starting the treatment, which of the following is true about vaccination? Options are: vaccinate as per schedule, give pneumococcal vaccine as per schedule, only killed vaccines to be given, OPV not given to siblings. What is the answer here? See, you're talking about a child who's having a nephrotic syndrome, 2-year-old baby having nephrotic syndrome, who's about to be put on steroids. So we have not started the immunosuppressant yet. In that case, what you can do? You can actually vaccinate the child as per the schedule, because we have not started immunosuppression as of now, right? You have to give pneumococcal vaccine as per the schedule, yes. Only kill vaccine to be given. Oh, yes, only kill vaccines can be given. Usually, if a child is immunocompromised, you prefer only kill vaccines, and OPV not given to siblings. So once a child is put on steroids, somebody is having immunosuppression, in that case, you don't give live vaccines. Why? Because live vaccine, what is a live vaccine? Live vaccine is actually that organism is being, whatever is the vaccine, that organism is being processed by different chemical methods several times, so that to decrease its immunogenicity. But when somebody is immunocompromised, and immunocompromised person taking a live vaccine, there's a chance that that organism actually can retain back the immunogenicity and cause a disease. So live vaccines are contraindicated in immunocompromised persons, but you can give kill vaccine. Also in pregnancy, we don't give live vaccines. Okay. So here the answer is A, B, C, and D in 1, 2, 3, 4. So option D is the correct answer. So the child can be vaccinated as per the schedule until and unless the child is being put on steroids. Minimum 1 week, at least till 1 week also it's okay. Once the pregnancy round you have started, after 1 week you can't give steroids. Okay. And live vaccine should not be given in immunocompromised group. So how do you know which is a live vaccine, which is a kill vaccine? Sometimes instead of this, they can give you an immunocompromised situation, and they can list you the names of certain vaccines. There is OPV, IPV. They can give you 4 vaccines and ask you which one is contraindicated or which one is the live vaccine. So we have a mnemonic here. See, there are so many mnemonics for live vaccines. If you've already studied some mnemonics, please stick on to it. Don't change it now. For those who don't have mnemonic yet, you can use my mnemonic. Okay, that is, I remember live vaccines for now. Love, live and love. Love vaccines or live vaccines. The code is Be My Top Valentine. BMYTOPV. So these are my live vaccines. So B for BCG, T for it. It's not clear actually. Okay, so B is for BCG, T for typhoid oral, as well as you have your typhus. Okay, M is for yellow fever. Then you have, M is for measles, mumps, rubella, MMR. You can write MMR. Y is for your yellow fever. T is for typhoid and typhus. O is for your OPV. P is for your plague vaccine. And V is for your varicella. It is not there in this list. So varicella. Okay. This is the code for studying live vaccines. Toxoid you already know. We just have tetanus and diphtheria. 2 toxoids. Easy to remember. Recombinant vaccine, hepatitis B vaccine. That's the only recombinant vaccine we have. So toxoids, you know, recombinant vaccine, you know. Then you have cellular fraction vaccines, that subunit. So these are your polysaccharide vaccines, okay. So polysaccharide vaccines, you have already coccal vaccines, meningococcal vaccine, pneumococcal vaccine. These are your cellular fraction vaccines, okay. So hepatitis B is recombinant, then all the coccal vaccines come under the cellular fraction vaccine. Toxoid, you know, D and T, diphtheria and tetanus. Then be my top valentine, that is for your live vaccine, and whatever is left is your killed vaccine. Okay. Now, next is your national immunization schedule. Very, very important. We have been repeatedly studying this in the pediatrics, in PSM, everywhere, but you should know it by heart. Okay. So, these are first thing we'll study when all are the vaccines given in national, according to your national immunization schedule. You have vaccines at birth, or you call them zero dose. Okay, then you have 6, 10, 14 weeks. Then you have 9 months. Then you have 16 to 24 months. Afterwards, you have 5-year, 10-year, 16-year. These are the times when you are supposed to give vaccine to your child as per your national immunization schedule. Okay, so we'll start with birth. Birth, I hope all of you know we are giving what? At birth, we have BCG, sorry. So at birth we have BCG, then you have OPV and hepatitis B. And hepatitis B, zero dose. Okay. BCG, OPV and Hep B, all zero dose. So at birth, BCG, OPV, hepatitis B, zero dose studied. Now we have 6, 10, 14 weeks. In 6, 10, 14 weeks, we have 3 vaccines which are given in 6, 10, 14 weeks, and you will remember it as ROPE. Okay, we will remember it as ROPE, ROPE. ROPE is given in 6, 10, 14 weeks. What is R? R is for Rota. It's given in 6, 10 and 14. So I'm just writing the same thing here. Rota 6. What is O? OPV. Okay. But now you have to write OPV1. The initial one you gave at birth was a zero dose. This was all zero dose. So now it's OPV1. This is OPV2. Then this becomes OPV3. Similarly, Rota 1, Rota 2, Rota 3. So ROPE I told. So Rota, OPV, and what is PE? P is for pentavalent. So you have Penta 1, Penta 2, Penta 3. So BCG, OPV, hepatitis B at birth. Then 6, 10, 14 you have ROPE, ROPE. R is for Rota, O is for OPV, 1, 2, 3, Rota 1, 2, 3, and Penta 1, 2, 3 at 6, 10, 14 weeks. Right? This much is clear, I hope. Now we have 2 more vaccines which I'm going to add here. We have IP. IP, I stands for fractionated IPV and P stands for PCV. Now you have to give IPV1 and PCV1 as well as IPV2 and PCV2. So, see, you're giving the baby 6, 10, 14 weeks. That is at a 4 weeks interval, you're giving 3 vaccines, right? So, let the baby take a break. So, this time, the next 2 vaccines which you're going to give, we are giving the baby a break of, in between, we are giving a break. So, we are giving the vaccine on 6 weeks and 14 weeks only. 10 weeks, we just leave the baby, okay? Let him have only 3 vaccines this time. So, 6 weeks, we are adding 2 more. That is your IP, that is fractionated IPV1 and your PCV1, okay? 10 weeks, I told, we are giving the baby a break. So, we'll go to 14 weeks. We'll give the second doses of your IP, that is fractionated IPV2 and PCV2. So I hope this much part is clear to you. Now we are going to your 9 completed months. 9 completed months as well as 16 to 24 months. So these two, both these we have your what? MR and GE. 9 completed months you give MR1, MR2 at 16 to 24 months. Similarly JE1 and JE2 at 9 months and 16 months. Okay. Other than this, something new has been added here. At 9 completed months, we have started your FIP. I told you fractionated IPV 1 and 2. Initially, we had only 1 and 2 at 6 and 14. Recent, along with 9 months, we have added a IPV third dose. Okay, fractionated IPV third dose. This is important because this is new. Okay, then here we are going to add along with MR and JE in 16 to 24 months, we are going to add some boosters. We'll add OPV booster. Then you have your DPT first booster. Okay. Okay, 9 months we also have a PCV booster. Okay. So 9 months and 12, 16 months you have MR and JE. Along with that, 9 months you also have fractionated IPV third dose plus PCV booster. 16 to 24 months you have OPV booster and DPT first booster. Okay. Now at 5 years you have only one vaccine, that is your DPT second booster. From 5 years onwards you are only giving T vaccines. Okay. 5 years you have DPT first booster. 10 years and 16 years you have your TD. TD1 and TD2. Then what is the one which you are giving every 6 months? It's vitamin A. From 9 months to 5 years, every 6 months apart, you are giving vitamin A. First dose is given along with the first MR or at the 9 months vaccine. Then you give vitamin A. If the child is less than 1 year age, you give 1 lakh international unit. If the child is more than 1 year of age, you give 2 lakh international unit. Then OPV and Rota and OPV are oral vaccines. I hope you know. So OPV, how many drops? You give 2 drops. 2 drops of OPV. Then Rota, you give 5 drops of OPV. Okay. So now this one, you have to know the sites as well as more than the sites. I think you will remember, but the dose of route of administration, whether the vaccine is given as IM, whether you're giving an intradermal, whether you're giving a subcutaneous, whether you're giving an oral vaccine. This you should know. Okay. So oral, this part of the table is showing the oral vaccine. So oral vaccines, you know, you have OPV, then you have Rota. What else? Vitamin A, even though it's not a vaccine, but it comes under the National Immunization Schedule. So vitamin A, these are the 3 things that you're giving under the program as oral medicines or oral vaccines. Okay. Now you have to remember 2 vaccines that are given intradermally and 2 vaccines that are given subcutaneously, because rest everything is given IV. Okay. So you just have to remember 2 intradermal and 2 subcutaneous vaccines. Okay. I'm just going to write it down. So I have subcutaneous 2 vaccines. Which are they? I have M and J. I have MR and JE. These are the 2 vaccines which are given subcutaneously. My code for this is how I remember it. I remember it as cute Mr. J. Okay. So there's a Mr. J who is very cute. So my code is cute Mr. J. So cute for subcutaneous, Mr. for MR and J for J. So that is your 2 subcutaneous vaccines. Now we have to study which are your intradermal vaccines. Okay. For intradermal vaccines, my code is BD. Okay. BD, you know, BD. Just like cigarette, you have BD. So that is my code here. And here, what is this? Intradermally, you have BCG and you have your IPV. These are the 2 vaccines which are given intradermally. So this is my code for that. So now you know subcutaneous, cute Mr. J, MR and JE, BD, that is intradermal. You have B and I, BCG and IPV. Rest everything, and oral you know. Rest everything, whatever vaccine is there, give it IM. Okay. Now next question is unimmunized child. Okay. Again, a frequently asked question. Unimmunized child comes to you. Which all vaccines can you give? So 4 points. Till 1 year. Till 1 year, if the child is less than 1 year and completely unimmunized child comes to you, what all things you give? You give, what all are the vaccines which you are giving till 1 year? We told about rope, right? We told about rope, and then we had your IPV, and you had your PCV for IP. Then what else you had? At the 0 dose, you have BCG, hepatitis B, and OPV. OPV is coming under rope. Then BCG is the only thing which we have not told. So that also can be given up to 1 year of it. But here there's a change. OPV, haven't you heard OPV? Is OPV given till 1 year of age only? No. because we know everywhere in pulse polio immunization we are giving OPV till 5 years of age, right? So I'm just cutting this from here. Okay, so I'm cutting my rope O from here and putting it here. Okay, so till 5 years you can give OPV. Okay, then what else? Then you can give MR, can be given till 5 years of age. Then you have till 7 years, which is the vaccine you give, DPT. And till 15 years, the longest one is JE. Okay, so question be like, a child who is 8-year-old is coming to you, is completely unimmunized child, 8-year-old, what vaccine will you give? If the child has crossed 7 years, there's only one vaccine to give, JE. Okay, very easy. If the child is maybe 6 years old, not immunized, what all things you can give? So after 6 years you can give DPT, and because DPT can give even till 7 years, and JE, that's only two options you have. So based on the age and the immunization status, these 4 points you should know. Okay, so that is about your unimmunized child. Now we'll see a question about the side effects or the adverse effects of vaccination. So you have here a 8-month-old child with history of unusual crying and convulsions following previous vaccination after BCG, DPT, OPV, hepatitis B. These many vaccines were given. Child is having unusual cry and convulsions. Parents have brought this child for next dose of vaccination. Which vaccine is contraindicated? So the child has a previous history of unsolvable cry and convulsions following the vaccination. That means there is one vaccine which is responsible for this, so that vaccine should not be given this time. So which is the vaccine here? It's actually DPT. See, this unsolvable cry and convulsions is caused because of your P or pertussis. So if a child has such an history, you have to stop. You cannot give P component again. So instead of DPT, you may give DT, but not DPT. So in this child, DPT is a vaccine that is contraindicated. Okay. Now I'll just write down some named adverse effect of certain vaccines. The list is not complete, but at least this much you should be knowing. Okay, I'm just writing the vaccine name and the adverse effect. Okay, so BCG, famous adverse effect is lymphadenitis, or you say suppurative lymphadenitis. You see this question, you see this as a side effect, it's BCG most commonly. You have MR or MMR or simple measles vaccine, it's thrombocytopenia seen. Febrile seizures are there. Even toxic shock syndrome can happen. Okay. OPV, I hope you all know as it's VAP. Vaccine associated paralytic polio, famous side effect of OPV. Pertussis is the one we told now. Seizures or more than 3 hours, continuous cry. That is the unsolvable cry you're talking about. Then there's something called HHE. That is your hypotonic, hyporesponsive. Child will have a lower tone, lower response episode. This is a rare side effect, but again, this is also a side effect of your pertussis only. Okay. Then TD, common is brachial neuritis. This is the side effects of TD. Then rota, again, famous, most of you would be knowing, but I'm just writing it down. Okay. Rhinosiception. Then the influenza kilt, GBS or Guillain-Barré syndrome. Then just though it's not your under the national immunization schedule, I'm just writing one more thing here. This is your yellow fever. A known side effect of yellow fever, or the named side effect, is your vaccine associated viscerotropic disease, VAVD. This is your yellow fever vaccine. And just tell me the strain of yellow fever vaccine. 17D. Okay, that's a strain for yellow fever vaccine. That's also commonly asked. Now, another question. Which one of the following vaccine is effective for mass vaccination during a disaster outbreak? See, it's measles. We have already discussed this, right? In the initial part, morning, we have told this because the most common disease you get after an outbreak is your gastroenteritis. Also, measles is also common. So, there is vitamin A deficiency and all that. So, if there is a vaccine that you are supposed to give in a mass vaccination after an outbreak, it would be measles. Okay. Other than that, you don't commonly advise vaccination post disaster. Better you have to focus on, safe water sanitation, things like chlorination. All those are more important. But yes, you do advise these vaccines, the cholera, typhus, typhoid, and all. You advise for whom? For healthcare workers who are working in disaster affected areas, you do advise. But other than that, general population, we don't. Okay. So now we are going to talk about vitamin A. Single massive dose of vitamin A for preventing the deficiency in preschool children between the age 1 to 6 years for every 6 months. So if the child is more than 1 year of age, what is the single massive dose of vitamin A? 2 lakh international unit. Okay. So dose is less than 12-month-old child, you give 1 lakh international unit. But if the child is more than 12 months, you have to give 2 lakh. You give 2 lakh international units. Okay. So what about the treatment part? This is all about your prophylaxis, right? If somebody is having a vitamin A deficiency and you're supposed to treat the child, you have to give 2 lakh international unit first. This start dose you give, then you repeat second dose or the same thing, 2 lakh international unit, second dose after 4 weeks. Okay. So if it's for treatment, 2 doses given 4 weeks apart, again 2 lakh international unit and 2 lakh international unit. Okay. Now, what is this? The famous white hot spot for a vitamin A deficiency. What is its term? It's a triangular pearly white lesion, or not a lesion, triangular pearly white appearance you see on bulbar conjunctiva. Okay. So this thing you see, this is your white hot spot. It's triangular pearly white on or at your bulbar conjunctiva, right? The white hot spot. Few questions about vitamin A deficiency. First question, most common ocular manifestation of vitamin A deficiency is xerophthalmia, right, or dry eye. First clinical sign of vitamin D deficiency is conjunctival cirrhosis, whereas your first clinical symptom of vitamin D deficiency is, this is what everybody knows, the night blindness. Yes. Then this points you might not be knowing. So I'm just writing down based on the prevalence. Okay. If night blindness prevalence is more than 1, and if white hot spot or prevalence is more than 0.5, in a prevalence, this is called as the prevalence for determining xerophthalmia in a community. This prevalence is checked in whom? 6 months to 6 years. So you take in a community, you take the 6 month to 6 year age group cohort, and in them, if the prevalence of white hot spot is more than 0.5, or if the prevalence of night blindness is more than 1%, then you say this is determining criteria for xerophthalmia. So saying that this community has xerophthalmia. Okay. So again, what is this? This is your easy, or this is a logo for your Mission Indradhanush. Okay, Indradhanush has seven colors. Indradhanush is nothing but your rainbow. It has 7 colors. So Mission Indradhanush was basically to improve the immunization coverage of the 7 vaccine preventable diseases, which are measles, polio, pertussis, tetanus, TB, diphtheria, hepatitis B. Okay, that was your Mission Indradhanush. It was actually started in 2014. So Mission Indra Dhanush started in 2014. So now we have something called Intensified Mission Indradhanush. 2017 this was started. And what do you do in the Intensified Mission Indradhanush? It's actually an immunization drive, okay? Immunization drive over 7 working days starting from 7th of every month. Now, initially I told you it's just the 7, it's Indradhanush, 7 colors or 7 diseases, but actually now recently we have added it. 6 more diseases have been added. Which are the 6 more, not diseases, 6 more vaccines have been added under this scheme. One is your rota, then you have your measles, IPV, JE, HIP, and PCV. These vaccines have also been added recently along with your 6, and most probably this name Mission Indradhanush will be changed, but as of now it's not actually the 7 diseases. We have added rota, measles, IPV, JE, HIP, and PCV also. Okay, now few not recent advances but something out of your national immunization schedule I'm going to discuss here. You have, what is this Cervarix, Gardasil? Cervarix and Gardasil are examples of, or are the brand names of your HPV vaccine, right? So HPV vaccine, whom do you give? You can actually give to boys and girls. There's nothing like that, but usually we are more concerned of girls above 9 years of age. That's our target for giving HPV vaccine. Cervarix is bivalent. Okay, it can protect against 2 types of HPV or human papillomavirus 16 and HPV 18. Whereas Gardasil is quadrivalent. You will have nonavalent Gardasils now, but here I'm just talking about the one which protects against HPV 16, HPV 18. Then you have HPV 6 and HPV 11. So, and both of them, what is the dose? You give it as IM 0, 1 or 2 and 6 months, 3 doses. This is the usual route. And one more point here that you should remember is, see, HPV 6 and 16 and 18 can protect you from CS cervix, right? So, Cervarix protects from CS cervix, whereas Gardasil have 16, 18, that is protects from CS, plus it also has protection against HPV 6 and 11. 6 and 11 protects you from what? Warts, okay? Genital warts. So, Gardasil, in addition to your CS cervix, it can also protect you from your genital warts. So, that was about HPV. Now, something from your vector-borne disease control program or vaccines related to your, dengue and malaria and chikungunya. So dengue, these are all new vaccines or these are recent advances. But dengue vaccine, I think it's a possible question they can ask you. Okay, so newer vaccines. The first approved vaccine for dengue is called Dengvaxia. Okay, it's your Dengvaxia, also known as CYD TDV. It's a tetravalent vaccine. What else is written? Live tetravalent vaccine given from children who are above 9 years of age. You don't give to children, you give only to those kids who are above 9 years. Okay, that is dengue vaccine developed by Sanofi Pasteur. Then you have one more vaccine for dengue which is under trial, not approved yet, but this vaccine is your tetravalent TV003. This is under trial only, under phase 3 trial currently. This is also for dengue only. Now, what is this? RTS SAS01. This is your Mosquirix. This is the first vaccine approved for malaria. Okay. So you have a vaccine approved for malaria, which is Mosquirix. For dengue, you have Dengvaxia. And for chikungunya, you have something called the Ixchiq. This is the first vaccine approved for chikungunya. Okay, that was just some extra points. So with this, we are concluding this module on vaccines. Now we'll just take a short break. After the break, we'll be discussing a very tough area as per the many of the students, but we'll try to simplify it and discuss only the important points, which will be on national health programs. Okay, bye. Friends, we are back. So now I have 5 more segments left. And this segment, we are going to study about the national health programs, or I've called it the program pulse. Okay. So national health programs, again, it's a high yielding area for almost all the exams, especially in EPG. So first, I'll just tell you the names of the programs which you should know. Okay, there is no excuse. You are definitely going to get a question from NTP. A TP program is important. Then your NACO, National AIDS Control Program, NACP or NACO, that's important. Then you get questions from NLEP. Almost all programs you can get questions, but TB, your AIDS program, then your vector-borne NVBDCP. These programs are, actually very, very important. Definitely you are going to get some question, some or the other question from this area. So we'll directly move on to the question. So first question is, a patient from Northeast was diagnosed to have infections with Plasmodium falciparum. Which is the most appropriate drug treatment? Simple question. Based on the program, how do you treat a patient, falciparum patient coming from Northeast states? Okay. So here the answer is artemether plus lumefantrine. Okay. This is the answer for this question. So now in brief, we'll just revise our treatment protocol for malaria as per your program. Fine. So most of you might be knowing it, but just revise it. Okay. So this is very simple if you study systematically. So I'm writing it here. Treatment for malaria. What all malaria you have? First, we'll see your Plasmodium vivax. So for Plasmodium vivax, what do you give? You give chloroquine. You have two drugs for Plasmodium vivax. You have chloroquine and you have primaquine. Chloroquine for 3 days plus you give primaquine for 14 days. Okay, that is the treatment for Plasmodium vivax. And what is the dose? For your chloroquine, you give 25 mg per kg body weight over 3 days. Okay, 25 mg per kg body weight over 3 days you give this chloroquine. So chloroquine for 3 days plus primaquine for 14 days. For 14 days your dose is 0.25 mg per kg. That is the dose of primaquine. So that is Vivax. Now, if it's falciparum, what do you do? So you have Plasmodium falciparum. For falciparum, see, falciparum is stronger, more resistant, more dangerous organism. Your chloroquine is not going to work with your falciparum. Okay, falciparum is smarter than chloroquine, so you have to give your artesunate or artemether combined ACT. Okay, so here what happens is you give ACT for 3 days instead of your chloroquine. I am replacing it with ACT for 3 days plus primaquine. You don't have to give on 14 days. You have to give only on day 2. Okay. Primaquine on second day. Single dose on second day alone. And what is the dose? It's not 25, it's 0.75 mg per kg. Since you're giving only on one day, no, you're giving a higher dose than the 0.25. So you're giving 0.75. Okay. So ACT for 3 days and primaquine for only the second day. So what is the difference between this ACT in different states? ACT SP and you have ACT AL. AL is the one where you're giving lumefantrine as per your question. SP is one where you're giving sulfadoxamine and pyrimethamine. So ACT SP is given in all states except your northeast. Okay, ACT AL is given in your northeastern states because in northeastern states even the SP ACT SP has also become resistant. So we have shifted to the next higher one, that is your ACT AL or lumefantrine. Okay. So this is your and ACT AL. Here the ACT is actually what? Artemether plus lumefantrine. And this one is artesunate, okay? Plus sulfadoxamine and pyrimethamine. So, and your this artesunate dose is 4 mg per kg. Okay, so that is in general about your treatment for malaria. Vivax, chloroquine, 3 days, plus primaquine for 14 days. Your falciparum, ACT treatment for 3 days, plus primaquine only on day 2. Now, what about certain special situations? How would you change this malaria treatment in special situations? First, pregnancy. Pregnancy, you cannot give primaquine is contraindicated, as well as your even your chloroquine, the safety is not that sure. So primaquine is absolutely contraindicated, okay, in pregnancy. So in pregnancy, first trimester of pregnancy, what do you give? You give quinine salts. That is the treatment of choice. 10 mg per kg TDS for 7 days. That is in the first trimester. Then after that, in your second or third trimester, you prefer your ACT. Can be either ACT, SP or AL based on whether the lady is from Northeast or not, for 3 days. Okay. This is the special case in case of pregnancy. Then what about the second one? In case of mixed infection, suppose somebody has a mixed infection where you get Bivax and falciparum, both are positive. So what are you going to do? You're just going to combine both the treatments. What was that? How do you combine it? So in this, you give area specific ACT plus, just like given falciparum, area specific ACT plus, since there is also Vivax to kill that, 1 day primaquine is not enough. So you are giving primaquine for 14 days, just like you used to give in your Vivax. Okay. So what is this? This is just a logo of your NVBD CPC, family protected from the mosquito bite or the vector bite. So this logo you should know, okay? That is your NVBD-CP logo, National Vector-Borne Disease Control Program. Fine. Then, till now we have told about the treatment part. Now let me ask you, what is the prophylaxis? Prophylaxis of malaria. Suppose somebody is going to a malaria endemic region from a non-endemic region, and if the travel is for less than 6 weeks, smaller travel, and there is more than 6 weeks, your treatment will change. So less than 6 weeks, suppose somebody is going to a place for less than 6 weeks, maybe the person is going to Delhi. Less than 6 weeks is enough, right? So I want to, if I'm going to an international place, or this is just for you to remember, okay? This is nothing to do with the endemicity of malaria. This is just to remember. It's just like a mnemonic for you to remember the medicine, okay? So less than 6 weeks, I'm thinking of a lesser, smaller travel. So I'm thinking Delhi. So D for Delhi, D for doxycycline. So less than 6 weeks, I'm giving doxycycline. If it's a longer travel, more than 6 weeks, I'm thinking of Malaysia. Malaysia is like more than 6 weeks, okay? So for that, I'll give what? Something with M, mefloquine. So this is the prophylactic treatment of choice for your malaria. And when do you start the treatment and when do you stop? So in case of your mefloquine, you have to, it's a long travel, so you have to start 2 to 3 weeks before travel. You have to start taking the prophylaxis. For doxycycline, you just have to take 1 to 2 days before travel. And both you have to continue 4 weeks after travel. After returning back home, again 4 weeks also you have to continue this prophylaxis. Okay. So that was malaria treatment. Now we are moving on to the next treatment, which is your HIV. Okay. So options, or sorry, the question. I'm taking up the next question. Question is, nurse gets HIV needle prick. What is not done? Wash with soap and water. Monotherapy with tenofovir for 4 weeks. Baseline serology before starting prophylaxis. Repeat serology after 3 months. So which should not be done? Should you wash with soap and water? Yes. Baseline serology before starting prophylaxis? Of course, yes. Repeat serology after 3 months? Yes, you have to repeat therapy with tenofovir. You have to give the treatment. But what is the catch there? It's not monotherapy. They have told monotherapy with tenofovir for 4 weeks. That's wrong. You don't give monotherapy even for prophylaxis. Guideline says to give your triple drug regimen, and it's not monotherapy. Okay, so the option B, saying that monotherapy is the correct answer, that's the wrong one. Okay, so now we'll see a bit about your HIV, the treatment and the treatment part mainly as per the program regarding your HIV. Okay, so we have for HIV, what you have, we have a test and treat policy. That means you test the person for HIV, and if he is positive, you start the treatment. Initially, what we used to think, what we used to say was, we used to give the treatment based on the CD4 count. If CD4 count is this much, you start the treatment. If CD4 count is this much, you don't give the treatment. Nothing like that now. At present, if the person is HIV positive, you start the treatment, irrespective of the CD4 count. So that's a HIV test and treat policy. Second question, What are the tests? I'm just writing the names, okay? You have screening tests, you have diagnostic tests. So under screening test, you have triple test, right? You have your ELISA, rapid test, and spot test. Under diagnostic test, you have your Western blot, and RT-PCR. Now, important part, the treatment for HIV positive. Okay, so I'm going to start with the treatment part. So, for adult, first remember for treatment, what you're giving, now you have fixed dose combination tablets daily. Daily tablets, irrespective of CD4 count, is given for treatment. And for adult, what you give, you have 3 drugs. Okay, it's an FDC of 3 drugs. Which are they? TLD. Remember, TLD. This is the treatment of choice for adult HIV patient. TLD. What is T? Tenofovir. L is your lamivudine. T is your dolutegravir. Okay. So, for treatment in an adult, you have to give TLD. This is the same thing which is given as a prophylaxis also. Okay. That will come down later. Now, adult treatment TLD. Suppose it's a child. You have a child patient coming to you with HIV. If it's child, instead of T, you give Z. The ZLD. That is zidovudine. Zidovudine, instead of tenofovir, it's better to give a zidovudine in children. So your treatment of choice becomes ZLD in case of a child. What about a newborn? It's a very, newborn baby. For the treatment part, you give ZL, but you're just changing the diluter, just like children. Children or newborns also child only, right? So children you give ZLD, adult you give TLD, children you give ZLD. But if it's a newborn, you give ZL. Instead of T, you are giving something else. You're giving something new. That is your dolutegravir. Instead of your dolutegravir, you are giving your dolutegravir. Okay. ZL instead of T. So this is your dolutegravir is given instead of your dolutegravir. That's only change. Now, treatment part is over. Now we are going to the prophylaxis part. So how would you give prophylaxis? Prophylaxis for HIV. So prophylaxis part, first is your post-exposure prophylaxis. Just like you have in this question, somebody gets a prick, comes to you, what do you do? What is the treatment you give? Say, you give TLT. When do you give? You have to give it within 72 hours. Always best if you give in 2 hours, right? But if not possible, at least you have to give it within 72 hours, okay? Of exposure. Up to when? For 28 days. Then you have to do the serology and all that. But if asked, you can say you give TLD for 28 days. You have to start it as early as possible, but at least within 72 hours. Okay, that's the first post-exposure prophylaxis. Then TLD is the post-exposure prophylaxis as per our program, as per the National AIDS Control Program. But WHO recommends instead of TLD for prophylaxis, WHO says TED is better than TLD. TED, TED is better. Okay. So if the question asks what is the WHO guideline, instead of TLD, you have to write TED or TED. Okay. E is for your entry citabine. Probably you will get a TLD wala question, but again, if they specifically ask for WHO guideline, it is TED, not TLD. Now, what are the other prophylaxis other than this post-exposure prophylaxis? What else prophylactic treatment you can give? You have something called the pneumocystis jirovecii, right? It's a very common, frequent opportunistic infection in your HIV patients. So, Jurovic in pneumocystis preventive treatment you give. What is the preventive treatment for that? Scotremoxazole. Simple. You have to give double strength cotrimoxazole. That's the treatment. When do you start? Start when CD4 count is less than 350. Here you have to check the CD4 count, okay? Start when, and you can stop if CD4 count is more than 350 for 6 months. At least past 6 months continuously you have CD4 count of more than 350, then you can stop. If the CD4 count is less than 350, you have to give double dose of cotrimoxazole for the patient to prevent pneumocystis. Okay. What else? What else is the other, preventive therapy which we are always talking about, especially in TB patients, in HIV patients, you have to give your TB preventive therapy. The most common opportunistic infection in HIV patient is, of course, TB, right? The most common opportunistic infection is TB, so you have to give TB preventive therapy after ruling out active TB. And suppose, okay, somebody is having TB and HIV, okay, you are testing the patient, he's positive for HIV and he's positive for TB. Which treatment will you start first? Very, frequently asked question. You have to start ATT first, right? You start ATT first, then followed by 2 weeks after you can give ART, followed by ART, okay? But in case of TB meningitis, sometimes cerebral TB, then you have to wait for not 2 weeks, you have to wait for 4 weeks before you start ART. Fine? Because why? ART is actually kind of, suppressing the immunity, right? So, initially, if you give ART and then you give TB, it doesn't work. So, first you give the TB therapy, then you wait for 2 weeks, and then later on you can start ART. That's how guideline says. Okay. Now, one more section under prophylaxis. Categorize child born to HIV positive mother. So, prophylaxis to whom? To your newborn. That is child born to HIV positive mother. Okay. Here you have to see what is the prophylaxis. So, there is a high risk baby and a low risk baby. If the mother is on ART, and her viral load and all is controlled or it is lesser than the allowable limit, then you need to give the child syrup nevirapine. At least for 6 weeks you have to give. Okay. Can give maximum up to 18 months as a prophylaxis. Okay. Sometimes if it's a high risk infant where mother not on ART, not taking ART, or she doesn't know the viral load, in that case child is having higher risk. Okay, in this case you have to give, see, nevirapine alone is not going to work. You have to give nevirapine plus zidovudine. Plus, to this baby also you have to give cotrimoxazole prophylaxis from 6 weeks till 18 months or till your HIV is ruled out. Okay. So, in the case of baby, what do you give? So, for pneumocystis jirovecii prevention, you give cotrimoxazole. Yes, the cutoff is here based on 350. Then, for prophylaxis of newborn, if it's a low risk newborn, you give nevirapine alone. If it's a high risk baby where the mother was not on ART or the mother's viral load is very high, in such cases, nevirapine is not going to give, you have to give pseudoprene also along with nevirapine plus cotrimoxazole prophylaxis. Okay. So that was your, now we have discussed what all? We have discussed HIV treatment, we have discussed your malaria treatment. Now we are going to discuss your anemia treatment or whatever is told in your Anemia Mukt Bharat. Okay. So Anemia Mukt Bharat, iron tablets we give, IFA, iron folic acid, no doubt in that. Only doubt is regarding the dose and how frequently you are giving, right? So IFA dose for adolescent female under Anemia Mukt Bharat program is, they have given different options. You have to choose which is the dose for adolescent female IFA for under Anemia Mukt Bharat. Okay. So tell me what is the answer here. See, because of some technical error, I cannot see the answers while you are typing, okay? But don't worry, keep typing the answers and keep trying to answer the question along with me. And I'm asking, before I mark the answer, no, try to find out whether you can answer it correctly or not. Okay. So, IFA dose for adolescent female, the answer is 60 mg iron and 500 microgram folic acid weekly is the answer for IFA in adolescent female. Okay. So what do you know about anemia Mukt Bharat? Since it's anemia, we'll use the red color. Okay. So you know anemia Mukt Bharat. Or hereby I'm just going to write AMB. Okay. Anemia Mukt Bharat. You have the famous six interventions. What are the 6 interventions? 6 beneficiaries and 6 institutional mechanisms. Okay. 6 interventions, 6 beneficiaries, 6 institutional mechanisms. Okay, please go through all the 6 intervention, mechanisms and institutional mechanisms. Due to lack of time, I'm not going to explain each of this. We'll just see the doses. Okay, very important table. So this is the blood drop. This is a sign or this is a logo for Anemia Mukt Bharat. And let's see the treatment. Okay, see, mainly you have to study only 3 dose combinations. What are they? Either you have 20 by 100, right? That is 20 mg iron and 100 microgram folic acid, or you have 45 by 400, 45 mg iron and 400 microgram folic acid, or the most common one is 60 by 100. Sorry, 60 by 500. 60 mg iron and 500 microgram folic acid. 20 by 100, 45 by 400 and 60 by 500. Only 3 doses you have to study. Okay. Now we'll see. See, first one is your children. You have children 6 to 59 months, that is child less than 5 years, and child between the age group 5 to 9 years. Then you have adolescents, that is 10 to 19-year age group. Okay. So, for child less than 5 years, for a child who is less than 5 years, okay, what is given? You give the smallest dose, that is 20 by 100. Remember, 3 doses, 20 by 100, 45 by 400, 60 by 500, right? So, for child less than 5 years, you give the smallest dose, which is 20 by 100, 20 mg iron and 100 microgram folic acid 2 times a week. Okay, 20 starting with 2. So remember, 2 times a week or bi-weekly it is given. And this is for the prophylaxis. Okay, I'm not concentrating on this part. As of now, I'm just reading only this much. Okay, first we'll see this much, then we'll see the treatment part. So for prophylaxis, child less than 5 years, you give 20 mg elemental iron plus 100 microgram folic acid twice a week. Now, when the child is bigger, you have a bigger child here with 5 to 9 years, or if the child is an adolescent, 10 to 19 years, you have to give it weekly. Okay, and folic acid is given weekly, IFA is given weekly, but the dose is for a 5 to 9-year-old child, you give the next small dose, that is your 45 by 400 is given in 5 to 9 years, and 10 to 19 years, you have 10 to 19 years, you can consider the dose same as that of the adult, that is 60 and 60 elemental iron and 500 microgram of folic acid, but you are giving it weekly only, you're not giving it daily. Okay. And now you have non-pregnant or non-lactating women here, and lactating woman in the sense somebody who was not the baby is not less than 6 months, okay, lactating more than 6 months. In that case also you give 60 mg iron and 500 microgram folic acid. Again, this is also weekly, okay, weekly, and this lactating you mean more than 6 months, okay. And for men, prophylactically you don't give anything. As per the program, for men, prophylactically you're not giving, but for all other groups you're giving. Even if the patient is having not having anemia, that is prophylactically to prevent anemia, you're giving all these things. But for men, there is no prophylactic treatment as such. So once again, we'll just summarize. 3 doses, 2000, 4500 and 6500, right? So 2000 is given in children. You give it as IFA syrups, 1 ml syrups given per day, because 1 ml IFA syrup contains 20 and 100, okay? So 1 ml syrup given bi-weekly. Then 5 to 9-year-old child, you give 45 by 400 combination, again weekly, not bi-weekly, it's weekly. Adolescent, you give the same doses of that of adult, that is 60 by 500, but weekly. If there is a reproductive age group female or lactating after 6 months, them also for prophylaxis, same thing, 60 by 100, 60 by 500 weekly. But for a pregnant woman and pregnant plus lactating for less than 6 months, that person you have to give same dose 60 by 500 but daily. Okay, that is the difference. And men, there is no prophylactic treatment as such. Now coming to the treatment part of anemia. For treatment for child, you have to calculate and give as per the dose 3 mg per kg body weight per day. That's a dose for treatment of child anemia. And rest, all this you can remember as 2 tablets. Okay, 120 mg iron plus 1 mg folic acid means IFA BD, right? This is also IFA BD. This is also IFA BD. This is also IFA BD. So for treatment part, mostly you give IFA BD, except for children where you have to calculate based on the weight. Okay. Now the last question, based on the colors, you have to tell me what is the color, okay, of these tablets. You know, you give red tablets where here daily tablets, red for pregnant woman you give red tablet, even for the other woman also you give red tablet. But what is the color you give for adolescents? The tablet is blue. Blue tablet is given, and for the children 5 to 9-year child you give pink tablet. Okay, less than that, this is actually IFA syrup. It's not a tablet. Okay, now treatment of anemia in pregnancy. Just write it down. Pregnant female with anemia. How do you treat anemia in pregnancy? First, you classify what is the anemia, whether it is severe or mild or moderate. Okay, if it is between, if the HB is between 7 to 11 gram per deciliter, your treatment option will be IFA BD. Okay, tab IFA BD can be given. In case the patient is not tolerating, some people they get no vomiting, nausea and all after taking the iron tablet, so they don't take. So in such cases, if the woman is not tolerating this IFA, then you can shift or you can convert to this IM iron sucrose or FCM, that is your ferric carboxy maltose can be given. But if she is having less than 6 gram per deciliter or severe anemia, you will have to go for blood transfusion. You'll have to admit the patient. This IFA is not going to work, then hospital admission. Okay, you can also try this IM iron sucrose, but again, this would be blood transfusion in case of a severe anemia. Now, so that was about anemia. Now we are going to the next question, which is your TB. So you have adult male patient presenting in the OPD with complaints of cough and fever for 3 months and hemoptysis off and on. This sputum was positive for AFB. On probing, it was found that he had already received treatment with HRZD for 3 weeks from a nearby hospital and discontinued. How will you categorize and manage the patient? So you have, at present, you have category 1 and category 2. Initially, you had many other categories. So category 1 and 2 is there. Category 1 is your new treatment and category 2 is previously treated patient. So who is a previously treated patient? You call somebody a previously treated patient if the patient has taken tablets, if the patient has taken ATT for at least 1 month and then stopped. Okay, only then you say that this patient can be a previously treated patient. But if the patient has taken less than 1 month and then stopped, that patient is again considered just as a new patient. Okay, so in your question, they have told the patient was on our ATT for less than 3 weeks, for 3 weeks, that is less than 1 month, and then stop. So here, this patient belongs to your category 1, which is the category for a new patient, okay? So your answer will be 1. And what do you do? The treatment is same, 2 HRZT plus 4 HRE, that is 2 months of continuation, 2 months of intensive phase and 4 months of continuation phase. 2 HRCT plus 4 HRE is not going to change. So category 1, start the patient on 2 HRCT. Okay. So now just about a few things about the TB diagnosis and treatment part. So for TB diagnosis, as per the program, okay. For diagnosis, what all you have? You have your sputum. You have sputum AFB, which is usually considered as a screening test. Suppose a patient comes to you with fever, cough for more than 2 months, hemoptysis. What is the first thing you advise? You advise a sputum AFP, right? Sputum AFP is kind of a screening test, but it has a very good sensitivity, okay? Sensitivity is good, but it's considered as a screening test. So second one, and where can you get sputum AFP done? You can do it in designated microscopic centers. These are the areas where they have this is designated for sputum AFP, okay? PHCs and all, most of them have DMCs. So that is sputum AFP. Second, what is the second test? You have CBNAT, most important one, which is considered as a confirmatory. Even if somebody has a sputum AFP, you have to get the CBNAT also. To start treatment, no need, you can even start with sputum AFP, but still, now we advise universal CBNAT. Why is that so? CBNAT, along with saying whether the patient has TB or not, it also gives your rifampicin resistance status. Okay, it tells you whether the patient is resistant to rifampicin or sensitive to rifampicin. Your sputum AFP doesn't say that. Sputum AFP positive, yeah, patient is having TB, right? Fine. But what about the rifampicin status? That you get from CBNAT only. So CBNAT is the confirmatory test for TB as per the program. Also, you are telling universal DSR, universal drug susceptibility testing, meaning every TB patient should get its CBNAT done so that the rifampicin resistance status can also be found out. Okay. Then two more things you're getting. The liquid culture. This is called your gold standard. Which is this gold standard test for TB? It's not CPNAT, it's liquid culture. Okay. Fourth one, LPA or line probe assay. This is again for drug sensitivity testing. CBNAT can detect the resistance for rifampicin only, but you have other drugs like HRZT. What about the other HZND? These and the secondary line of drugs, drug resistance is tested by your LPA or line probe assay. Okay. Now the treatment part is the same: 2 HRZT plus 4 HRE. This is the intensive phase, and the other one is the continuation phase. And this is for the normal patient. In case somebody is monoresistant, H monoresistant, that means the patient is resistant to H or INH. In that case, you give 6-0. This is the regimen, 6 months of 0, where instead of your H, you have replaced it with E stands for ethambutol. Okay. Then, you know what is an MDR-TB? Somebody who is resistant to both H and R. That is MDR-PB, and then you have XDR-TB, right? H and R plus other second line drugs also. So in MDR-TB, what is the treatment and what is the treatment in XDR-TB? It was actually initially we had a very complicated injection regime. Now you have all oral regimens also under the program. So you have all oral shorter BDQ regimen for MDR, and you have all oral longer BDQ regime for your XDR-TB. Fine. Then what else? This is your logo of your NTEP program, National TB Elimination Program. TB Harega, Desh Jitega, TB Mukh Bharat. See, this logo should be there in your mind. Okay. Now, few more things about TB. Something what is new in TB program. Okay. What is this TB Mitra? See, Mitra is who? A friend, right? TB Mitra is a new initiative under your Pradhan Mantri TB Mukt Abhiyan, just like you have your Anemia Mukt Bharat and all, there is a TB Mukt Abhiyan recently, 2022. So under this, they told something called TB Mitra. TB Mitra is a friend who actually helps or who actually adopts a TB patient with his consent and helps him in improving the nutritional status, or maybe you're taking drugs or some financial help, whatever help, you are actually adopting a TB patient and doing whatever you can to help him, and in terms of nutrition especially. Okay. And while you're adopting this patient, it's a commitment for at least 6 months. So at least 6 months you have to take care of this patient. After that, it's depending upon you, but minimum period is 6 months. Okay, that is something called TB Mitra. So what is it? PM TB Mukta Bharat Abhiyan. So this came in 2022. Under this, you have this TB Mitra. This is the logo for TB Mitra you see on screen. Here you can adopt minimum 1 TB patient for at least 6 months. And it's not just a person. It's not Mitra means doesn't just mean an individual. I can also adopt. It can be an NGO who wants to, adopt the patient, or any private organization or any religious organization. Anyone can be a TB Mitra. Okay. So this is your Pradhan Mantri TB Mukt Bharat Abhiyan logo. This is the TB Mitra logo. Sorry, TB Mitra logo and your TB Mukt Abhiyan. And what is your, tell me what is Nikshai? You know it's the TB portal, right? What is Nikshai Poshan Yojana? This is a scheme by which every TB patient gets 500 rupees per month for improving nutrition. For the throughout the 6 months, every month 500 rupees is being credited to the patient under the name this Nikshay Poshan Yojana. It is actually a DB, that's a direct bank transfer. You give, the patient has to give the bank details and the money is credited directly to the patient's or the TB patient's account. Okay, that is Nikshay Poshan Yojana. What is this DTPB, or what you call your detect, treat, prevent, build? This is the 4 pillars as per your national strategy plan for TB elimination. Okay, so these are the steps or the strategies that you can adopt. First, you have to detect the TB, then you have to treat, then you have to prevent, focusing on the TPT or TB preventive therapy, and building the policies and better things like that. Okay, so you have that's all about TB. This is not all about TB. This is just for the time being. We are stopping here on TB. So again, TB program is very important from your exam point of view. Okay, treatment you should know, all the tests you should know, and what is new also is important. Now, next program is your leprosy program, or NLEP, National Leprosy Eradication Program. The TB was your elimination program, because leprosy we already have eliminated. Okay, we have eliminated leprosy. What is the cutoff? We said leprosy eliminated if the prevalence of leprosy is less than 1 per 10,000. So at national level, we have actually achieved the leprosy elimination. So now we are targeting for a eradication where we can completely wipe out the leprosy organism or the Mycobacterium leprae. So here, which of the following indicator shows the efficacy of early detection of leprosy in the NLEP? So they are talking about the National Leprosy Eradication Program. They are talking about the indicators. So every program will have certain indicators, right? So leprosy program indicators is what they are talking about. Which indicator shows the efficacy of early detection of leprosy? See what happens when you can detect leprosy early. When you can detect leprosy early, you can prevent the complications like disabilities. So efficacy is shown by proportion of rate to disabilities among the general population. Okay. So that is the answer here. Now few words about NLEP, or National Leprosy Eradication Program. So you have NLEP, your National Leprosy Eradication Program. Under this, would you treat the patient? Paucibacillary and multibacillary. Yeah? For paucibacillary, you have treatment for 6 months. Multibacillary, you give treatment for 12 months. Okay. Okay. What are the drugs you give? You have doctor. Most important. Doctor. Okay. D for Tapson and R for rifampicin. Doctor is constant in both, okay? Whether it is possibacillary or multibacillary, you give rifampicin and dapsone. But if it's multibacillary, along with this, you also add one more drug, that is clofazimine. Okay, so possibacillary, it's just two drugs, rifampicin, dapsone. Multibacillary is rifampicin, dapsone plus clofazimine. And how do you give? The doses are, rifampicin is given monthly. Rifampicin is given 600 mg. Rifampicin is given 600 mg once monthly under supervision. Okay, the patient has to go to the PHC and then get the tablet under supervision. Okay, that is rifampicin. What about dapsone? Dapsone is given at daily dose, 100 mg daily. Okay, 100 mg daily dose for dapsone. And what about clofazimine? In case of clofazimine, it's just half the dose of rifampicin and half the dose of dapsone. That will give you the dose of clofazimine. So rifampicin is 600 mg once monthly, right? So instead, clofazimine becomes 300 mg once monthly. Plus, what was the dose for dapsone? 100 mg daily. So I'm halving it. You have 50 mg daily dose of clofazimine. This is the treatment protocol for possibacillary as well as multibacillary leprosy as per the program. Now, prophylaxis. What is the drug of choice for prophylaxis of leprosy? It's rifampicin. Okay, rifampicin is the drug of choice for prophylaxis. Whom do you give? Single dose rifampicin given to all household contacts and social contacts. Who is the contact? Contact is somebody who had the contact with the patient, with the leprosy patient, for at least more than 12 hours per week. In a week, at least 12 hours contact. Only then he's considered as a potential contact, and he needs to be given a prophylaxis. So just writing it down. This is the symbol of NLEP. I hope you all know this. The lotus symbol, the rising sun and the lotus is the NLEP logo, not symbol. I'm sorry, logo. Okay. So we were talking about prophylaxis. This is to contact time. Those who are contact with a contact time of more than 20 hours per week is the person for prophylaxis and treatment. Single dose rifampicin, right? Is given. Now, two more programs, two more names related to your this thing, leprosy, Sparsh and Sapna. Sparsh is your awareness campaign. Sapna is that schoolgirl mascot. Again, for awareness regarding leprosy, not against. Okay, we'll see what are the core indicators. Okay, just add one page here. The question was actually asking the core indicators of leprosy, right? So we'll just write it down. Core indicators of the program. Indicators of NLEP. Okay, you have 4 indicators to learn. First one is your annual new case detection rate, or ANCTR. This is the first one. It is an epidemiological indicator. And what are we aiming at? More than 10 per 1 lakh in high burden areas. Second one is your G2D, grade 2 disability. G2D is grade 2 disability, okay? Per 10 lakh population. This is your operational indicator. This was your question. No, your question was indicator for early case detection. It's all your disability. If you detect the case early, it won't progress to disability, right? Then you have something called your curate, and you also have your prevalence rate. These are also epidemiological indicators, but prevalence rate, what is the use? It gives you a estimate of the long-term impact. The prevalence to come down, you need a longer time takes, right? So long-term impact gives, then so you know the indicators, you have the grade 2 disability, you have the curate, you have the prevalence, and you have the ANCDR or the annual new case detection. And last point under leprosy is the targets. What are the targets we are aiming at for prevalence rate should be less than 1 per 10,000 at district level. This is what we are targeting at, okay? District and subnational level. What is this prevalence less than 1 per 10,000? That is the criteria for leprosy elimination. I told you leprosy has been eliminated in India at national level only, not the subnational or the district level. So we have to achieve that same thing in the district and subnational level. That's one aim, one target. Second one is decrease grade 2 disability percentage to less than 1 among new cases at national level. Okay. Third one is decrease G2 with disability case number less than 1 case per million. This is also at national level. These things we have not achieved at national level. So these are, we are aiming to achieve these things at national level. Okay. Now, so now we'll see in quick about all the maternal and child death or the RCH programs. So the first question, a recently delivered woman with a 14-day-old newborn suffering from cough, sneezing, fever needs help. So she's a recently delivered woman. Her baby is only 15 days old. She has no money for transportation to nearby hospital. Which of the following national health program can help this woman? Tell me which is the program which helps the mother as well as the child, okay, to get medical help without any cost. So it is your, I told you, mother as well as the child, right? So it is your Janani Shishu Suraksha Karyakram, where there is the Janani, that is mother, and the Shishu, that is your baby. So Janani Shishu Suraksha Karyakram is the one which helps this, is the one which is going to help this mother. Okay. So we have Janani Shishu Suraksha Karyakram is the answer here. So we'll quickly see what all are the RCH programs. So this first one is your JSSK, which is the Janani Shishu Suraksha Karyakram. So both the mother as well as the child, you are the mother and the child, they are eligible for free OPD, free IPD, transport, treatment, investigation facilities, and if she has to undergo an LSCS, that's also free. She needs blood, that is also free, but provided it's a government facility. Okay, you don't get this in private facilities. So all this is got free of cost. That is their JSSK, and mainly they are doing this to promote public facility utilization. Thereby, using the public facility also to decrease all the rates, infant mortality rate, maternal mortality rate, everything. Up to 1 year of age, that is till the child is 1 year of age, she can get all these benefits under the JSSK or Janani Shishu Suraksha Karyakram. Okay. Next, what you have? You have Janani Suraksha Yojana or JSY. JSY is for the Suraksha or the safety of the mother. So we are focusing on Janani Suraksha Yojana, not about the child. So this is basically to decrease home deliveries and to improve institutional deliveries. Home deliveries are a very common cause of PPH and maternal mortality. So at least the woman should be delivering in a hospital. We cannot tolerate even one home delivery, right? So Janani Suraksha Yojana is promoting institutional deliveries. And who's the person who's going behind the mother and telling us to go to hospital, let's go get delivered in the hospital? Who's that? It's your Asha. Okay, so and Asha does get an incentive for this. Okay, incentive, the Asha also gets an amount. That is, if the mother comes and delivers in a home, in a government hospital, the mother is also given an incentive as well as the Asha is also given an incentive. Okay, how much is it? Incentive for Asha, you have 600 rupees for rural and 400 rupees for urban. Whereas for mom, for the mother, incentive for the mother, how much is it? Again, you have rural, urban, rural, urban. Under JSY, you have something called high performing states and low performing states. Okay, so low performing states under rural they get 1,400, and for low performing urban they get 1,000 rupees. Some other gets, and here it is high performing states, rural 700 and 600. Okay, so usually low performing states get more money. Similarly, your rural area get more money than the urban area. Okay. So JSY, JSSK over. What else is this? What is this? Pradhan Mantri Madhur Vandana Yojana. Yes. You see a mother and a child in the logo. What is this? This is actually incentive for female. Mainly what you're doing is because of pregnancy and all that, the woman is maybe she's not able to go to work. Not everybody gets this, luxury of maternity leave where she gets paid and she gets the leave. No, most people don't get it, right? Especially in the private sector, they don't give any maternity leave, things like that. So it's actually to support those mothers where you're giving some incentive to the mother. The incentive is 5,000 rupees. The mother gets a 5,000 rupees as a financial incentive. So she gets INR 5,000 as incentive, but it is not given not together. It's given in 3 installments. Okay. To get this money, she has to follow the rules of the program. First thing is early registration. The first installment she gets while she registers the pregnancy at the earliest. Then on institutional delivery, that is when you get the second installment, and the final installment is given when the baby is given the first vaccinations, not the 0 dose. I'm talking about the first dose of vaccination at the 6 weeks. Okay, then she gets, once she completes all this, she'll get amount of 5,000 rupees. Fine. Now this is your PM, Pradhan Mantri Matru Vandana Yojana, PMMVY. Now confusing another thing, PMSMA, Pradhan Mantri Surakshit Matrutva Abhiyan. Okay, here what happens is, you see here 9th of every month. This is, you are providing ANC screening, free screening for high risk. Some places, especially there are no gynecologists won't be available, or they still lack access to health services, especially for the ANC care. So what you're doing is 9th of every month, these specialists, they go to this particular place, they conduct a camp there, a health camp where the pregnant woman can come, get screened for all the diseases. Then she'll be classified based on the risk, whether she's a high risk mother, whether she's a low risk mother, whether she will be color tagged also, so that we can identify earlier. So PMSMA is free ANC screening, and everything is free. Okay, treatment, everything. When do you give? On 9th of every month. And you have some color coding also. Sometimes you say the lady, blue color coding is given in case she's she's having hypertension, pregnancy induced hypertension, the color code is blue. Yellow if the mother is having thyroid disorder or diabetes mellitus. Red in case of high risk pregnancy, and green in case of no risk. Okay, so you have green for no risk, then you have red for high risk pregnancy, then what else? You have your yellow for diabetes and thyroid, and finally you have blue for PIH. Okay, this is the color coding as per the PMSMA. Now last you can see MA. What is MA? MA is mother's absolute affection. It's actually an awareness campaign to promote good nutrition as well as to promote breastfeeding. What does they say? You see, breastfeeding within 1 hour of birth. Breast milk alone is the best food. That is exclusive breastfeeding. Then about weaning, how to start. About, you don't use weaning, you say complementary feeding, when to start, what to start, and also you advise the mother to continue breastfeeding at least for at least 2 years. Exclusive for 6 years and continue till 2 years of age. Okay, so this is Ma, mother's absolute affection. Now what is this Ma, everything is written here in this photo only, so I'm not writing it again. Okay, basically to improve nutrition of the baby. Now you have something called Suman, that is Surakshit Madritva Ashwasan. This is something new. This is a scheme. This is actually, so whatever schemes we have told, the JS5, JSS, everything, when the woman goes to get it in the, when goes to avail these, in the hospital, sometimes what happens is the quality is compromised, or sometimes, they don't behave properly, she has, some issues with the dignity, the quality, things like that happen, right? So we don't want such thing to happen. We want the care, whatever we are giving to the program, should be a quality with dignity that should be given to the ANC mother, to ensure that we have something called as Suman or Surakshit Matritva Ashwasan. Okay, so under this you have to remember one point, it's a quality guarantee service. Okay, with dignity. Then here you have something called grievance redressal. So if the woman is not satisfied with the quality of care given, she can, that actually a way in which that can be, addressed. That's your grievance redressal mechanisms. Then it follows a zero tolerance policy. Okay, that is any compromise in quality, or any form of questioning the dignity cannot be tolerated. That is what your zero tolerance formality means. Okay, now what is this? This is your logo for your Lakshya. Again, this is also quality Q. This is a quality improvement initiative for your labor room as well as your OT. Okay. Two more things which I have not written here. I'm just going to write it down here. One is your home-based newborn care, and you have something called home-based HBNC and HPYC, home-based newborn care and home-based care of the young child. Both these are home visits done by ASHA. Okay, ASHA worker is supposed to go to certain days are there. We'll see it in another question. So there she's supposed to go and counsel the mother if there are any danger signs, pick it up fast and send them to the hospital. So things like that done by ASHA, that is the home-based newborn care and HPYC. Then another thing is your India Newborn Action Plan, or your INAP. This actually aims to bring NMR, that is your neonatal mortality rate, to single digit, and your stillbirth rate also to single digit plus by when? By 2030. This is what it's aiming at. Okay. What is the current neonatal mortality and what is the current IMR? We haven't discussed it anyway, right? So I'll just write it down now here. Current values based on the SRS, okay, your sample registration system values. Your IMR at present, India has an IMR of 28. You have NMR, or neonatal mortality rate, is 20. So NMR is 20, IMR is 28. Your maternal mortality ratio at present is 97. Okay, these values you should be knowing. Now we are moving on to the next question. And under these programs, two more programs, one is RBSK, RKSK, not directly related to RCH, but again, RBSK is Rashtriya Bal Swasthya Karyakram for Bal is children, right? For Bal. So Rashtriya Bal Swasthya Karyakram is mainly to detect defects, deficiencies, disabilities, and deformities in the child. So the child is actually being screened for any of these, and if you find the child is having a disability or any defect, the child is being referred to a district level center, that is your DEIC, or district early intervention centers, where the early interventions can be made. Similarly, you have something called your RKSK, that is Rashtriya Kishore Swasthya Karyakram. K is for Kishore. Kishore is who's Kishore? Kishore is adolescent. Okay. RKSK is a program for your adolescent health, whereby one thing is your they have specialized clinics, especially for adolescents, catering to the problems of adolescents, that they are called the adolescent friendly health clinics, or AFHCs. Okay, initially they were called ARCH clinics and all that. Now that name is not used. ARCH was mainly for the reproductive health services, but now you know adolescents not just reproductive health. There are you have to look at a holistic approach. So you have something called AFHC, Adolescent Friendly Health Clinic, coming under your RKSK, Rashtriya Kishore Swasthya Karyakram. Okay, so now I think we'll take a short break. After the break, we have a few more questions regarding the newer initiatives in the national programs. Then we'll go on to the other segments also. Thank you. The Ayushman Arogya Mandir are the new health centers established to replace. So what is this Ayushman Arogya Mandir? This is something under your Ayushman Bharat, and this is a new name for your HWC or Health and Wellness Centers. Okay, so this is the logo for your Ayushman Bharat. Few points about Ayushman Bharat, which is important. So it's a newer program, and you can get questions from Ayushman Bharat. Okay, so Ayushman Bharat is the Government of India flagship program in 2017 with the vision of universal health coverage. That's everybody should be entitled to get good health services. Okay, and they are following this continuum of care approach, and you have mainly two components or two prongs of Ayushman Bharat, which is one is your what we were just talking about, health and wellness centers, and next one is your insurance scheme or PMJ, Pradhan Mantri Jan Arogya Yojana. So these are the two prongs of Ayushman Bharat. This is mainly your primary health center level. This is at the secondary and tertiary levels. Okay, so what is this health and wellness centers? It's nothing but your currently the current sub centers, your primary health centers are being upgraded into what is called the health and wellness centers under the Ayushman Bharat. And under this, you have someone called CHO or the community health officer. Usually, it's a nursing officer who is appointed under this health and wellness centers. Okay. Then what is this PMJ? It's just like an insurance. It's a largest health assurance scheme. Okay. That is, people are entitled to cashless healthcare services under this program, and per family they get 5 lakh rupees. So how much is the amount given according to this PMJ? 5 lakh per family per year. Okay, for secondary and tertiary level hospital care. So who are entitled to this? You give, the bottom 40 percentage of the population. India's the lowest 40 percentage of the population in terms of socio and economic development. Those people are given this benefit of PMJ, whereby they can get maximum of 5 lakh rupees per family per year for health related expenses in hospitals, that is secondary or tertiary care hospitals. Okay, 5 lakh per family per year. So 40%, the bottom 40% of population is given. How do you select this? Who is entitled? You had something called a socio-economic caste census of 2011. It's based on the data of the census that beneficiaries are selected. Okay, and initially before this BMJ came, we had something called RSBY. Okay, the patients, if you had worked in a government hospital, you'll see patients had a pink slip and all that with RSBY card. So when we write it in that slip and give, they get medicines free of cost. This thing is actually subsumed. This is not there anymore. It's been substituted by this your PMJ. So all those who were getting the RSPY scheme, they are now, instead of RSPY, they are also automatically eligible for this PMJ. Under RSPY, the maximum amount was, I think, 30,000 rupees. But here you have 5 lakh per family per year. Okay. Next question is Ujjavala schemes for prevention of child trafficking. Okay. I put this question purposefully because you have three different names which are very familiar. You have Ujjala, Ujjwala, and Ujjavala. Okay. Ujjala, Ujala, is your LED. Okay. And your Ujjwala is where women are given LPG cylinders free of cost or at subsidized rate. And this is your Ujjavala. This was your question, where this is a scheme to prevent, as an effort to prevent immoral trafficking, especially the child, women and girl child trafficking prevention. That's your Ujjavala scheme. Fine. Now, next question is a direct question from Vision about your blindness control program. There's a 46-year-old female presenting to OPD. Her vision in the right eye was 6 by 60, left eye 3 by 60, under the National Program for Control of Blindness. So under the national program, how do you classify her? Does she have low vision? Is she blind? So under the National Program of Control of Blindness, 3 by 60 is considered as low vision. Okay, but under the WHO criteria, 3 by 60 accounts for blindness. Okay. So I'm not explaining this. You have different cutoffs for visual acuity. You have different cutoffs for your NPCB as well as your WHO. So you should know the cutoffs also. Okay. So now the next question is, what is this population-based screening? The population-based screening initiative is under which national program? Okay, this is again a hot topic. Not asked yet, but I think this has a quite a high chance of being coming in any exams. Okay, PBS or population based screening initiative is an initiative under your NPCDCS or currently known as NPNCD, that is National Program for Non-Communicable Diseases. The older name was NPCDCS. What is this population-based screening? Under this, NPCDCS or NPNCD is for NCDs, right? So under this, we have something called population-based screening where more than 30-year-old population is screened. By whom? By your ASHA or the ANM or your multipurpose worker. They go house to houses to screen all those who are above 30 years of age and for screened for hypertension, diabetes, and 3 cancers which are there, which can be screened by your ASHA worker, can be oral, breast, and cervical. Basically, what they do is they go, there is some questionnaire and all that, so they go and ask, and those who are found to be having high risk or positive for screening, they'll be referred to the higher center. That's usually the PHC, and rest will be done by the medical officer of the PHC. And again, if needed, the person will be referred to the higher center. Population based screening, NPNCD. Okay, age group more than 30. Fine. This is this logo for your NPCDCS or currently known as NPNCD. And now we'll see just 2 more new schemes. After that, we can stop this national health program. So one is this Amrit. Amrit is where it's a scheme by Government of India where medicines are given at a very subsidized cost or at a lower cost, especially those medicines which are very costly, like your cancer treatment drugs or your cardiac drugs, cancer drugs, things like that, which are given at a subsidized cost. Amrit stands for affordable medicines and reliable implants for treatment. So basically, it's an initiative by your Ministry of Health and Family Welfare where these things are given at a subsidized rate. Okay. What is Kayakalp? Kayakalp was started in 2015 again by initiative by Ministry of Health and Family Welfare. This is actually just to promote cleanliness. Kayakalp is to promote cleanliness in public places. Okay. Cleanliness in public places, especially you have Kayakalp awards and all for the best PHC, best health center and all that. So, and it's an effort to complements your Swachh Bharat Abhiyan. Okay. So now, so that was the end of your national health programs, not the end, but I've just tried to, I've only incorporated only the most important questions. So now we'll go to some of the questions from environment. Okay. From your environment. So since we are running short of time, I will be quickly going to the questions and answers. First question is temporary hardness of water is primarily due to the presence of, you have calcium and magnesium sulfates, chloride, bicarbonates, nitrates. So the question you're asking is temporary hardness, right? So temporary hardness is always due to bicarbonates. Rest everything, whether it's sulfates, chloride, or nitrate, it is your permanent hardness. So hardness of water can be temporary or permanent. Temporary hardness is due to bicarbonates of calcium and magnesium, and all others will be your permanent hardness. And how do you remove temporary hardness? Simply by boiling. Boiling, you can remove the temporary hardness of water. Okay. Now, other than that, from water, some more points I would like to add here. Water quality, you have physical quality indicators. Water comes under physical quality indicators. The water density, the water color, things like that comes under physical quality. Then you have chemical quality indicators. Okay. Your hardness and also chemical quality, right? Then you have biological quality. So a few important points from biological quality indicators, we'll just write it down. So first one, best method to detect fecal contamination of water. Fecal contamination. What is the best method to detect fecal contamination of water? That is your coliform count, right? The E. coli or the coliform count is the best method to detect fecal contamination of water. And what is the permissible level of coliform count in water? 0, nothing. no permissible level of coliform. Coliform should not be there in water, okay? In drinking water, it should not be there. Okay, so permissible level is nothing, 0. Next is fecal contamination is your coliform count. Then the test for this can be your McCartney test you have, McCartney chart you have. Then you have the MPN method. All these are methods for coliform count, okay? Then, how do you detect recent fecal contamination of water and remote contamination? Okay, for recent fecal contamination, you have presence of fecal streptococci. And for remote, you have Clostridium perfringens. If present, it denotes remote contamination, as the reason is fecal streptococci. Okay, now, what about sand filters? There is a rapid fire sand filter and a slow sand filter, right? So sand filters, you should know the basic differences. I'm just telling the important points, rapid and slow sand filters. So under rapid sand filter, the main filtration is by your sand bed, whereas in the slow sand filter, the main filtration is by the biological layer, also known as, that's a very difficult name to remember, you have your Schmutz Decay layer. Okay, then next question, we are going to deal with a question regarding chlorination. So orthotoluidine test or OT test is used to determine options: nitrites, free and combined chlorine, ammonia content. Okay, OT test is used to determine chlorine content in water. Okay, free and combined chlorine content in water is got by OT test. So under chlorination, you have two tests. It's not just the OT test. We have something called OTA, orthotoluidine arsenate test. So you have OT test and you have either OT, orthotoluidine arsenate test. Okay, what is the difference? OT test can detect free and combined chlorine in water. This thing, OT arsenate test, can detect these separately. OT test gives you a combined value, whereas it can detect free and combined chlorine separately. That is your OT arsenate test. Okay. Then what about the residual chlorine? Residual chlorine. How much is the residual chlorine that should be remaining after, well water chlorination or normal chlorination? What residual amount should be there remaining? You should have at least more than 5 ppm. Okay. Only then the chlorination is going to work. What about in post-disaster phase? 0.5 is not enough. There you need 0.7. And so swimming pool chlorination, you have at least more than 1 ppm should be there, residual chlorine. Okay. Now, what is this? Since we are talking about chlorine, we have only one apparatus regarding chlorine, that is your Horrocks apparatus. Okay. So Horrocks apparatus, what is the use? It gives you the amount of how much bleaching powder is to be added. That's got by this. Okay. Amount of bleaching powder to be added for 455 liters of water is got by your Horrocks apparatus. Please go back and try to learn all the steps of chlorination. What is chlorine demand? What is how much is needed? So all those things should be there at your fingertip. Okay. So next question. So that was about water pollution in general and water. Now we'll move on to the air pollution part. So question is, all are indicators of air pollution except soiling index, McCardle's index, suspended particle count, sulfur dioxide concentration. So the answer here is, what's the answer? This is actually, the comment section is actually a bit slow, so I'm not able to see the answers when you are typing. So I'll just say the answer here, okay? So the answer here is McCardle's index. Except this, all others are examples of your air pollution indicators. What is this McCardle's index doing? It is an indicator of thermal comfort, sweat rate, comfort, or it gets something called your sweat rate is what's measured, okay? So that is your McCardle's index. All others are indicators of air pollution, okay? Few MCQs again here. Best Best indicator. If I ask you which is the best indicator of air pollution, what is it? It's your sulfur dioxide. Okay, sulfur dioxide concentration is the best indicator. But if I ask which is the best biological indicator, then your answer should be lichens. Okay, best indicator is sulfur dioxide, best biological indicator will be lichens. Now, let's move on to the next question. This was a recently asked question in your, actually not NEET, but INI-CET. Okay, so New Delhi reported the following AQI. Which type of AQI was reported on 24th number? So 24th number, you have an AQI of above 400. So AQI is air quality index, you know. If it's above 400, then it is severe. Okay, 4 values you have to study. Above 400 is severe, above 300 is poor, less than 100 is fine, satisfactory. The quality or air quality, and less than 50, then it's good. Okay, this is actually good. So less than 50, less than 100, fine and good and satisfactory. More than 300 becomes poor, and more than 400 becomes severe. Okay. So this is your air quality index. You can be given a picture like this, and you can be asked to identify what does this mean. So that's your AQI. So now we have a question regarding your soft tick. All of the following diseases are caused by soft tick except tularemia, Q fever, relapsing fever, KFT, which is not caused by soft tick. That means which one is caused by hard tick? The answer here is your tularemia. Okay. So rest, everything is caused by soft tick. So just remember, you have soft tick and hard tick, right? Soft tick causes 3 diseases you should know, which is RKQ. So RK, maybe you can remember Ranbir Kapoor. Q, I don't have a mnemonic, so RKQ. Okay. R is for relapsing fever. K is for KFT. Q is for Q fever. Okay. So soft tick, RKQ. So rest will be your hard tick. Okay. So under hard ticks, we will just write down hard tick. You have one is your question which we've been given now, tularemia, tick typhus. Then you have babesiosis. You have viral encephalitis caused by heart tick. Then you have hemorrhagic fever. So things like that by heart tick. So it's easy to remember the soft tick part. Okay. Sorry. So soft tick RKQ. Okay. Now, just like tick, you have something called mites, right? Similar, quite similar to tick in appearance. Mites can cause 2 diseases mainly. It is one is your scrub typhus, recently been in news, and your scabies. Both these are caused by mites. Scrub typhus is caused by your trombiculate mite, and scabies is caused by your itch mite, also known as sarcoptes. Okay. Now we have completed 7 segments. Now we are left with 3 more. We have a segment on health systems, and we have a segment on infectious diseases, and finally we have a miscellaneous mix. Okay. So now let me move on to the health systems and management and communication part. So these are, quite direct questions, nothing much to explain, no concepts, nothing, but things you should know. So first question, subcenter in a hilly area caters to a population of how much? Subcenter population is actually 5,000, but when they specifically say hilly area, it's not 5,000, it's 3,000. Okay. The subcenter in a hilly area caters to a population of 3,000. So this is given here. You should know the population of, what is the population of subcenter, what is the population of a PHC, what is the population of a CHC, different for hilly areas and your other, normal plain areas. Also, you should know what is, for how much population is one ASHA worker, for how much population is an Anganwadi worker. So all these things I put in this table. So this first value is your plain. The second, row is the hilly area. So subcenter plain 5,000, hilly area 3,000, PHC 30,000 and hilly area to 20,000. So it is 30-20 in PHC. Subcenter is 5 and 3. Then like that CHC also you should know, and Anganwadi also you should study. Then your population covered per Anganwadi worker is 400 to 800. Okay. For ASHA, 1000 population. One ASHA for 1000 population. Then multi-purpose worker is 5000 population. Simple. Multi-purpose worker is seen where? Subcenter. So subcenter, if the population 5000, that means multi-purpose worker is for 5000 population, right? So similarly, see here, multipurpose worker I told is in subcenter. So the population for multipurpose worker is same as that of a subcenter. Similarly, where do you see health assistant? Health assistance is posted in a PHC. So population for one health assistant will be equal to that in a PHC, right? That's how you correlate and study things. Now we are moving on to the next question. Primary health care. So under primary health care, you have something called the pillars of primary health care and you have something called elements of primary health care. Okay. So they are asking you all of the following are pillars of primary health care except your answer should be what are the pillars of primary health care and which is not. So here the answer is health education. Health education is not a pillar of primary health care. Rather it's a element of primary health care. Okay. So we'll just write it down. So you have pillars of primary health care. You have 4 pillars. Okay. 1, 2, 3, 4. And you have something called elements. We'll write with a different color. You have pillars. Just like that you have elements of primary health care. Okay. So under pillars of primary health care, which are the pillars of primary health care? You have 4 pillars of primary health care which can be remembered as care. Okay. So C is for community participation. A is for appropriate technology. R is for, actually R is not the correct one, but intersectoral coordination. Okay, R is for intersectoral coordination, not a quite a good mnemonic, but still. E is for equitable distribution. Okay. These are the pillars of primary healthcare: community participation, appropriate technology, intersectoral coordination, and equitable distribution. 4 pillars of primary healthcare. Now, what are the elements of primary healthcare? Simple. It is given by the mnemonic elements itself. Okay. So, elements of primary healthcare: E is for essential drugs. L is for control of locally endemic disease control. Okay. And the next T is for extended program of immunization. Basically immunization. Okay. Just to fit in the mnemonic, we are writing it as EPI. MCH, maternal and child health plus your family planning. Next E is for education. What is your health education? N, nutrition. Treatment of minor illnesses. And last S is for sanitation and safe water, or safe water and sanitation. Okay. These are the pillars and elements of primary health care. Now we have a question. Again, a question which is hated by most of the students, but we have a very funny and a beautiful mnemonic made by someone, I don't know, but it's very famous among students. Some of you might be already knowing. With the help of that mnemonic, we'll be able to study all the committees. Okay, the question is, multipurpose worker scheme in India was introduced following the recommendation of whom? So who introduces multipurpose worker scheme, or which committee proposes multi-purpose worker scheme? Okay, multi-purpose worker scheme is by your Kartar Singh committee. Okay, Singh is king. Okay, Singh is king. Singh is a Punjabi. Singh is king. He can do multi-purpose things at a time. Very active. So multi-purpose worker is for your Kartar Singh committee. Okay, so what are the other committees? We'll just study all the committees in PSM. Okay, we have 2 pages here. So I'm just writing down all the committees. The first one, Board Committee. Board Committee. What all things did Board Committee do? See, the code is Board Medicos. The Board Committee actually board the medicos with 3 months of PSM training. PSM is considered as a boring subject was by most of the students, not me, but still most of the students. So here you can remember it as board committee actually board all the medicos with 3 months of PSM training. That is one. Second one is which else is the boring subject, one which you have studied in school, social, right? No offense, but social was a boring subject. So social physician, that is another one. Social physician concept also came in your board committee. Okay. Second committee is your Mudaliar. You have your Mudaliar committee. Mudaliar was a IAS officer actually. So you can remember it as All India Health Services. This committee proposed the idea of All India Health Services, just like your IAS. Now we are going to the third one, Chadda committee. Chadda committee, the mnemonic goes like this. Chadda used to sleep wearing chaddi alone. Okay. I hope you know what it is. Because of this, because of no proper clothing, he was prone for getting what? Mosquito bites. So if he sleeps like this without proper clothing, what will happen? Mosquito will bite him, right? So he'll get malaria. So he was to work on malaria eradication. So malaria eradication related committee is your Chadda committee. Okay. Fourth one, Mukherjee committee. Mukherjee committee. You know where Mukherjees are from? Mukherjees are from Bengal. No, Bengal. See, there are so many Mukherjees. Bengal is actually quite a populated state. So Mukherjees were like, we are so many numbers, so we'll just, try to reduce our numbers. That this much of Mukherjees is not needed. So we'll just try to reduce our number. To reduce the number, you have to go for family planning. So Mukherjee committee actually worked on family planning, okay, to reduce their number. So that was Mukherjee committee. Then you have someone called this Jangalwala committee. Okay. What did this guy do? He made some jungly provisions, okay? Like he said, doctors should not do any private practice. No private practice. Then something called equal pay, regarding equal pay, special pay, things like that were told by the Jangalwala committee. Next one is your question, Kartar Singh. Singh. So Kartar Singh, I told you, Singh is king. Singh is king. He's a Punjabi. He can do multi-purpose thing. So multi-purpose worker idea came to the committee. Remember the first three words here, S, H, R. I'm just rearranging this, okay? If I rearrange this, what will I get? I'll get RHS, that is your Rural Health Services. So basically, this committee worked on improvement of rural health services. Then also you have referral service, health education, semi-professional workers, everything is coming under the Srivastav committee. Then you have your, Balwant Rai Mehta committee. See, this is the only committee which has three names, Balwant Rai Mehta, right? So, three-try system. Simple. And one more committee is your Bajaj committee. See, Bajaj has, lot of very powerful productions like your Pulsar or your Avengers. All these are Bajaj things which are very, powerful. So, here it's for manpower planning. Powerful. Remember, Bajaj is powerful, okay? They're a big company with all the power, a lot of manpower, production, management, everything. Okay, you have one more committee, which I did not tell you. That's a Krishnan committee. Krishnan committee basically helped in renewing or regenerating your urban health schemes. Basically, they worked on urban health schemes or promote urban health sector. You can remember about Lord Krishna. Maybe he renewed everything, right? So just like that, but here focusing only on the urban health scheme. This is roughly about the committees. So next one, number of ASHA visits after home delivery. This we have already discussed, right? Number of ASHA, we have not discussed the numbers. Okay, what is this home delivery for ASHA visit? What is this? What are they talking about? They're talking about something called as home-based newborn care. I told you the ASHA worker is supposed to go and visit the houses of newborns on particular days. That is called a home-based newborn care. Just like home-based newborn care, you have something called home-based care of young child also. Okay. So for ASHA worker, number of visits after home delivery is 7. Okay. So I'll just show you one. This is an INC material for this. This is the for the home-based newborn care by, I think, Assamese government or someone. So what is happening is, once the child is born, once the child is back at home, the ASHA worker has to go and meet the child. For home visit, there are 7 visits, but if it's a hospital visit, if it's a hospital, you have only 6 visits, and if a mother is coming after cesarean session, means she'll come only after 5 days, right? So 5 visits. So you have 7, 6, 5. 7 visits in case of home delivery, 6 visits in case of hospital, vaginal delivery, and 5 visits in case of hospital LCS. Okay, this is the number of visits, and the 6 visits in this, you can see the first 6 visits after a hospital vaginal delivery. First visit on the 3rd day, so the days are 3, 7, 14, 21, 28 and 42. And does she get any incentive for this? Yes. For each child, she gets 250 rupees. Okay. So incentive is 250 rupees per child. Not per visit, it's per child. So what is she supposed to do? Asha is supposed to go and ensure, and counsel the mother, not just the mother, the other family members also, regarding whether the newborn is getting proper adequate breast milk, whether colostrum is being given, whether the baby is protected from hypothermia, kept warm, whether the mother is receiving adequate diets, and if there is any danger signs which needs immediate referral, and teach the parents, teach the mother about the vaccination of the child, and how about the safe water, sanitation practices, home hand washing, and also age appropriate play and communication. Everything is the function of the ASHA. She's going to counsel the mother and the other family members regarding all this. So that is your home based newborn care. Okay, even for home based care of young child also. So home based care of young child, you have only 5 visits. Okay, home based care of young child, only 5 visits. This is at 3, 6, 9, 12 and 15 months. Whereas your newborn is, you're saying it in terms of days. Okay, here also she gets 250 per child as the incentive. Okay, this is the same only. So we'll move on to the next question here. So what is this? Which of the following conditions must be fulfilled for a PHC to become a first referral unit? So PHC to become a first referral unit. What do you mean by referral unit? From a smaller center, you're referring the patient to a higher center because they have something more. They have some more facilities, some more doctors, so some more, beneficial things for the patient. So for a PHC to become a first referral unit, it should have emergency obstetric care. Only then any PHC or a CHC to become a first referral unit, it should have an emergency obstetric care. So what are the things under the emergency obstetric care? You have the normal obstetric care things like provision to give IV antibiotics, provision to give oxytocin, methods to remove placenta, manual removal of placenta. If there are any retained products of placenta, that also removal should be available at that center. Then what else? Then you have your facility for assisted vaginal delivery. All these are points coming under your emergency obstetric care. Along with these 5 points, the most two important points are there should be provision for cesarean section. In case of an emergency CS, there should be provision for that. So if there is a CS section, if there's an operation, of course you need blood transfusion facility, right? So CS and blood transfusion facility should be available. Only then you can say that you can upgrade a center to a first referral unit. Okay. So all the initial things plus LCS and blood transfusion facility should be available to say that, okay, this is an emergency, this comes under the emergency obstetric care. Now, next question is from your management part. What is this time taken for any project is estimated by? Time taken for any project is estimated by something called your network analysis. Okay. So network analysis is a plan. It's a graphical plan. You are going to plan all the events leading to the particular outcome in a graphical manner so that you can estimate this is the time taken to complete this work. So in management, if this is a work, what is the estimated time I need to complete the work? For that, you're writing down all the steps. Step 1, recruiting the people, then teaching them things like whatever is your concerned thing. You're writing all the steps in a order in a graphical manner. This is called network analysis, and under network analysis you have two types. One is your PERT and one is your CPM. Okay, I'm just writing it down. So you have network analysis, right? It is a graphical plan of all events and activities to be completed in order to reach an end objectives. Okay, you have two types. You have your PERT, which is your, this is called program evaluation and review technique, and you have your CPM, or just a critical path method, right? So what do you mean by PERT? PERT is simply, you're writing everything with an arrow with in the logical sequence of all events that's going to occur. Whereas in CPM, you're concentrating on the longest path of a network. So both, I told you, network analysis is both. You want to estimate what is the time taken for this particular work to be done. So in this, basically you're going to write down all the steps involved in a graphical manner. Okay, so in PERT, under PERT type, you write everything in a logical sequence with arrows, and then you calculate the time. Okay, but for CPM, what you do is you see which is the longest path in the network, out of this network, which is the longest taking path in this network, so that when you estimate the time, that will be the approximate time needed to complete the work. Or in other words, if there is a delay in that critical path, that means the whole thing, your whole work, whole program gets delayed, right? So this is the longer path, and if there is a delay, that means your whole thing is delayed, whole delay, right? Now we have another thing from management only. The management technique which is more promising tool for application in health field is cost effective analysis, cost benefit analysis, cost accounting, input output analysis. So what are we asking? What is this question all about? See, in health field, everything is scarce, right? We have lesser money, we have lesser manpower, everything is scarce. So how do you know to which program I should give more money? I have 1 crore rupee with me and I want to allocate this money to your TB program, or should I give more money to the AIDS program, or should I spend more money on the RCS program? So how do you know this? So I have to know whether the cost, whatever cost I'm giving, is effective or not. If I'm investing on a program, what is the effect? So that is, for that you have certain analysis methods, or you have economic evaluation methods, whereby you can know what is the effectiveness of the cost, what is the output you're getting in terms of money. Okay, so for that you have an input. So for this you have something called an input and you have an output, right? Input is always the cost. For any program you have to spend a cost, right? But when the output is in terms of cost only, then it's called a cost benefit analysis. Okay, but what is the issue with this cost benefit analysis? You think sometimes what happens, you're spending money on a reproductive health program or the mother and child program, MCH program, and what will be the outcome? Outcome will be maybe you decrease the infant mortality rate, or you could bring, because of your program, you could bring the neonatal mortality rate or your maternal mortality rate. So, but how do I assign a cost? How do I assign a cost for this life? This much is infant mortality rate reduces, this much means this is the cost. You can't say like that, right? It's difficult to assign monetary cost to your health benefits. So in such case, you will have to measure the output in terms of effectiveness. Maybe effectiveness, maybe in terms of number of lives saved or things like that. So that type of analysis is your cost effective analysis. Okay. Now you have something which is not given in the option. You have something called cost, where and the output is measured in terms of the quality or quali. This is your cost utility analysis. It's not given in the question. But if the output is measured in terms of quality, it becomes cost utility. Output is also measured in terms of cost, it becomes cost benefit. But output measured in terms of effectiveness is cost effective analysis. And in case of health field, the best option would be your cost effective analysis. Okay. Now we'll move on to the next question. In the management of stores, VED, D stands for. So we are basically talking about something called stock management or inventory management, whereby in a PHC or in a health center, when you are the MO, you will have to, you have to manage the things there, manage the drugs there, the inventories, everything there. So for that, we have certain management techniques. We have techniques called VED, we have techniques called ABC, there are others also. So out of this VED techniques, what does D stands for? VED, V stands for vital, E stands for essential, and D stands for desirable. Okay, these are all stocks management techniques or inventory management. Okay, these are all coming under this topic. So vital, essential, desirable. For example, if I'm telling in terms of drugs, if I have 100 drugs in a pharmacy, or if I want to buy 100 drugs for my health center, 10% of the drugs are considered as vital. That is, without that, I cannot run the pharmacy, which are life-saving drugs. Adrenaline. Every patient should have adrenaline, right? Do you agree with me? So that's a vital drug. So likewise, 10% of the drugs are vital. Then you have something called essential drugs. Essential drugs are which are very essential but not vital. Maybe you can wait for some time. You can you have a time period to go get the drug and come, so you can have a bit of time period. Most of the antibiotics can be an example of essential drugs. Then you have something called desirable. 40% of the drugs will be essential and 50% of the drugs are desirable. Desirable, it's okay, even if it's not there, it's fine. Maybe some of the dermatological paraffin, liquid paraffin for dry skin, that is not an essential thing, okay, but it's needed, so it's just a desirable one, right? So like that, I just told in terms of drugs, like that, anything you can divide as VED, vital, essential, and desirable. So here the answer is D, desirable. Just like VED, you have something called a VED, it's already written here. Then you have something called a ABC analysis. Just like VED, you have ABC. A being outstandingly important, B is average importance, and C is relatively unimportant. Okay. And others are some others. I'll just write down the names here. You have something called HML analysis, where H is, it's based on the cost. H is your high cost, M is your medium cost, and L is your low cost. Okay, that is HML analysis. Then you have, based on the availability, you have SDE, that is scarce, difficult, and easy. This is scarce availability, then difficult availability, and easy to get. So these are other examples. Then you have FSN, which is your fast, slow, and not moving. Similarly, you have SOS. SOS, season in and sorry, on season and off season items. Okay. Now, moving to the next question here. The box C in the following image represents what? Box C represents, what is this? What are we talking about here? It is the models of your behavioral change, models of behavioral change communication. See, there are for maybe for any NC, you take a hypertension or diabetes, what is one management method? You tell the people to change the behavior, right? We tell them to increase the physical activity, decreases the food. There are many behavioral change things involved in treating a patient or while advising a patient, or maybe for preventive aspect also. But it's very difficult to bring about a change in behavior. If I ask you to exercise from tomorrow every day 1 hour, will you do it? It's difficult, right? So behavioral change communication, to study that, we have certain models for studying this behavioral change. So mainly you have to study two models. One is the health belief model and second is the trans theoretical model. The question they have given here is the health belief model. Okay. And the C stands for this person, this, space is your health motivation. So health belief model says that for a behavior to result in action, if you want an action or if you want a change in behavior, either that can be due to these things, that is perceived susceptibility or severity. That is, if the patient realizes, okay, there's somebody who's obese, and because of the susceptibility or severity, if the person realizes that this obesity is not good for my health, I may end up with cardiac problems and I may die, something like that, because of that fear, he'll do the exercise. So that is one way. Second is health motivation. When he is actually motivated, again, can lead to action. Then others is perceived benefits and perceived barriers are there. That's, if I do this exercise, what are the benefits I'll get, or what are the barriers in doing this? So all these are incorporated in your health belief model. So here it is health motivation. So just like the health belief model, this was a INI-CET question. So another model which you should know is this one, the cyclical model, the trans theoretical model. Under trans theoretical model, we have different stages. You see, there's a stage of pre-contemplation, contemplation, preparation, action, maintenance, and relapse. Okay, what is this pre-contemplation? Is no action. Yeah, I'm not going to do if I am overweight, I want to reduce my weight. If I'm in the pre-contemplation phase, that means I'm not going to do anything. I'm not going to do any exercise for the coming 6 months. Okay, that is pre-contemplation. Contemplation is maybe, yeah, I agree that I am overweight. I have to do some exercise, and in the coming 6 months, I am changing my that I might do in coming 6 months. That is contemplation. Preparation is I'm determined that I'll take the action in the next 30 days. Okay, I'm determined I'm going to do. That's a preparation phase. Action is actually I'm going and doing. I'm going to the gym. I'm doing the exercise. That's the action. Maintenance again simple. You have to maintain it. And relapse or lapses. If I stop doing it, it's a relapse. So these changes keep on happening in any behavioral change, and we have to know when you're advising the behavioral change to a person, you should know where the person is actually, because accordingly only you can give the intervention. Okay, so this is a trans theoretical model. Now we are moving to the next question. All of the following are approaches to health education, except you have service approach, regulatory approach, health education approach, and mass media. The answer is mass media. Okay. All the three others are approaches to health education. So approaches to health education means how can you bring about this behavioral change, or how can you give health education. One approach is regulatory approach. Regulatory approach means you are regulating or by means of laws or legislations. Helmet. You're supposed to wear helmet while driving. If you don't wear helmet, police will catch you or you'll be caught on the camera. You'll have to pay fine. So that is a legislation. Because of that fear, because you'll be caught by the police or you have to pay the fine, you are wearing the helmet and going out, right? So that is an example of a regulatory approach whereby you're enforcing some law or legislation or punishment because of the fear the patient is doing it. But what is the disadvantage here? See, if there is a loophole, you don't do it. If there is no camera, that camera is not working on that particular area, you're going on the road, you'll avoid the helmet, right? Because there is no motivation from your side. So that's regulatory approach. Second is service approaches at doorstep. Sometimes some things you're providing at the doorstep. For example, your ASHA worker is supposed to go house to house and provide family planning, contraceptives. So you go there, and if you're providing the maybe the condom or any OCP to that female at the house, that is a service approach. Again, the issue with this is if the person does not feel that this is necessary, she might not use it, right? If she's not confident, if you're giving that albendazole, you go and give albendazole to children, right, to prevent deworming, I mean for deworming. So if the mother feels that, no, this is not needed, I don't want albendazole, it's not good, you will give the tablet and come back, but you don't know whether the person is actually taking it or not, right? So that is one issue with the service approach. You're providing a doorsteps, but you don't know whether the person actually needs it or not. It's not based on the need. Next is a health education approach where you're actually you are motivating the person, you're telling them, you're teaching them everything. See, this is how you have to do it. And you're actually trying to bring about that motivation in that person so that he himself realizes and he does it. Okay. So these are all approaches of health education. Now moving on to the so that was the end of this segment. Now we'll move on to the contagion corner or some MCQs about infectious diseases. Okay. So infectious diseases, there are many questions that can come from infectious diseases or communicable diseases, but due to time limitation, I'm not able to cover everything. We'll just discuss some MCQs and finish it off. But you should know the incubation periods of all the diseases. Then you should be knowing the period of communicability, because I'm not discussing these in this question, that's why I'm writing it here. You should learn the period of communicability. You should know the treatment, and especially if there is a chemoprophylaxis, you should know it, and vaccines. What is the measles vaccine, when it's given, it's a live killed or whatever, or all other vaccine things you should know. And if there is something particular for a particular disease, something important, all those points should be known to you. Okay, just revise the previous year questions from this communicable and non-communicable diseases so that you get a grasp of the questions coming. Okay, so first question from this portion: which is the following statement about incubation period is not correct? You have different points regarding incubation period. The answer here is, so I'm reading out the options. First option, it's a time interval between invasion of an infectious agent and appearance of the first sign or symptoms. Is it correct or wrong? It is correct, right? Incubation period means the time between invasion of the organisms, the time the organisms enters your body to the time you develop the first sign or symptom. That is what we mean by incubation period, right? During IP, the infectious agent undergoes multiplication in the OCS. The agent is inside your body, it can undergo multiplication. Factors such as infective dose of pathogens and portal of entry determines in IPS. Incubation period can vary depending on the portal of entry. For example, rabies. Rabies, if you get a bite of a rabbit dog in the leg, it takes some time to reach the brain, right? So maybe sometimes the incubation period may be long, but instead if you get a bite somewhere near your face or the head area or your hands and all, it takes lesser time to reach your brain. So incubation period might be lesser when you get a bite in the face or head region compared to when you get a bite in the lower extremities. Okay. Last option, incubation infectious diseases are not communicable during IP. No, it is communicable. This is the answer here. Okay. And IP even during the IP, it is communicable. But the thing is, we usually fail to detect that this person is in the incubation period. So by the time we detect him as a case, he would have spread the infection. That's what is wrong in this. So you tell me what is incubation period. We have already discussed, right? Now tell me what is median incubation period. Okay, median incubation period is the time required for 50% of the cases to occur after exposure. Especially when you draw the epidemic curve and all, no? If this is the curve, this is the time for 50% of the cases to appear. No, this time is the median incubation period. Okay. Second one, tell me what is serial interval. And then you have period of communicability and latent period. So what is serial interval? Serial interval is the gap in onset between your primary case and secondary case. You have a primary case, you have a secondary case, right? So the gap between the period of onset of this primary case and the secondary case, that is the serial interval. Period of communicability is the time period when this person, if I am infectious, the time when I am communicable or the time when I can spread the infection to others. That is the period of communicability. Latent period is almost similar to incubation period, but usually latent period we say in terms of your NCDs. In NCDs, disease initiation to the time of disease detection, that is your latent period. And what is this is completely different. What is lead time? Lead time is not in this chapter. This is a added in here. Okay, it's advantage gained by screening. You screen a person, you find the disease earlier, so there's a better chance for early diagnosis, early interventions. So that extra advantage or that extra time that person gains is the lead time. Okay, so I hope this is clear to you. Now we are moving on to the next question. It's about your AFP surveillance. So under AFP surveillance, what is AFP? Acute flaccid paralysis surveillance, right? Follow-up examination is done after. For residual paralysis, when do you check? In the AFP paralysis surveillance, it's done after your, any answers? So it's done after 60 days of onset of paralysis. Okay. So what is this AFP? Some few points. We don't have time to discuss everything. So I'm just writing the most important points under AFP surveillance. You know it, right? Acute flaccid paralysis, if a case is reported, an AFP surveillance should take place. So whom do you do this? In kids less than 15 years old. Second one, when do you start? If suppose this, there is a case of acute flaccid paralysis report, when do you start? You have to start the investigation within 2 days, within 48 hours. Okay. And then what is this? What should you do? You have to collect 2 stool samples from the child who's having this paralysis, acute flaccid paralysis, within 2 weeks. Okay, investigations should start within 2 days, but you have to collect the stool sample within 2 weeks. And between the two samples, what should be the time interval? They should be 24 hours apart. The gap should be maintained. Okay. Third step, once you collect the stool sample, you have to send it to laboratory, right? By maintaining at a 2 to 8 degrees Celsius. That is this is called reverse cold chain. This temperature should be maintained. Okay, why? Within 72 hours of collection. Within 72 hours of collection, your sample, the stool sample should reach the place of testing or should reach the laboratory. Okay. Fourth one is what you have been asked here, residual paralysis check. When? After 60 days of AFP reporting. It's not after 60 days of starting your investigation. It's after 60 days of AFP reporting. And how much should be the stool sample? It should be approximately thumb size or more than 8 grams. That's the size you say. So that is about your AFP. And difference between OPV and IP, I hope all of you know. OPV is oral polio vaccine. IPV is injectable polio vaccine. OPV is your oral. It's a live vaccine. IPV is injectable, killed. This is your sac. And OPV is your sabin. Okay. Which one is used in epidemics? In case of epidemics, you have to go for OPV. Why? Because it provides local immunity plus humoral immunity. Okay. But your IPV is not the best option in case of epidemics because it provides only humoral immunity. Okay. Now we'll move on to the next question. So this is about chickenpox. So true about chickenpox are all except caused by herpes simplex type 3. The secondary attack rate is 90%. Superficial rash, single stage of rash is seen. Caused by herpes simplex virus type T. Yes, correct. Secondary attack rate is 90%. Yes, it's correct. Superficial rash. Yes. Single stage of rash is seen. No, that is wrong. Okay. What is specific? What is so special about your chickenpox rash? Chickenpox rash shows something called pleomorphism. Okay, if you see pleomorphism, that's a chickenpox rash. You see here, there's a chickenpox rash here. So you can see different stages of the rash, right? Some are, macules here. Some are here, I can see pustule. It is pus filled, right? Sometimes you get, vesicles. Okay, this is looking like a vesicle. Vesicle is fluid filled. Sometimes it would have crusted. Here you have some crusted lesions, it's a scab. So you have different stages of rash you see at the same point of time in the same patient. That is called pleomorphism. That's the characteristic feature of your chickenpox rash. Okay. Now, why I put this picture here? The chickenpox rash is also known as your dewdrop in rose petal. See, there are people who can appreciate beauty in everything, right? So somebody like that said that in chickenpox rash looks like a dewdrop on a rose petal. The dewdrop mainly telling about the vesicle, the fluid filled vesicle, the rose petal because the skin is usually red erythematous. So dewdrop in rose petal appearance is seen in your chickenpox. Just like in chickenpox, just asking, it's not related to chickenpox. Coplic spot, characteristics of measles, right? Then you have something called the blueberry muffin rash. Where do you see this? This is seen in rubella. Okay. Now we'll move on to the next question. So which of the following is least common complication of measles? So the least common complication of measles is SSP. It's subacute sclerosing panencephalitis. But even though it's the least common, it's a very dangerous, deadly complication. It's also known as Dawson's encephalitis. This is an encephalitis or a neurological manifestation. Usually appears after 5 to 10 years of you get the measles infection. Okay, all others are complications of measles. Your diarrhea, pneumonia, otitis media, all are complications of measles. Most common complication in children. Complication in children is otitis media. Okay, most common complication in general, most common complication of measles in general is your pneumonia. Just asking one more question here, which is the most common complication of mumps? Of mumps is aseptic meningitis. Okay, most common complication of mumps. Then you have you heard of something called catch up, keep up, catch up, follow up campaign? It's the other way around. It's catch up, keep up, follow up campaign. This campaign is for which vaccine? This is for your measles vaccine, your MR vaccine. Okay. Okay. So now before going on to the next question, we'll just take a short break. Let's move on to the next question. The question is, all of the following statements are true about congenital rubella except you have it is diagnosed when the infant has IgM antibodies at birth. It is diagnosed when IgG antibodies persist for more than 6 months. Most common congenital defects are deafness, cardiac malformation, cataract. Infection after 16 weeks of gestation results in major congenital defects. Okay, so your question is about congenital rubella. Actually, the options are actually very easy. Even if you don't know much, you'll be able to answer it, right? See, you all of you know that for any congenital infection or any congenital anomaly, usually the most of the most effects occur during the first trimester of pregnancy, right? Because first trimester or the first 3 months is the time of organogenesis. So if the mother is having any infection during the first 3 months of pregnancy, then there's a more chance for the child to have a congenital anomaly or child to be born with a congenital anomaly. This holds true in case of all your infections or your X exposure, everything. Okay. So here the option they've given, option D, you see the option D, infection after 16 weeks of gestation results in major congenital defects. No, infection before 16 weeks results in major congenital defects. Okay, now, so that is the answer here. Now we'll just see the other options. Okay, so congenital rubella syndrome. What is the classical triad of congenital rubella syndrome? First is causes if the mother is having rubella during the first 3 months of the pregnancy. And the triad, child will be born with CDC. C is congenital cataract, cardiac defect and deafness. And out of these three, cardiac defect, deafness and cataract, which is the most characteristic one, was most commonly seen one is deafness, because cardiac defect and cataract usually seen if the mother gets rubella, around the before the first trimester. But the defect, the deafness can be seen even after that. That is around 16 to 18 weeks also. If the mother gets rubella during that time also, there's a chance that the child will have deafness. Okay, and so that is option is correct. Then you have something about the diagnosis. See option A and B. So basically, you have two types of antibodies, right? You have IgG and IgM. IgM is a bigger molecule, okay? M for mega or big. So IgM molecule cannot cross the placenta. So there's a mother, there's a baby. So the IgM cannot cross the placenta. So if you see IgM antibody in the baby, that means it is not from the mother, it's from the baby alone. So the child has rubella or child has acquired rubella, and hence the child's body is producing the IgM. So if you see IgM antibodies at birth in a baby, that means the child is infected with rubella, okay? What about IgG? IgG being a smaller molecule, it can even be transferred from the mother to the child. So the mother's IgG may be transmitted through the placenta to the child. So when you detect IgG in the first 6 months of pregnancy, you can't be sure whether it's actually from the mother or if it's by the child's body. But if you see IgG persisting for more than 6 months, then it's diagnostic of rubella, because if it's from the mother, it doesn't persist for more than 6 months, okay? It will start weaning off. So your option D is correct about congenital rubella. Now, what else? Now we have a question on diphtheria, okay? Diphtheria, the options are true about diphtheria are all except carriers are more common source of infection than cases. It is true. Carriers are more common source of infection. Incubation is 2 to 6 days, correct. Diphtheria is endemic disease in India, correct. But option C is the wrong one. 25 LF. Sorry. Okay, 25 LF of diphtheria toxoid are present per ml in DPT vaccine. No, it is present per dose. This is wrong, okay? Small mistake, but again, this is the wrong answer. So, 25 limits of flocculation are present per dose of DPT, okay? But what about DT? If it's DT, it is only 2, okay? 2 in case of DT and DPT, it is 25. But this option C is correct because it's not per ml, it should be per dose. So, that is the one answer here. Now, what do you see here in the diagram? You see something known as pseudomembrane. This is your characteristic feature of diphtheria. You get pseudomembrane, then what else? You get a bull neck deformity because of this membrane, because of the whole edema. The child, usually it's a child patient you get. So there's a bull neck deformity. Okay. Then tell me your name test for diphtheria. That is your Schick test. Schick test. Just like your tuberculin test, this is a hypersensitivity test. Schick test is for pneumonia. Diphtheria. If I say Schick test is positive, that means the person is susceptible. to diphtheria. If the Schick test is negative, that means the person is immune to diphtheria. Okay. So what something similar to Schick test? Okay, don't get it confused with your shake test. What is shake test? Shake test is in case of vaccines. Just like your vaccine vial monitor, whether the vaccine due to freezing, whether the vaccine has gone wrong, whether the vaccine is not working properly, it has got destroyed or not. There you do the shake test. Now here, diphtheria we are talking about shake test. Okay. Next question is about meningococcal meningitis. So the following statements about meningococcal meningitis are true except source of infection is mainly clinical cases. The disease is more common in dry and cold months of the year. Chemoprophylaxis of close contacts of cases is recommended. Vaccine not effective in children below 2 years of age. See, the source of infection in cases of meningococcal meningitis, just like in diphtheria, the most common source of infection is not cases, it is the carriers. So option A is wrong because source of infection is not mainly the cases, it is mainly the carriers. Okay. Rest of the options are correct. And you see option C here, chemoprophylaxis of close contacts of cases is recommended. Yes, it is recommended. But what is the drug of choice for chemoprophylaxis? So when I say meningococcal meningitis, people usually have a tendency to answer it as doxycycline, things like that. But no, this is actually something bigger. You need rifampicin. Rifampicin is the drug of choice for chemoprophylaxis in case of your meningococcal meningitis. Okay. Okay, now we'll move on to the next question. So, which of the following are seen in acute hepatitis B? So, this is about the serum markers of hepatitis B. You would have already studied this in medicine, microbiology, everywhere. So, which is the acute marker of which is seen in acute hepatitis B? Obviously, it is HPS-AG, right? So, this is a table just showing you the different markers in different situations. First one, when the person is susceptible to HPV infection, has not had HPV infection yet, hepatitis B infection yet, and is not vaccinated. So everything is negative. There's no HPS, no anti-HPS, nothing. Everything is negative. Okay. Second one, when there is an acute hepatitis B, the person is currently having hepatitis B, you get HPS-AG. HPS-AG is a surface antigen positive. Then you have HPV DNA positive. HPC-AG is the core antigen that is also positive. HBCAG, IgM, IgG, both can be positive. Then you have HPEAG, that is also positive. That's an envelope antigen. But you don't get any antibody. Anti-HPS or anti-HPC won't be there in an acute case, right? But if it's a chronic case, what happens is your HPCAG and HPV DNA, HPCAG, everything will be positive. But you will also get, there's a chance that you get the antibody for HPE. Okay. But if somebody is immune to HPV, immune can be because of two reasons. One thing is there was a past infection, got cured. Second one is you're vaccinated. If it was a past infection or wherever, whether you're immune, whether it's a past infection or because of the vaccination, if you're immune, you will have serum anti-HPS titer, right? When you want to take, when you get a prick or not, especially in college and all, when you get a prick from a hepatitis B person, first thing you do is you check the serum HPS titer and you see if it's adequate or not. More than 10 is adequate. So that means if you're immune to HPV, you have a serum HPS titer. So that will be present in immune. But if it's due to vaccinated, you have only the serum HPS titer. But if it's due to a past infection, along with serum HPS titer, you'll also get this HBCAG IgG positive. Okay. So just study this table so that you know what is the serological differences in different criteria in different situation in case of your hepatitis B. Now moving on to the next question. What is the drug of choice for chemoprophylaxis of cholera? So cholera, drug of choice for chemoprophylaxis, the answer is tetracycline. Okay, tetracycline is the drug of choice for chemoprophylaxis of cholera. So for cholera, for treatment, the drug of choice is doxycycline. Okay, but for chemoprophylaxis, the drug of choice is tetracycline. Don't confuse it. But so for treatment doxycycline, prophylaxis tetracycline. But you cannot give doxycycline in a pregnant woman or maybe in children you can't give doxy. In that case you can, instead of doxy you have to give your azithromycin. Okay. Otherwise in general doxy is the treatment of choice and tetra is the chemoprophylaxis drug of choice. Okay. So other chemoprophylaxis drugs, one we already told, meningococcal meningitis, you give rifampicin. Then where else can you give rifampicin and prophylaxis? You give it in case of leprosy, right? Leprosy, close contacts, you give rifampicin. Then what about plague? Plague, you give tetracycline, okay? For tetracycline is the chemoprophylaxis of choice in plague also. Okay. For diphtheria chemoprophylaxis, we have not discussed it there, so I'm just saying it here. The drug of choice is erythromycin. Chemoprophylaxis, erythromycin, plus you have to give first dose of vaccine. This is the chemoprophylaxis in case of diphtheria contacts. Okay. Now, in cholera, one more point that you should know is the types of carriers in cholera. So, cholera, types of carriers. 4 types. First one is your preclinical carrier, or preclinical is nothing but somebody who's in this incubatory period, that is the clinical signs and symptoms have not appeared. He's just in the preclinical phase, but he's definitely going to develop clinical signs and symptoms. It's going to be a patient. Okay, so it's a potential patient. Okay. Then the second one is convalescent carrier. This is a person who has not a cholera patient, but he did not receive proper antibiotics. Not received effective antibiotics. Maybe he stopped the antibiotics after 2-3 days, or he did not get the correct antibiotic. So he becomes a convalescent carrier where he doesn't have much of signs and symptoms, but again he can spread. So convalescent carrier. Then you have healthy contact. Healthy contact carrier is, he doesn't have any signs and symptoms, but he is a carrier. What is happening is this is actually due to subclinical infection. Patient doesn't have any signs and symptoms. He's having only subclinical infection, but he can spread the disease. Okay. Then you have somebody who's a chronic carrier. Chronic carrier is when your gallbladder gets infected. Okay. Then you become a chronic carrier, and the time period usually up to 10 years. Somebody can be a chronic carrier. Preclinical is usually only for 1 to 5 days. By that time you develop the disease and you become a patient. Convalescent carrier for 2 to 3 weeks. And healthy contact is less than usually 10 days. Okay, these are the types of carriers in cholera. Now, next one, Chandler index for hookworm. When is it a health problem? Okay, so first question, Chandler's index is used where? It's used in case of hookworm, and what are the cutoffs? So, when is it a health problem? It is when it's more than 300. Okay, so what is Chandler's index? We have a Chandler here. So, Chandler's index is number of hookworm eggs per gram of feces for an entire community. Okay, this is your Chandler's index. Remember, Chandler with hookworm. Okay, now what are the cutoffs? If it's more than 300, it's a public health problem. More than actually 250 to 300, this is actually a minor public health problem. Okay, minor public health problem. If it's less than 200, it's not significant. It's okay. Now, next question. Pre-exposure prophylaxis for rabies is given on. Pre-exposure we are giving on 0728. Okay, how do you remember this? So, for rabies, you have post-exposure prophylaxis, pre-exposure prophylaxis, re-exposure prophylaxis. Okay, so first we'll start with post-exposure. Somebody got a dog bite. So, he's coming. After the bite, you come. That's a post-exposure prophylaxis. So, under post-exposure prophylaxis, you have 2 regimens, right? We have the SN regimen and you have the modified Thai Red Cross regimen. Okay. So, SN regimen, you have 5 days you have to give the vaccine. SN, ESSEN, 5 letters. So, 5 days you are giving the vaccine. Which all other days? 0, 3, 7, 14, 28. Okay. So, 5 days you will give the vaccine. Whereas Thai, THA, only 4 letters. So, you are giving it only on 4 days. 0, 3, 7, 28. Okay. That is only 4 days. So, SN and Thai, I hope you know. So, for post-exposure prophylaxis, you have SN regimen and Thai regimen. SN with 5 letters, so you give on 5 days, 0, 3, 7, 14, 28. Thai is 4 letters, you give on 0, 3, 7, 28 bus. Okay. Now, what else is the difference? SN regimen you are giving as IM. You are giving the vaccine as IM dose, 0.5 ml IM, one side. So only on one side. That is usually the delta. Only on one delta you are giving 0.5 ml IM. Whereas for Thai regimen, you are giving 0.1 ml intradermal, two sides. That's both deltoids you are giving. So total of 0.2, here, 0.1 here, so 0.2 ml. Okay. So that is your this thing. Then now the preferred regimen is, we prefer the Thai regimen over the SN regimen, but again you can give both. That's not an issue. So that is your post-exposure prophylaxis regimen. Now we have pre-exposure prophylaxis. Whom do you give pre-exposure prophylaxis? To those who are at risk of developing this rabies, right? Those who are veterinary doctors or those who are handling animals and all that, you give a pre-exposure prophylaxis. Okay. So let me write pre-exposure. So this first one we have post-exposure. Second one you have pre-exposure prophylaxis. So pre-exposure again you have three letters, PRE, right? Pre. So you give on 3 days. It is your 0, 7 and 21 or 28, any one of the days. Here you give, usually it is one site, IM or ID. You can give it only on one side. Okay. Similarly, you have something called re-exposure. When do you give re-exposure? That is, the person already completed the schedule of the vaccine, but unfortunately the next day again he got a dog bite. Not the next day, next time he got a dog bite again in spite of taking all the vaccines. So this time you have to go for a re-exposure. So since he has already completed the dose, we just have to give on 2 days. That is only on 0 and 3. Or you can remember, re has only 2 letters, right? RE. So it is 0 and 3. Okay. So pre-exposure, you have 3 days, 0, 7, 21 or 28. Similarly, for re-exposure, you have only RE, 2 words, 2 letters, so it's only on 0 and 3. So all these cases you are giving in one side. Okay, the vaccine is given only on one side, IM or ID, except for your Thai Red Cross regimen, where you are giving 0.1 ml ID on both sides. Rest everywhere it's only on one side. Okay. Now, re-exposure question, one more question is, up to after which time should you take this re-exposure prophylaxis? So, somebody got a dog bite, you got the second dog bite within 3 months of completing your previous schedule, vaccine schedule. That means you don't have to do anything, no need. If it's crossed 3 months, if you got, unfortunately you got the dog bite the next day after completing 3 months, then you will have to take the vaccine. That is, you have to go for a re-exposure. If it's within 3 months, it's fine, you don't have to take anything. Okay. Plus, always remember, in case of re-exposure prophylaxis, you do not give immunoglobulins. Okay, you do not give immunoglobulins in case of your re-exposure prophylaxis. Okay, so I hope your rabies vaccine schedule is clear to you. Now let's move on to the next question. All are true about yellow fever vaccine except incubation period 3 to 6 days is correct. Urban form is controlled by 17 days. So 17 days the vaccine. Validity of international certificate for vaccination lasts up to 10 years is wrong. Yes, it was thought to be, it was initially, we had this certificate valid only for 10 years, but not recently, but it has been updated by Ministry of Health and Family Welfare. Now, the vaccine certificate is valid lifelong. Okay, it's not for 10 years or anything. Once you take the vaccination, you are protected for lifelong. Okay, so that is what falls about your yellow fever vaccine. Next question. Epidemic typhus causes and vector. So what is the cause and vector of epidemic typhus? So how do you study the vectors of epidemic typhus? You have a code here. I have a mnemonic here. Again, many people might already be knowing this. The mnemonic is let fen try PSM. Okay. Why should you have all the trouble? Let fen also try PSM, right? So fen is the name of the guy, okay, which is made up for this mnemonic. So let fen try PSM is the mnemonic. And how I'm going to expand it, C L E T F P R Y and PSM P PSM. So remember, let fen try PSM. Okay. So here L stands for the first thing for the let, L stands for louse. Louse, and E and T is for epidemic typhus. Okay, epidemic typhus. So let is for louse, epidemic and typhus. So epidemic typhus is caused by louse. Okay, so F flea. F is for flea, AEN, endemic typhus. Okay, endemic typhus. So the causative vector for endemic typhus is flea. Then we are going to about to try. T is your tick. We have already told, right, which was whether it is hard tick or soft tick. Under soft tick you have Ranbir Kapoor and RKQ. So soft tick you have Rocky Mountains for Rocky fever, and your KFT and Q fever, right? So tick you have your Rocky Mountain fever. Last one PSM. Here the vector is here. Okay, it's mite. And for P you have pox, or you can say rickettsial pox. And S is for scrub typhus. Okay, so now you see here epidemic typhus and vector. Epidemic typhus I can see here. So epidemic typhus, the vector is let, louse. So here I have only one option which is having louse. So luckily my answer is A, Rickettsia prowazekii causing louse, or Rickettsia prowazekii and louse is the cause and vector for epidemic typhus. Okay, so we'll just write down the vectors also, the causative agent also separately here. So Coxiella causes Q fever. Coxiella Q, Cox Q. Okay. Then Rickettsia prowazekii, the one which you have here, that is your epidemic typhus. Okay. Then you have Rickettsia typhi, that is your endemic typhus. Okay. Then you have something called Orientia Tsutsugamushi. Different name, difficult name. TS Tsutsuga, that is your ST or scrub typhus. Okay. So these are some of the causative agents for your typhus. Now, next question. Commonest mode of transmission of AIDS in India. What is the in descending order? Okay, this is the answer is C. Most common mode of transmission is heterosexual, followed by transplacental, then homosexual. Okay, that is the descending order of mode of transmission of AIDS. Treatment of AIDS we've already discussed. TLD is the adult regimen. Then we are moving on to the next question here. So life cycle of which of the following organism is depicted in the diagram? So you see infected mosquito, you see a non-human primate, then finally you see this Aedes, the mosquito here is Aedes, right? Aedes, and then through the mosquito bite, the human being is getting it, and then he spreads it again through mosquito bites. And the most important thing you see here, see if a pregnant woman gets this disease, it becomes a, the child, her baby will have a congenital anomaly, mainly usually in terms of microcephaly, small head and things like that. So this typically shows the life cycle of Zika. Okay, this is the Zika virus that is shown here. I'm putting this question here because see the newer agents like the Zika, Nipah, or anything else like the JE, all these things, they can give you the life cycle, they can give you the picture of the life cycle, and then they can ask you to identify the virus. Previously, there was a question where Nipah virus life cycle was shown and it was asked. So, just get familiarized with all the life cycles. Okay, just have a quick review of all the life cycles images. Okay. Now we are moving on to the last segment of today's PSM final dash, which is a miscellaneous mix, just adding all the other miscellaneous questions which we have not discussed yet. Okay. First one, most universally accepted indicator of health status of whole population and the socioeconomic condition among the following is. So, which is the most universally accepted indicator, or which is the indicator of health status of whole population and the socioeconomic conditions among the following? You have MMR, IMR, life expectancy and disease notification rates. So here the answer is your IMR, or infant mortality rate. See, infant mortality rate is a very important indicator as far as your health indicators are concerned. It actually reflects the health status of a society. Infant mortality rate, what is that? It is the number of infant deaths per 1,000 live births, right? So how many infants or how many children less than 1 year of age die? So if there is a proper antenatal care, if there's a proper perinatal care and a proper vaccination, everything, you can actually bring down the infant mortality rate. So when there is a healthcare system where there is a proper RCH services, proper immunization services, and everything is accessible to the population, in such a community or in such a population, you get a lesser infant mortality rate. Or in other words, you can say IMR is indirectly an indicator showing the health status of the community, also the socioeconomic conditions of the people there. So here the answer is IMR. But if you get a question which is asking the socioeconomic conditions, under 5 mortality rate or the child mortality rate is supposed to be superior than IMR as a proxy indicator of socioeconomic conditions as per your UNICEF. Okay, but in this you don't have that option. So here the answer is anyway IMR only. And also they have asked the health status. Health status is always IMR. Okay. So also you should know all the indicators. Because of lack of time, I'm not explaining all the indicators. You should know all the RCH indicators and all the other indicators. You should know the formula, what they mean, and also how to calculate the indicators. Okay, they'll give you the values and you'll be asked to calculate the crude birth rate, calculate the maternal mortality ratio. So what is maternal MMR and maternal mortality rate is there, ratio is there, right? So ratio is number of maternal deaths per 1 lakh live births. Okay, that is the ratio. Ratios where the numerator and denominator are not the part. Sex ratio is another example of a ratio where numerator and denominator are not part of each other. So maternal mortality ratio is where number of the maternal deaths by 1 lakh live births. Okay, and rate is, in the rate you say number of maternal deaths divided by number of women in the reproductive age group. So that is the rate and ratio. Now we'll move on to the next question. Which is the best indicator for burden of the disease? You have options: case fatality rate, disability adjusted life years, dependency ratio, and morbidity rate. So which one of the following is the best indicator of burden of the disease? So burden of the disease, the best indicator is your DALY, or what you call as disability adjusted life years. Okay, this is the answer here. Okay, so what is DALY? DALY is disability adjusted life years. It is calculated using the formula YLL plus YLD, where a YLL is the years of life lost. Okay, YLD is the years lived with disability. Okay, so YLL plus YLD will give you the DALY, or in other words, it's a combination of the early death years of life. If somebody was supposed to live in a particular country, if somebody had the normal life expectancy is 80, and this person, because of this particular disease, he dies at 60, so he loses 20 years, right? Suppose he was supposed to live till 80, but he died at 60 because of the disease. So that is the years of life lost, or the years of life lost due to premature death, plus years of life lived in disability. Because of this particular disease, he's having some disability, so that is also taken into account. So that the sum of both these will give you the DALY, and DALY is the best index for burden of the disease. Okay, best index for disease burden. Okay, and you should know there is something called a GBD, or Global Burden of Disease Study, conducted by the Lancet. This is the study where they report the DALYs for each diseases. How much is the DALY for depression? How much is the DALY for your cardiac MI? Things like that are reported in this study. So DALY is the best burden for disease, best indicator for disease burden, because it takes into account not only the mortality but also the disability. Okay, that's about DALY. So see what are the other options you have? You have case fatality rate. What is this case fatality rate? Case fatality rate, write it down. The case fatality rate is the number of deaths, fatality is deaths, right, divided by out of the total number of cases into 100. This gives you the case fatality rate. So if for in the case of cholera, there are 25 people with cholera, 25 cases. Out of the 25 cases, there are 5 deaths. So what will be the case fatality rate? It will be 5 by 25 into 100. Okay, so case fatality rate is also indicator, or it's a proxy for the virulence of the organism. Also it shows the killing power. It's a fatality rate, killing power of the disease. All these are shown by your case fatality rate. For example, rabies has a 100% case fatality rate. You get rabies, it's almost 100% that you are going to die. So it shows the killing power or it shows the virulence of the organism. This is all your case fatality rate. Okay. Then dependency ratio we have already discussed in your population, right? Dependency ratio is the number of dependent people divided by the number of people in the productive age group or the working age group. So that is not here. Okay. So now we are moving on to the next question. What is the causative agent is present, but there is no transmission. What is this known as? You have elimination, control, eradication, endemicity. So when the causative agent is present, but there is no transmission, that is called elimination. Okay. So we'll see what is control, what is elimination, what is eradication. See, what is control? Control is in case of a disease, when you're bringing the disease to such a level that it is not a public health problem anymore, then that is called a disease control. Okay. You don't have any cutoffs, just saying that this disease is not a public health problem anymore. So you're bringing it down to a allowable or a permissible level, then it's called a control. In case of diarrhea, we have diarrhea control programs, right? So that is an example of control. Second one is elimination. Elimination is defined to a particular geographical area. Okay. Suppose I'm eliminating this disease. I say this disease, polio is being eliminated in India, or dengue, not dengue, or any disease is being eliminated in this particular place. That means in that particular geographical area, there is no further transmission of the disease. That doesn't mean that the agent is not there. Agent might be there, but there is no transmission of the disease. That's called elimination. For different diseases, we have certain cutoffs. For example, in leprosy, we say when the case load is less than 1 per 10,000, we say leprosy is eliminated. Yes, leprosy is being eliminated in India at the national level. Okay, so that is elimination. In eradication, it's a global thing. In eradication means you're completely wiping out the organism. You can't just say it to a particular geographical area, it's just wiping out the organism. That is, this organism is not there at all. Best example, we have only one disease that has been eradicated till now, right? Smallpox. Smallpox, we don't have transmission as well as we don't have the organism. Yes, the sample is stored in 2 laboratories, but other than that, in the circulation, we don't have smallpox anymore. Okay. Once eradication is achieved, then you can actually stop all your interventions, but surveillance should go on. Okay. What do you mean by endemicity? Endemicity is constant, constant presence of a disease or in a particular area. I can say common cold is endemic in India, or diphtheria is endemic in India. That's always there's a constant presence of that disease in that particular area. But when it increases from the normal limit, what is seen normally, that is endemic. If it increases more than what is seen normally, then it becomes an epidemic. Okay. Some cases, even one case is considered as an epidemic. For example, smallpox, I told smallpox is eradicated. So what is the normal presence of smallpox? 0. So even if one case comes, it is more than the normal, right? So in that case, that becomes an epidemic. Okay. This is what you mean by endemic, epidemic, control, elimination, and eradication. Now we'll move on to the next question. So, in a population to prevent coronary artery disease, changing harmful lifestyles by education is referred to as. So, what you're going to prevent? You want to prevent coronary artery disease. So, you're going to prevent the disease, right? And what is already there, harmful lifestyle or the risk factor is present in this case. But disease has not occurred. So, you want to prevent, you have to modify the risk factor so that you can prevent the disease. This belongs to which level of prevention? It is primary prevention, right? So, what are the levels of prevention? Again, very important. Study all the examples for levels of preventions. You have primordial level of prevention, primordial, then you have primary, then you have secondary, and you have tertiary levels of prevention, right? So, primordial level of prevention, it's kind of the ideal or the purest form of prevention, where you go and do some intervention in a population where there is no risk factor, or the risk factor that you're going to study has not appeared yet, or you're going to prevent the risk factor, appearance of the risk factor. That is your primordial level of prevention. Where can you do it? You can do it in population where there is no risk factor, right? For example, in newborn children, or in children who are about to be weaned. You're going to a cohort of parents whose children are maybe less than 6 months of age, and you tell the parents that, see, once you start giving the child food, don't give high salt content food. You reduce the amount of salt to this much level so that the child is not going to develop hypertension in future. So salt intake, high salt intake is a risk factor for hypertension. So in a cohort where where this risk factor is not still present, So there, if I go and do an intervention and prevent the occurrence of risk factor, that's a primordial prevention. Okay. So second one is the primary prevention. Here the risk factor is already there. Risk factor is present, but you want to prevent what? You want to prevent the occurrence of disease. Just like the example given in this question, this factor, harmful lifestyle, is already there. I'm obese, I have the harmful lifestyle, everything is there, but I have not developed heart disease yet. So if I modify my risk factor now, I can prevent the disease occurrence. That is the primary prevention. Under primary prevention, what are the modes of intervention you have? Specific protection is one mode. Okay. Under specific protection, what do you have? Specific protection, you have something specific. So that's all the vaccines. All the vaccines are example of a specific protection. That is something specific you have. Okay. Then secondary level of prevention. Secondary level of prevention, here what is happening is you have the disease. Disease is also, disease is already occurred or disease is there, but you are going to prevent the further progression of the disease, prevent progression. Or what you want to do is you are going to find out early diagnosis and treatment. If I diagnose the disease earlier, disease is there. I cannot prevent the occurrence of disease, but I can diagnose it early and I can give them adequate treatment early so that I can prevent the progression. I don't want it to progress further. That is your secondary prevention. Okay. Screening for a disease is an example. Screening, in what you do in screening, you are actually screening for a disease in an apparently normal population so that you can catch hold of the disease people early and you give the proper intervention so that the disease doesn't progress at a secondary level of prevention. Tertiary level of prevention is done when your disease is already progressed. Tertiary level is when the disease is already progressed. Here you just you're giving what? Rehabilitation. Okay, you don't want the disease so that you can actually improve the quality of life of the person. The disease is already progressed, but at least whatever is left, you make that the life, whatever is left, you try to improve the quality of the life, or you try to increase the functionality of the person. The rehabilitation part comes in your tertiary prevention. Somebody had a stroke, cannot walk, but now you're providing physiotherapy and other methods whereby he's able to walk. So that is an example of a tertiary prevention. Okay, so you should know all the levels of prevention and examples also. Now I'll just show some diagrams. What is this? What's the first one showing? You have a whole community with hypertensive subjects. Among the hypertensive subjects, only half have diagnosed hypertension. Among those half who have been diagnosed, only half have been taking treatment. And among those who are treatment, only half are adequately treated or half have a controlled status. What is this? We are talking about the rule of halves. Okay, this is your rule of halves, which we talk in terms of hypertension. Just like that, what is this? This is your tracking phenomenon. Again, in hypertension. What is tracking phenomenon? See, if we track the blood pressure of people over time, if you see, you're tracking somebody's BP from their childhood or pediatric age group from the adolescence, you can see that those who had a high blood pressure in the adolescent period, when you track over time, it was found that they have a tendency to have high BP in their adulthood also. So this phenomenon is called tracking of blood pressure. Okay. Showing this because I can just show you this diagram and show us what this means. It's a tracking phenomenon or seen in blood pressure monitoring. Here, this is your rule of halves. What is this? Very easy, right? This is your iceberg phenomenon. Iceberg phenomenon means half of only what you see is only the tip of the iceberg. In case of many diseases, especially in case of diabetes, hypertension also, the detected cases or what you see or whom you see as hypertensive patients is only the tip. You only see a very small portion. Many of them remain undetected, undiagnosed, or subclinical cases are there. So those who are in the, below the water, below the portion or the submerged portion has the higher chunk. So the tip of the iceberg or what is visible, this is the visible cases which the clinician sees, and as epidemiologists, we are more concerned with the submerged portion, which is the bigger portion. Okay. And what is this water? Water surrounding is a healthy population. So what is seen above is the visible cases. What is seen below is the invisible cases. It can be carriers, symptomatic, subclinical, everything. So this line is the demarcation between the visible cases and the invisible cases. And where do you apply screening? You screen for the disease here in the invisible cases so that you can find the diseases, right? In the visible places, you apply not screening test, you go for diagnostic test. Okay, so that is about the iceberg phenomenon. And tell me a disease that doesn't show iceberg phenomenon. Measles and your rabies. There is no iceberg phenomenon because the patient once they get the disease, there is a evident disease that is showing. Okay, there is no subclinical phase like that. Next question is from your occupational health. Which of the following pneumoconiosis is caused by Micropolyspora fini? So this is a causative agent for your farmer's lung. Okay. So what are the pneumoconiosis? From occupational health, you should know pneumoconiosis, also called dust diseases, when the particle size is between 0.5 to 5 micron. So these smaller particles, when they enter into your lung, it causes issues and you end up having pneumoconiosis. There are different types of pneumoconiosis. What are the types you know of? Under pneumoconiosis, you have silicosis occurring due to inhalation of silica dust. Then you have anthracosis due to inhalation of coal particles, coal dust. Then what else you have? You have bagasosis. Bagasosis G is for sugarcane. Okay, sugarcane dust, you have bagasosis. Then you have byssinosis. This is in cotton industries. Okay, cotton fiber. Then you have farmer's lung due to inhalation of moldy hay. Okay, you missed out something. Yes. Then you have what your asbestosis due to inhalation of asbestos fibers. Anthracosis is due to coal. Silicosis is again silica. Okay. So most of the things it's there in the name: silicosis, anthracosis, asbestosis. What you get confused is bagasosis, G4G, sugarcane. Okay, byssinosis is the other counterpart, that's for cotton fiber. Then you have farmers like moldy hay. So these are the types of pneumoconiosis which you should know. So under each pneumoconiosis, I'll just show some striking things. So this one is, what is this? This lungs is showing a snowstorm appearance. Snowstorm appearance is seen in which of the pneumoconiosis? Okay, this silicosis. Okay, now what is this? This shows what is called your asbestos bodies. Asbestos bodies in sputum. When you take the sputum of a patient with asbestosis, you see this something like this. These are these brown things you see here. No, this is asbestos bodies. Seen as obviously asbestosis. Okay, asbestosis is very dangerous because it can directly cause many cancers, including the mesotheliomas and even other malignancies. Okay, so it's very notorious in that sense. Then, so now we are coming to the acts. Under occupational health, you should know about the ESI Act and major points about the Factories Act. Okay, so under ESI Act, sickness benefit is given for a period of 91 days. Okay, so I'll just write down some of the important points under the ESI Act so that you remember. You can quickly have a revision of the ESI Act. Okay, first point, what are the benefits under ESI Act? You can have direct. If one is direct, the other one, of course, indirect benefits, right? You have direct benefits and indirect benefits. Direct benefits is via the person who's enrolled in the ESI, he can go and get the benefits, treatment, everything from the ESI clinics. Indirect is via empaneled. If that is not available in the ESI clinic, then they can go for empaneled hospitals and then avail the benefits. That is your indirect benefit. Okay. Second one, financial. How is the financial distribution? See, the 75% of the wage should be given by the employee every month, and for the employer 3.25% of the wage by the employer. Okay, what is the benefit for the employer? You can show this for tax reduction and all that. So 3.25 by employer and 0.75 by the employee. Then what are the benefits? You have sickness benefit for 91 days. I think that was your question, right? Sickness benefit is given for a period of 91 days. So somebody is having a particular sickness, they have listed down what all are the sicknesses. So for that case, for 91 days, the ESI, the person enrolled in the ESI gets leave, but the salary will be up to 75% of wage he can get during this 91 days period. Then you have something called extended sickness benefit. For certain diseases, you are getting extended sickness benefit. So it's extended. So not 91 days, so it's for 2 years. Here you can get almost 80% of the wages, up to 80% of the wages. Then maternity for females who get pregnant, you have maternity benefit for 26 weeks for delivery. Okay, 26 weeks for delivery you get. Then if it's a case of MTP or an abortion, then the benefits is for 6 weeks. Okay, other than that you have what else? For funeral, if the person dies, for funeral expenses the family gets an amount of 15,000 rupees. Okay, these are all coming under your ESI Act. Now just like that, some points regarding your Factories Act. Factories Act. Okay, so under Factories Act, first point, it mainly talks about child labor. Okay, no child less than 14 years should be employed. If somebody less than 40 years is employed, that's a child labor, you will be punished. Okay, if the child is between 15 to 19 years, there is a list of appropriate working hours that can be work and the working hours. This is all coming under your Factories Act. This is Article 24 and this is Article 39 of Factories Act. Okay, next point is about space. At least 500 cubic feet space should be provided per worker. Okay, just like that, there should be a creche facility in a place where there are more than 30 workers. There should be a canteen. If there are more than 250 workers, then there should be a welfare office. Welfare officer in case of more than 500 workers. And finally, safety officer should be there if the place has more than 1,000 workers. Okay, so these are all important points under your ESI Act and your Factories Act. You can get questions like which of the following is not true, which of the following is true, like that regarding both these acts. Okay, so next one is about your lead poisoning. So useful screening test for lead is measurement of, so you have coproporphyrin in urine or CPU, then you have what is called aminolevulinic acid in urine, that is ALAU. Okay, then you have lead in urine and lead in blood. So all these are tests used for measuring lead, but they are specifically asked you which is the screening test. So out of these, coproporphyrin or CPU in urine is the screening test. So what about other tests? So CPU is a screening test employed, whereas the other tests are not screening tests. So what is the level of blood in urine? If the lead is more than 70 mg per deciliter in blood, this is the level where you will start, where the person will start to get signs and symptoms of lead toxicity. Okay. So if they are asking you the screening test, it's always CPU or coproporphyrin in urine. Now, these two pictures, what do they show? They show clinical manifestations of lead poisoning. There are different clinical manifestations of lead poisoning, which can be remembered using the mnemonic A, B, C, D, F, G, H, I. A is for anemia, B is for Burton's line basophilic stippling, C is for colicky pain, then E is for encephalopathy, D is for wrist drop and all you get. E, then what is the F is for, I think it's, fertility issues will be there, F. So like that you have mnemonic, just search, you can get it. But now what I want to show you here, you see this line here, over the gums you see a grayish blue line. This is called Burton's line, okay. This is characteristically seen in your lead poisoning. Just like that, this finding, the basophilic stippling is also, this is our basophilic stippling or punctate basophilia. This is also seen in your lead poisoning. So if you get images like this and you're asked to identify which is the metal involved, then it's lead. Okay. So next one, Kupusamy scale for socioeconomic status is based on. So Kupusamy scale is a scale used for socioeconomic status, and what are the what are the components of your Kupusamy scale? So Kupusamy scale basically measures three things, that is the income, occupation of the head of the family, and education of the head of the family. Okay. So total family income, then occupation of the head of the family and education of the head of the family. These are the measurements taken for assessing Kuppuswamy scale for socioeconomic classification. So what are the other scales of socioeconomic status of? There's something called BJ Prasad scale. Then there is an Uday Parikh scale. All these are also scales for socioeconomic status evaluation. Okay. Now we'll go on to the last question of this PSM final dash. Who is known as, or which of the following is known as the father of public health? So father of public health, again, very common question, most of you will be knowing. Father of public health is not a person, it's a disease. Cholera is known as the father of public health. Okay. So what are the other, diseases like this? We have fancy names, disease of measurement of, or, barometer of social welfare. Which disease is known as the barometer of social welfare? It is your tuberculosis. Okay. Then which disease is known as Slim's disease? It's your AIDS. HIV/AIDS is also known as Slim's disease. Then with black, you have, black death. Black death is plague. Whereas black disease or black fever, it's all Kala Azar. Kala Azar, right? Now, father of public health, cholera. What else you should know about cholera? Cholera, the story of Jon Snow, spot maps, it's all related to cholera. Okay. Sorry. Now, here I have just put a table with some of the important personalities and their contributions. So, Hippocrates is known as the first two epidemiologists, father of medicine. Then, John Snow is the father of epidemiology, handyman, homeopathy. James Lind, famous for scurvy. Edward Jenner, smallpox vaccination. Then, when was smallpox eradicated? It was eradicated in 1980, okay? Then, Robert Koch, you have caused postulates. Then, he founded the organism for anthrax, TB, cholera. Pasteur, pasteurization. Then first vaccine for rabies and anthrax by Louis Pasteur. See, the first vaccine was smallpox vaccine, which was founded by Edward Jenner, but the vaccine for rabies was by Louis Pasteur. Okay, so this you should know. Then finally, we'll as far as your exams are concerned, you should know the sustainable development goals. Okay, sustainable development goals, we have many goals. Out of that, the target 3 is the one for health. Okay, sorry, goal 3 is the one for health, and under goal 3 you have 3.1, 3.2, like 3.9 plus A, B, C, D. Okay, after that, some important things are the target 3.1, 3.2, 3.3, 3.4. How do you remember this? So 3.1 you have, so first point, goal 3 is for health. Out of the sustainable development goal, the goal related to health is goal number 3. Fine. Now, under goal number 3, you have different targets. So, how are you going to remember this? So, first, remember, every story starts with the mother. Only after the mother comes the child, right? So, your 3.1 is mother. Or 3.1 says that by 2030, we are aiming to reduce the maternal mortality rate less than 70. That's your 3.1. So, once the mother comes, second is the baby, right? So, 3.2 aims to reduce your neonatal mortality rate and infant mortality rate. Okay. Then you have 3.3, it is dealing with infectious diseases. So mother came, child came. So when the child is growing up, first he'll be getting infectious diseases, right? You agree with me? Cold, diarrhea, everything is infectious. After that, he'll develop, after a point of time, once he grows up, he develops non-infectious diseases. So 3.3 is regarding infectious diseases, 3.4 is regarding non-infectious diseases, 3.5, once the child develops, then, he starts, due to peer pressure and all that, he starts going for addictions. So addictions and all coming under 3.5. After that, if you do go for addictions, you end up in accidents. So road traffic accidents come in 3.6. Then 3.7 is related to, sexual health. Okay, 3.8 says about universal health coverage. And 3.9 finally is regarding pollution. Okay, roughly you should know an outline of at least the target saying MMR is 3.1, about your IMR and NMR is 3.2, infectious diseases 3.3. It actually says to end the epidemics of HIV, TB, malaria, and neglected tropical diseases. Okay, then you have 3.4 where you are aiming to decrease the early prenatal mortality rate because of NCDs, everything by 2030, at least to half. But only thing which you are aiming to reduce by 2020 is RTA, that is 3.6. We are aiming to reduce the deaths by RTA by 2020. Rest everything is for 2030. So SDGs are from started at 2015. We are aiming to achieve everything by 2030. Before SDG, you had something called Millennium Development Goals. Okay. Now, what is this? So, monkeypox global health emergency declared by WHO. I put this slide just to tell you about PHEIC. What is PHEIC? It is Public Health Emergency of International Concern. So WHO says that some of the diseases are public health emergency of international concern when the disease is a potentially disease is a disease which has the potential to spread across international borders, and it can cause panic public health issues. Plus, to control the disease, you need international cooperation. So such diseases, sometimes WHO says that okay, this is a disease of PHEIC. Recently, you have COVID and monkeypox. Both were declared as PHEIC by WHO. Initially, you had swine flu, Ebola, Zika. These are all declared as PHEICs, but recently you have COVID and monkeypox. Okay. So, with that, we are coming to the end of this NEET PG final dash. I hope this was useful to you. Please go and practice the PYQs. Try revising the most important tables, all the indicators, all the formulas, and all the important concepts. Please revise the previous year's questions. So, hard work. We have all worked such hard. You have all been consistently working so hard for your exams. So if you work hard, you are consistent, you have discipline, and if you have patience, you will definitely end up in success. Okay. So don't worry. All the best to all of you. I hope you all get your desired seat and desired ranks. Okay. With that, I'm concluding today's session. Thank you.